Hi, welcome to part 2 of this Big Data course video. So I have already made part 1 video. I have given the link in the description box of this video. So before continue watching this video, I highly recommend you to watch the part 1 video and then please continue part 2. Let's get into the topic.
Spark RDD. So before we get into Spark RDD, we just wanted to discuss few things and then we can go for what is RDD. Okay, so MPP. Okay, what is MPP? Massive Parallel Processing Technologies. What are all the massive parallel processing technology you are aware of? Yes, you know Spark is an MPP technology. In Hadoop, MapReduce is an MPP technology. We have Storm, Flink, all these big data technologies are MPP. That means doing the processing in parallel. So for that, first what you have to do is you have to first distribute the data and then only your technology can able to do the parallel processing. Now, I'm going to explain you some scenario here. I'm having 4 nodes. Okay, it's a Linux machine. Okay, and on top of this Linux, I'm installing Spark, and then I'm going to explain you some concept, and finally I will explain you RDD so that you will understand. And here I'm not installing HDFS and Hadoop is not installed. I'm just going to explain this RDD only with Spark. Okay, now I have a file in this first mission input file, so which I'm going to use for the processing, and this file size is 1 GB. Now in the very first line of my Spark code, I'll be writing a line to read the file. So what Spark will do, it will read this 1 GB file and then it will create partitions, a logical partitions. Okay, imagine this 1 GB file is split into 3 partitions. The partition is based on the partition logic what we use in the Spark. Okay, now imagine the Spark is reading this 1 GB file and then splitting into 3 partitions, and these 3 partitions will be get distributed across these 4 nodes. It's not mandatory, it has to be get distributed for all these 4 nodes. It could be 3 or even in the 2 nodes the 3 blocks can be get distributed, and I'm not using HDFS, I'm just speaking only with Spark. Okay, now imagine these 3 blocks are getting distributed in 3 nodes, and very importantly they are getting stored in memory, not in disk, or we are not using HDFS. It's just stored in the memory. It get distributed in memory and it get stored in the memory. Now you are writing a job, a Spark job, and these the Spark job will create tasks, and these tasks will be get running on these 3. So how many tasks I'm having, it's based on how many input blocks I have. Okay, now it's 3. Right, so I have already uploaded the Spark architecture video and what is Spark video, the kind of introduction, it's all there in my playlist, and I have given my playlist link in the description box of this video. Fine. So the architecture is not required for you to see, to understand the RDD, but still I recommend you to watch that, and then you can watch this RDD. Even without that, you can still understand this video. Okay. Now the job you are writing. Now in Spark, what you can do, you can write n number of transformations on top of the block. Okay, you are writing first transformation, and the output of first transformation you can do, you can give it as an input for the second transformation, and then the output of second transformation you can give it to third, and so on, so you can do, and finally you can store the output. Okay, and Spark records all these transformations whatever you are performing on the input data set. That we call it as data lineage. So it maintains the lineage. So which transformation happened before this, and which like a history, it maintains all the history, it knows the lineage. So the job itself holds the metadata of all these lineages, transformation lineages. Okay, and these lineages are maintained something called DAG, direct acyclic graph. It's a graph algorithm which is used to maintain the lineage, and this DAG is a separate topic we can discuss later point of time. Okay. Now, so this lineage, so why you started explaining this lineage? You may ask me this question, but I will tell you later. Now you are doing a first transformation. The transformation is, so imagine this B0 is a file. In the file, I have a number called 2. That's an input. Okay. So I'm reading the number 2 and I have to do +1. So this +1 is my transformation. Okay, so in all the file I'm having some number and I have to do +1. So imagine in B1 I have a number 3, I have to do +1. In B2 I have a number like 5, I have to do +1. Okay, now output 2 + 1 3, and then 3 + 1 4, and then 5 + 1 6. So this is the first transformation. Now again this 3 4 6 are your output, and this output will be get stored in the memory. Okay, so the default, the transformation output will be get stored in the memory. Okay, so this again a file, and this will be get partitioned, and this will be get distributed in the memory. The output also creates a partition, and then that will be again distributed. Now with this you can start your second transformation. The second transformation is I have to do +2 with all the output of the previous output. Okay, so that means here it is 6 plus 2, here it is 4 plus 2, and here it is 3 plus 2, and output 5, 6, and then 8. So second transformation is completed. So and so you can do it. Now imagine, for example, I got an issue. Okay, so I got an issue like this 4, right? The output of the first transformation is gone, so that I couldn't start my second transformation. Okay, the output is gone. So it's lost due to some memory corruption or something happened in my cluster. Now how Spark will handle this? So whether Spark, since this particular output is gone, this task will be failed, or this, since this task is failed, my entire job, that is other running task, also will be failed. So this is a question you may ask me. So Spark will not fail any of your jobs because of one task failure, because for Spark can able to tolerate the fault. Okay, we call it as fault tolerance. Okay, so how Spark is tolerating the fault, I will tell you. So since Spark maintains the lineage, if this particular output is gone, it will try to find out what was the previous transformation, because it maintains the lineage. So it find out this is the transformation, so it will recompute this. Recompute means it will rerun the task once again, so you will get the output again, and then it will give the output to the second transformation, so that you will not get any job failure due to a particular task got failed. It will be get recomputed automatically. Okay, so here fault tolerant is handled. Now the next thing is, people used to ask me, how about replication? Because in HDFS and MapReduce and all, we have replication, right? So how about the replication here? Okay, so Spark also supports replication in storing the output of a transformation, and we call that as persist. So persist is again a different topic. I will explain you. Persist means where to store the output of each transformation, and that is called persist. We have to persist somewhere. You have some types like you have some persist type in which you can decide whether you can store your output of a transformation in a memory or in disk, or both memory and disk. So something like that, you have some types. I will explain you in a separate topic. So in this persist type, there is a type called memory underscore only underscore 2. That means your output will be get stored as 2 copies. Okay, so here this 4, imagine with this first transformation, I'm invoking this persist method memory only underscore 2, and that means the output 4 will be get copied one more time somewhere in another machine, for example here. So that means if this 4 is lost, instead of recomputing, it will take this replica and then it will continue the second transformation, so that the recomputation time is saved here. Okay, so but again, it's completely depends on the use case, whether to you have the replication or not. You have to decide, because the replicated data also gets stored in the memory. Memory is very important. Memory is something RAM, right? So in my use case, right, so far I haven't used this replication in the memory. So because the memory is very important, so other jobs should not be get impacted due to this replication stuff. So even the recompute is very faster. So I don't want to go for replica. So that is my use case and my performance stuff based on my infrastructure. But again, it's depends on your case and your infrastructure. So you have to decide this. So all these concepts, what we have seen is RDD. Okay, and finally I'm coming to the point. RDD. Resilient distributed dataset. I repeat, resilient distributed dataset. Last D, dataset. Dataset means the input data file. It could be CSV or JSON or Avro, whatever, the dataset, right? So that is called D for dataset. And the second D, distributed, and that means your data will be created in partition and then that will be get distributed, right? So that is D. And R is very important, fault tolerant. How Spark is tolerating the fault. So Spark is using data lineage with DAG, So data lineage with DAG, and then it is identifying the previous transformation and it is recomputing it. That means the DAG. So this data lineage we understood, right? But DAG is something I will explain you in my upcoming videos. So fault tolerant. So whatever you do, any transformations that you do in Spark, we call it as RDD. If you take map as a transformation, it's an RDD. Filter is a transformation, it's an RDD. Each and every transformation that you use in Spark has the concept of this RDD. Okay, similar to RDD, we have two more things in Spark called data frame, and then there is one more called a data set. It's like a next version. So data frame is next version of RDD and data set is next version of data frame. But underlying all these three, the main thing, all these three different APIs, what it is doing is RDD only. All these three, internally it's an RDD, but it's just an upgraded version, data frame and data set. So we can see these data frame and data set also in my upcoming video, and the difference between these three also we can see. But underlying all these three, what it will do is the concept what I have explained you. And all your syntaxes will change. So in RDD, the syntax will little bit different from data frame, and that is different from data set. But underlying concept is again RDD for all the transformations. And if you take RDD, the operations of RDD splits into two, called a transformation and then action. Okay, so if you use RDD to write a program, and then you will be using this transformation and action, and I will explain you what is these two things in my upcoming video about how to create Spark RDD and what are all the ways to create and Spark RDD. So there is totally three ways are there to create an RDD. The very first one is parallelized collection. Okay, so in Scala or in Java or in Python, you have a collection. It could be a set, or it could be a sequence or a list or an array. Now I want to convert that to an RDD. How to do that? So there is a function called parallelized. If you read an array or a sequence or a list via the function parallelized, then it's turned to an RDD. Now if you see this array, I'm converting this array to an RDD by using this parallelize. So I'm running this command. So after running this, I'm gonna do an action. I'm going to perform an action. So collect will work only if the particular RDD variable is actually an RDD. Only the collect will work. So it's working. So that means RDD1, the variable, is actually an RDD now because we used that parallelize, right? So it has been converted. So what parallelize will do, it actually Spark will parallelize your data into the Spark cluster, and that means your data is eligible for to be and to become an RDD. Now if what parallelize, what it is actually doing, Spark, when I say Spark is parallelizing your data, it's creating partitions for your data. So if you want to specify your own partition count, that you can do by just mentioning here (2) or (3). So that means that many partitions will be get created. Okay, so this is one way to create an RDD, which by using parallelized function. The next one is from the external data set. Okay, you have a file, you have a text file, CSV, JSON, or Avro file, or ORC file, whatever files you have a file in, either it could be in HDFS or your local file system, or it could be in S3 or any other distributed or standalone file systems. Okay, now I want to read a file, an external source, and that means when you read a file via Spark read command, then that particular file will be turned as an RDD, so that you can apply all RDD transformations, data frames, data sets, and even actions. Okay, so now I'm going to read a text file. Like that, you can even read JSON or Avro files also. Now this RDD2 is actually an RDD because I use Spark read command to read a file. Now the file has been converted to an RDD. Now you can do all transformation on top of that file. So now I'm going to do RDD2.collect. So as I told you, collect will work only on the RDD variables. Yeah, it's working. I can able to see my data, right? So this is the second way to do. And the third way is creating an RDD from an existing RDD. So for example, if you take a word count program, first I'm reading a file, that means RDD3 is actually an RDD now because I'm reading a file via Spark, so my file is an RDD now. Now with that file, I'm going to apply a transformation flat map and split by and that gets stored in the variable split data. Now split data is an RDD. Now on top of split data, again I'm going to apply a map function and assigning to map data. Now map data is an RDD. That means I'm creating an split data RDD from RDD3, and then I'm creating map data RDD from split data. Okay, so creating an RDD from an existing RDD. Okay, so now I'm just running this code. No, it's not the full word count, it's just a partial one. The agenda is just to show you to create a new RDD from the existing one. Yeah, you can see the output, right? So still the map output I'm getting. So the agenda of video is completed. So that there are three ways to create an RDD about transformation and action in Spark. So now we are going to deep dive into the Spark transformation and actions. So with respect to RDD, it has two major operations, which we call it as transformation and then action. Okay, and action. In Spark, we do all whatever we do with data is transformations, right? So you have to filter something, you have to do join, or you have to aggregate, or you have to map something. So everything we call it as a transformations, right? So and action. So what is action? So I want to perform something. So you perform some transformation, and finally you have to do some action. For example, I have to print it, or I have to save to a file. So something like that, if you do, we call them as action. So if you are very new to Spark and you have a question, so how can I, by seeing the code, how can I say this particular function or piece of code is transformation, or this particular function or piece is an action? But that is something you can easily able to understand once you start doing your code activities. So for example, I will give you some transformations example here. So map is a transformation. By seeing that, I can say, yeah, map is a transformation, and then filter is a transformation, etc. And in action, we have something like collect. So collect will collect the data. It's similar to the print statement. Show, we have something called show, and then there is something called save as file. So save as file is something you save your output to a file. So by seeing this, yeah, we can say, yeah, this is the action. Okay, and Spark RDD has an advantage called lazy evaluation. What does that mean? Okay, people are very familiar with this. If you are very familiar, yeah, maybe you can skip like 40 to 50 seconds of this video from now. So for others, I'm gonna tell you what is lazy evaluation. So in Spark, in map reduce, there is only two transformation, map reduce, that's it. But here we do have a lot of transformations, right? So the lazy evaluation is all about, in Spark, you are writing a program. Imagine you are reading a file and then you are doing a map operation on top of it, and you are making it as a key value pair or whatever you want, and then you are applying a filter, and finally you are performing an action like save as file. You want to save this in HDFS or somewhere in your Linux. So now if you run this first three, right, in your Spark shell or even in the IDE, when you run it, so what the compiler will do is it won't do anything. So when there is an action, only then the compiler will start your transformation. So that means the bottom to top. So that we call it as a lazy evaluation. You can ask me why they have designed in that way. See, I'm using some memory, for example, 20 MB to read, 50 MB memory to read, sorry, map, and then like 100 MB to filter. And finally, you are not doing anything. And that means, why should I have to use all these resources and do all the transformation for you? Compiler is asking you, when like, why should I have to do all these transformations, and finally you are not doing any action. That means, why should I have to waste my resource by doing the transformation? So here Spark has been designed in a way, we can call it as an intelligent way, that your compiler will check in your code whether there is a piece of action mentioned or not. If it is not mentioned, your Spark job will not start. Only when it finds the action, it will start your very first transformations. Okay, fine. So now in transformation, we have again two types. We call it as narrow transformation, and then one is narrow and another one is wide transformation. And again, a same question you may get in your mind. By seeing the transformation, how can I differentiate it whether it is narrow or wide? So that is the next question for you. So for this, I'm going to explain you with some example, and we do have a practical as well. So I'm going to give you an example. Let me delete this. Okay, so imagine you have four tasks. Okay, you have four tasks. Your first thing, you are reading a file. Okay, so read is my first transformation. So you read a file, and the output is your file. And on top of this output, the file which you have read, on top of it you are applying a map operation. Okay, this is your map output. Okay, and then again you are making a filter operation. Okay, so this is your filter output. Okay, now if you see here, all these are one-to-one, right? It's the mapping is similar, like one-to-one mapping. So read, map, filter, we call them as one-to-one mapping, and if it is one-to-one, and we call them as narrow transformations. And I will explain you the wide. Before that, if you take map reduce, right? So you have like 3 mappers and 2 reducer in map reduce world. Okay, so imagine this mapper may or may not can send the output of mapper to both the reducer when there is a condition to send them to both the reducer, right? And the second mapper, again, it will send out part of output to first reducer and second reducer. And again, the third mapper again may or may not can send its output to both the reducer when the logic, well, what are the condition you have written in the reducer, based on that it will share the data to this mapper is sharing the data to both the reducer. So here what you see is shuffling. In map reduce we call something between map and reduce is shuffle. Shuffle is a core part in map reduce, the heart piece, right? So imagine the same thing happens here. Now finally, in the reducer, how you will increase the task of reducer. In map reduce code, we can set the count 2, 3, like that we can increase, or even we can decrease. And similar to that in Spark also, the final aggregation part you can decrease and increase. And we do that via repartition. There is a function called repartition. With that you can able to increase your output task, okay, or you can decrease, okay, but for that we use Coalesce, but Coalesce, repartition and all I will explain you in my upcoming videos. Now imagine I just wanted to run my aggregation part in 2 tasks, not as 4 or 5 tasks, but it's again up to the coder's decision. So here we call the final thing as reducer, but here I can't use that word because we do have so many other transformations, not only reducer. So that's why I'm trying to avoid that word when I'm explaining you the same in Spark. Okay, I'm having 2 output aggregation tasks, and what you are going to do here, I'm going to do something called group by key. I'm just want to group all the outputs. Now I'm just doing a word count. Just imagine I'm just doing a word count operation. So I have hi here, and then hello. Okay, and then here I have hi again, and I'm having w. Okay, and here again I'm having hi, and here I'm having hello, and then here again I'm having hi, and again w. Now, so I need all words hi and w to my first task of the group by key, or in map reduce term, if I want to say, I need hi and w count to my first reducer and hello to my second reducer. Okay, so that means this particular mapper will send hi to this mapper, and this particular mapper will send hi and w to this reducer because it has both, right? Our condition is we have to send hi and w to this, and even if you take third, it has hi, so it is sending only the hi, and here hi and w, so it has to send both. And if you take the first mapper, again it is sending hello to this node because it has hello, whereas in second task we don't need it, and third, yes, it has hello. And in fourth, again we don't want it because it doesn't have hello. So what happens here is shuffle. So this before reaching to this reducer, all these mapper outputs like this one and this one and this one and this one, because all these mapper has, all these task has hi, it's group all the hi and send and all the w and send it to my first reducer, and that means shuffling. What is shuffling? In MapReduce we used to say group by key, sort by key. Yeah, exactly the same thing happens in Spark as well, shuffle. So a shuffle means the data movement is happening from one node to another node, right? So this is also a transformation, but this transformation requires a shuffling. But if you see, these three is also a transformation, but there is no shuffling required. It's just one-to-one. So the transformation which doesn't have a shuffle, we call them as narrow transformation, and the transformation which has shuffle, which we call it as wide transformation. So that is the difference between wide and narrow transformation. Now by seeing a transformation list, you can still able to say this transformation is narrow and this is wide, so which is easy. I will show you that. I will show you more transformation and action list for you. Okay, so you can see here all these transformations are one-to-one and they are narrow, and if you see all these transformation require shuffling, so we call them as wide transformation, and all these are actions. Okay, now I will explain you with the word count program. Yeah, I have already explained a word count program, but not with this respective context. Okay, I'm explaining you with this now. So first I'm going to explain this. If you see here, I'm reading a file which is an arrow transformation, then I'm doing a flat map to do a split operation, which is again an arrow transformation, and map I want to split it to key value pair, which is again an arrow. So I will copy this, I will just run it here. Okay, so I have executed all the narrow transformation, and I have already the jobs page of Spark. So you can see one completed job. This is something I have already done. Okay, this is not the one which we are running now. So if you refresh here, nothing happens. See, we have executed one line, right? But we didn't get any new job for it, right? So I'm explaining you the lazy evaluation now. So now the next thing, I'm going to trigger the reduce by, which is the aggregation. That means this is called wide transformation. I'm executing this as well. And if I again refresh the page, I'm not getting any new job, because as I told you, only when the compiler checks for the action in the code, then only your job will get start. And now I'm going to invoke an action. So here the last one is B, right? So B dot collect. Okay, if I do this, I will able to see the output. You can able to see here, and channel is 2. Now if I refresh this particular thing, yeah, now I can able to see 2 jobs, right? So the one, yeah, this one is latest. So so only when I trigger the action, I can able to see the job getting started and it's get completed. Now I click this. So if I click this, I can able to see the DAG. Okay, for DAG I have a separate video. So the main use of DAG is for each and every transformation what you trigger, Spark will maintain a data lineage. It maintains what transformation happened before, what happened, what is going to happen next. So it maintains all the information. So in between, if some transformation is failed or data loss happened, it will recompute from the previous transformation. So to maintain all this, it maintains, we call them as a data lineage to avoid fault tolerant. They are doing this. For this we need a DAG for sure. Okay, but again I'm going to make a separate video for DAG. But if the video is not available, please wait, I will upload soon. But just I'm giving a heads up of what is DAG. So if you see here, we have 2 stages. Okay, so here stage 2 and stage 3. So if you see in stage 2, we have reading a file and then flat map and map. And in stage 2, we have reduce by key. You can ask me why reduce by key has moved to a second stage. That means a different stage. I will tell you that. See, how the stages will work. So for every narrow transformation, so if I'm having 5 narrow transformations, means for all 5 narrow transformation, the stage will be 1. When the DAG finds there is a wide transformation, right, then it will cut here, it will create a new stage for this, and it will name it as stage 2 or sorry, stage 1. So whenever there is a wide and narrow transformation, the stages will split. Okay, so and that's the reason I can able to see 2 stages here. Okay, now I will just go for this second stage. That means the first stage. Okay, so why it is not 0 and 1 or 1 and 2? Because already one job created with the 0 and 1 stage. That's why this job, the stage name is 2 and 3. Okay, don't get confused. So I'll go with this stage 2. I will click this. You can see here in first stage reading a text file, and then we did a map operation, flat map, and again a map, right? Now I'm going back and I click the second stage, which is collect. Okay, which is third stage. Okay, 2 and 3. So if you see here, it is mentioned as shuffle RDD. That means since this particular transformation is shuffle operation, it created a new stage. Okay, so in this video we have we discussed about the transformation and its types, and also the lazy evaluation part, and we discussed about the DAG as well, right? These 4 properties which we used to set in Spark submit command during execution, right? So these 4 properties are very important for your Spark application when you do a Spark submit. And today we are going to just discuss what these properties are all about, and for we used to give values for these properties, but I have made a separate video how to calculate those values. So I have given that video link in the description box of this video. I recommend you to watch that video after this. Fine. So now imagine you have a cluster. Okay, so you have some 6 node of cluster. So you have 5 plus 1 6. Now let's let's say like we do have some input data, and these data has been partitioned in Spark. So while reading it will do a partition, and on top of these partitions your input data will be get splitted into small partition, and for these partition the task will be get created based on what program that you have written. And these task is nothing but the code what you have written has been splitted into small tasks, and these tasks will be get executed on top of the partition in parallel. Fine. Now what about executor? Now imagine this executor is just a JVM. Imagine it's just a kind of a container. Okay, so what this container will do, it will just, this executor will get created in any one of your node. For example, you take this node. Okay, so now an executor got created within this node. Okay, so executor 1. Okay, so what this executor will do, this executor will create tasks. So task 1, task 2, task 3, etc. Oh, imagine it creates 5 tasks within this executor. So this executor is just a JVM, and this executor has a memory. Within that given memory, executor will create these tasks, and these tasks is nothing but the code what you have written. So that code is get executed as small task on top of your input data, which is got partitioned already. So here this number of tasks within this executor, like for example I have 5 tasks, and whether all these 5 tasks will run in parallel or one by one or sequential. Now the answer is, if you take this executor cores, so core is nothing but the CPU. Okay, the CPU, we have like a quad core, i3 core, right? So core processor. So core is nothing but it's a CPU. Fine. So here this executor core will have a value. For example, if I give value as 3, that means this particular executor can run 3 tasks at same time in parallel. Now if you give, this executor can have so many tasks, but this executor at a given time, the executor can run only 3 parallel tasks. For example, if I give 5 here, now this executor can run 5 parallel tasks at the same time. So what happens if this particular executor cannot run all the 5 at the same time? So even though you have given 5 here, but still this particular executor doesn't have the capacity or the resource to run all the 5 in parallel. In that case, what it will do, right? Imagine now executor has resource to run 3 tasks at parallel, but you have given 5 here. So what it will do, it will create 5 tasks, but it will run only 3 in parallel first. So once this is completed or some other task completed and the resource got free, these 2 will get picked up. Okay, so whatever you are giving here, we are just informing the executor can run 5 tasks at maximum in parallel. So if the resource is not ready, then executor will understand on its own and it will just run as much as possible. It will run in parallel, and the remaining task will be in queue. Now this executor core, whatever the executor core value you are giving, which is denoting the number of maximum tasks that an executor can run in parallel. So executor is a JVM, it's a container. Within that your task will be get executed. Now this executor needs some memory to allocate for all these tasks, right? And that is what we are giving it an executor memory. Okay, and number of executor is something you have to decide how many executor you need. For example, I need 10 executor to complete this job, and each executor can have 5 tasks at maximum run in parallel. Then 10 into 5, totally you will be having 50 tasks. Okay, so this 10 executor, so how this executor will be get created in the slave nodes, that is worker nodes. Imagine this first node can have 1 executor, maybe the third node can have executor 3 and executor 7. That means same node can have more than 1 executors. Okay, so I have explained this concepts recently to some of my friends, and they have asked me this question. They asked me like this: so when I give number of executor as 10, each node will have 10 executor? No, that is wrong. When you give number of executor as 10, that is for your cluster. It's not for each node. So for that particular job, the application, you need a 10 executor, and this 10 executor will be get created across the cluster, across the nodes in the cluster. So this executor, this node can have 1 executor, this node can have 2 executor, and this node can be empty, and next node can have 1 executor, like 8 executor 8, something like that. So each executor is a container which will have group of tasks, and this task can be like we can determine like how many parallel tasks can run with this property executor core. So core is nothing but the CPU allocation that you are giving for your task. Okay. So now at finally we are coming to driver memory. So what is driver memory? So you have a main method in your code, right? So this main, we call it as a driver. So when you do a Spark submit, okay, so when you do a Spark submit, the driver will be get created. So the mission from which you are sending a Spark submit, the driver will be get created. So this driver will communicate with the master. So if it is a Spark, then master. If it is Yarn, then it communicates with the application master. And this driver, what it will do, right? So this particular driver will communicate with the master or application master, and then it will coordinate the jobs, that the task which is running in parallel in the slave nodes. So once it is completed, the driver will be also get it will be also get completed, and then your code will come out, means your job will come out, and then you will be getting the output. Now this driver memory is something that is very important when there is no complex or not recommended actions. For example, if you use collect or take, what it will do, so the driver will be get running in one node. Okay, so when you give collect or take, what it will do, right, it will just get all the data from the total number of slaves. For example, each node is processing some 1 GB of data, and finally, like, you are getting all these data, like 5 nodes are processing your input data, and each node is processing, each executor is processing 1 GB, and that means finally you will be getting 5 GB, and you are bringing all these 5 GB with the using collect action. What it will do, right, if you use collect, what it will do, right, it will bring all these 5 GB data to your driver, which is running in one node. And for driver memory for this program, if you give just 2 GB, right, it will fail, because you are bringing all the 5 GB of data to one place, which is your driver. So this driver is runs in a one node, and you can ask me whether all the actions, or like it will run all the actions will be getting the data to driver. No, it's not like that. We do have something like save as text file. This action will run in parallel, you don't worry. Okay, so for this and all, you can give, for driver memory, you can give 1 GB to 2 GB is wide enough. Okay, only actions, the dangerous actions like collect or take, will bring the complete data to the driver. So don't use such actions. So we do have some usage of those two, but I will explain that in a different video, when to use and when you should not. So for now, driver memory is something that you are giving us just to coordinate your tasks with master. Okay, how to calculate Spark memory properties. So in Spark, after you develop your program, you have to create the jar file, and then by using Spark submit command, we have to submit the jar file in Yarn cluster mode. Right. So during that time, we used to pass few memory properties like driver memory, executor memory, number of cores, and number of executors. And we do have some calculation to calculate that, because many of the people have the confusion of like what numbers I have to give for those memory properties. And it's not like I can give 10 GB, 20 GB, or even 5 GB. It's not like that. We can't go something like that in very dynamic way, because there is some calculations we have to do. So when we run Spark job, there is some monitoring tools like Spark Lens, which will be like integrated with your code. So what Spark Lens will do, right, it will inform to the admin or the people whoever manages the cluster that this particular program supposed to use 5 GB, but instead it is using 10 GB memory. So that means you are locking extra 10 GB memory in your code. So the resource has been locked. So that is a problem. Then the administrators will raise a question to the developer, why you are using extra 5 GB RAM. So by the time I cannot say like I'm not sure, like I don't know how to specify. So for solving this problem, there is a calculation you can use it. It will be like not 100% accurate one, but still it will be more or less it will be there. So it's always good to do that. So let's get into the topic. And in Spark there is an option called DRA, dynamic resource allocation, where Spark will take care of allocating the memory on its own, but that is not highly recommended for real-time use cases and heavy volume of data. Okay, so don't go with DRA, where Spark itself will take care of all the memory properties. Please don't go for it. So now there is a scenario we can go for it. We have 6 nodes, okay, 6 nodes, and each node have 15 cores and then 64 GB of RAM. I'm saying this calculation for real time only. It's not for our personal example or personal laptop. In personal laptop, you have a Spark cluster and you're running your program with test data. So it's not for that. It's for the real time. Okay, so now cores. So what is cores? The number of concurrent tasks that can be executed in each node. So here I'm having total 15 cores. So as a decent count, I go with 5. Okay, so that means at a time 5 the particular task assigned to a particular node where the data exists at the when the task got assigned. So at a time 5 parallel task can be get triggered? Okay, so I'm going with 5. You can ask me how you decided this 5. So the 5 is something I'm deciding based on the total number of cores. I'm just dividing it to 3 or 2, something like that. Okay, I go with 5. Now equal number of, I'm just doing some divides. Okay, now it is 5. For example, we have given 5 parallel tasks for each executor. So when in your slave node, executor will be get created first, and then your tasks will be created. The task is what, and as an executor, how many parallel tasks I can launch. So that is what this course is all about. An executor can launch 5 cores in parallel. So now the question is, so how many executors I can have? Okay, that is the next question. So number of core is 5 and number of executor is 15 is total number of cores, divide by 5 is number of cores that you have decided. So total 3 executors can be launched in a node. So if you see here, you have node 1. In node 1, you have 3 executors, and each of this executor have 5 tasks. It can have 5 parallel tasks at a time. Now imagine only 2 tasks is required by executor 1, then it will launch only 2. If it is 3, then parallelly it will launch 3. Now the executor 1 requires 10 tasks, then that means for the executor 1 will first trigger 5 parallel tasks. Once that is completed, it will trigger the next 5. It will be in that way. Okay, so 100% parallelism within a node is not that much easy to achieve. Okay, if you go for any parallelism technology, we call MPP, right? Massive parallel processing technology, Storm, Spark, MapReduce. It's not that much possible to always achieve 100% parallelism. Okay, so between node is parallelism. Similar to that, even in a single node, the tasks should run in parallel. Sorry. Now, executor per node. Okay, 3. Now the next thing is how much memory an executor can have. This is a very important thing. So total is 64 GB. Divide by 3 executor per node. So that means you will be getting around 21 GB of RAM. Sorry again. So 21 GB of RAM is something you can allocate for the particular Spark job. Now you are deploying this in Yarn, right? So Yarn should have some memory to deploy your job in the cluster. So Yarn needs some memory. So it is recommended to give 1 or 2 GB for your Yarn. Okay, there is a property that you have to set it in Spark submit while triggering the command. So there you can give 1 or 2 GB. So that means 18 GB you can give for your Spark job. And keep in mind that this last line, as a disclaimer, I'm telling you, the 18 GB what you get as an output is imagine that as a max memory that you can have for the job. So starts from minimum 5 to 18. Decide between you have to decide one number between this 5 to 18. So that is something you have to take care. So we always used to go in a decent. I can recommend you to 5 to 10. Or 5 to 15 GB is okay, not more than that, because 18 is max you can give and 5 is a decent, is always minimum you can go with it. And driver memory is similar to your executor memory. Whatever you give for executor memory, you can give the same for your driver memory. 8 GB. So there is no special calculation for driver memory and all. Driver is like main method and which will trigger the Spark context, right? Yeah, so this is what the exact formula. So based on this, you can trigger a job, and then when you check for some monitoring tool like Spark Lens, it will be somewhat accurate. Yeah. So thanks for watching a2zknowledge.com and my channel Data Engineering, and that's all about. The topic is over. About the Spark submit. So how to deploy a code, Spark code via Spark submit. And before getting into that, we're gonna discuss about how to build a jar file for the code. So how to do the IDE setup. So like Eclipse, it could be IntelliJ. So how to do an Eclipse or IntelliJ, the IDE setup, and then how to create a jar file, and then how to deploy that in cluster mode with Yarn and without Yarn. Okay, so this is what we're gonna discuss today. So here I have a sample code which is just a word count. So the agenda is not about the code. The agenda is about the way how we submit the job. Okay, so here is the word count program. So I will explain you how to create a project. So here we are going to use a Maven project, not a normal project. Okay, and this process you can use for both Java and Scala, but I'm going to show you Scala here. So you can go ahead with file, new, and you will be seeing an option other. So here you have to choose Maven project, and then next. So here you have option create a simple project. So just click this, and then next. And here we can give some names. So I'll go with the test and then artifact ID as test. It's like a project name that we give. So like group ID and artifact ID is important when we go for Maven project structure. So Maven is a build tool which we are already aware. So if people are new for Maven, just Google it. What is Maven? So Maven is a place where we don't want to worry about collecting the libraries to resolve the dependency problems in the code. The Maven will take care. If we just mention what version of Spark libraries are required, just mention that only. So Maven itself will download the libraries from the central Maven repository in behalf of you, and then it will create a local path in your machine. It will store all the libraries, whatever we mention it to the Maven project. I will show you everything. So now click finish. So whenever we create a Maven project, it is by default, it will be like Java. So if you see here in the folder, you can see a small m, right? A small m and then J. So Maven, J for Java. But if you see the remaining two projects above to the test, you can see M and S. So that means S for Scala. So by default, Maven is a Java project. So you can change the structure of this. So before I just forget to mention one thing, you have to download the Eclipse called Scala Eclipse. So you have to download that from the Eclipse website. It is there, an Eclipse for Scala. So where you can write a code for both Scala as well as Java. So here now we have to change the structure of Java to Scala. So just right click and there will be an option called configure, and then you can give add Scala structure. So after this you can see Scala library will be get added. Before we had only JRE, but now we got this Scala library as well. So the Spark version what I am currently using is 2.4. So my Scala version should be 2.11. It should not be 2.12. You have to match that before you start writing your code. So two things I have to change. I have to change my JDK version and then I have to change my Scala version. So go right click, properties, and Java build path. Just click this option and you can see here first we can change the JDK. It should be JDK 1.8. So I'll go for alternate JRE. I have already installed JDK 1.8 in my local machine, so I have to browse that directory. So go for installed JRE. As you can see, I have already added the JDK which is installed in my home folder. If you want to do it newly, I will show you how. You have the option add and then you have to click the standard JVM, next, and just browse your JDK directory. So in my home, so if you see in my home, I'm having my JDK here. So it is here JDK 1.8.0 underscore 45. Just click OK. So what it will do, it will bring all the libraries of JDK here, and then you have to give finish, but I'm giving cancel because I have already added it. So it will be here. Then you can click the one which you added and give apply and close. And now in the drop down list, you can able to see your JDK. Just choose this, finish. So you are changing your JDK. Now we have to change our Scala library as well. Just click this, edit, and then you will be seeing 2.11. Click finish. Yes, apply and close. So now the versions has been changed. Now you can just, I will share you this code and I will share you this code. You can just copy paste this code and you can add it over there. So if you see, this is the code that I have already builded here. So this is my actual code. You can see here. Yeah, so my code is here. Okay, so now what is the next important thing is pom.xml. So pom.xml is a place where you have to mention all the dependency information, like which version of Scala libraries or Spark libraries or Hive library or Hadoop library you want to download from the internet. Means Maven will download it for you, but for Maven you have to inform which version of these dependencies are required. So for our code as of now we need only Spark. So if you see, I will just show you my pom.xml of my previous project. So in pom.xml I've just added, so these things you will be seeing default. So you can see, like, I have added this dependency. It has to be, so I will share this pom.xml also. So this information will be there in the description box of the video, where I will be giving the links for all this. Okay, so 2.4 is my Spark version, and then Spark core is what required for this program. So I've just added only this, and this 2.11 is denoting the Scala version of the Spark 2.4. Okay, don't get confused. And one more thing I have to add here is this piece. So I have to build the jar file. So Maven will build the jar file for you. So to do that means for Maven, when it build a jar file for you, it will build the jar file only for the code, not for the dependencies. Okay, so if you want to build the code along with the dependencies what you have added the Spark core, then you have to add this piece. If you add this piece, then only Maven will build your jar file with code and dependency, so that you will not get any error when you run it in the terminal in the runtime. So to do that, you have to add this. You have to give the entire package name dot class name, and then in the description you can give jar with dependency, so that the Maven will build a jar with dependencies. Okay, so once this is done, what you have to do is right click, run as Maven clean, and then Maven install. So so when this jar file will be get created by Maven, so when you give Maven install, and you can see there is a target folder here. So under this target folder, the jar files will be get created by Maven. So you can see this is what Maven will create by default. So this is without dependency, but if you see this jar file, it has with the dependency. So for this only we have added this properties here. Okay, so now I'm gonna do Maven clean. When I give Maven clean, what will happen, right? It will delete the jar files. So e- each and every small changes what you do in the code, you have to do a Maven clean and then Maven install. Sometimes what people will do, they will just do some changes in the code, but they forget to do the Maven clean and install. That means the new jar file will not be get created. So the code is new, but the jar is old. So still they will get the same error. So whenever you do changes here, you have to clean the Maven, run as Maven clean. So this will delete the target folder itself. You can able to see here. Okay, so the target folder is gone. Now right click, run as Maven install. So this will create the target folder, and the jar file will be there. Okay, and in the code you can see I'm going to read the input file from HDFS, not from local, and then the final output of word count I'm writing it back to HDFS. Okay, and one more thing, I'm giving this set jar. Okay, so this set jar is nothing but the jar file which the Maven will create for you, the with dependency one. I'm giving the entire path here. The reason, if I remove this, I'm getting some logging issue, and that's why I've just added this in the code. Okay, so I'm not sure like what was the error, but when I add it, it is working fine. So and that's the reason I've just added this set jar here. There is nothing new for you to for me to explain to you, because word count program is very familiar for you people. The only thing I want to say, this set jar, why I'm giving this, and then the input is HDFS and output is writing to HDFS. So the jar file is done, build success. Now the target folder is created. You can able to see the jar file got created. Now we can go with the command to execute this. So Spark submit ---- class, you have to give your package name dot class name and master yarn, and then deploy mode is cluster, and then I'm giving my executor as one, and again you want to give driver memory, executor memory, driver core, executor core, it's up to your choice. I'm not giving those other memory properties, I'm giving only the executor, and then the jar file name here. So if you want to run it yarn, you have to give yarn here. No, I'm not going to run this on yarn. I'm going to run it on Spark standalone cluster. That means without yarn. Then what you have to do, you have to remove this yarn here. Instead, you have to give your Spark master URL. So Spark master URL means start your Spark daemons and then go to localhost 8080. You will be seeing an URL here. This is your Spark master URL. Okay, so after master you have to paste this. If you don't want yarn means, no, I'm going to deploy this in yarn, then you have to go with yarn here. So that means you need to start both Hadoop daemons and Spark daemons before running this command, because you are running it on yarn, so you need Hadoop. Okay, now copy this and then go to terminal and then just paste it from the Spark folder, so the job gets started. So since I'm submitting this in yarn, right, so I have to monitor the job in yarn URL. So yarn URL is 8088, which is your resource manager URL. So okay, so the job gets started. So let's give some time for the job to get initialized. So once it is initialized, we can able to monitor in the yarn. So 008 was the last one. So now it has, the job ID should end with 009. Yeah, okay. So 009, and it is an accepted state. Okay, in the terminal it is an accepted state. So accepted state, and then it will be moving to running and then finish. If it is failed, then it will be failed. So there is 4 states. I just wanted to tell you that there is a four states in Spark. So now it's an accept, then it will be in running. Yeah, it's in running. So if there is no error, then it will be finished. So I will refresh this again. So now it's accepted will be get changed to running. So once it is finished, right, so we'll be getting the output in HDFS, not in local, okay, because my input is HDFS and output is also in HDFS now. Yeah, you can even mention without, okay, it is finished, and you can even, without this information, you can give local path also, and you can run it in Spark mode without yarn, it will work. So let me do an ls quickly. So what is my output folder directory name is word output 2. Okay, is there a directory? Let's see. Okay, so it is here. Okay, word output 2. Let me do a cat. Hadoop FS. Okay, it's Hadoop cat, not local cat. I'm sorry. Okay. So ls word output 2. So I have not given any repartition. So if you see like it is created as 2. If you want only one, then you have to go for repartition. So but I didn't go for it. I just leave it with the default one, cat. Okay, I will just show you one partition. So this is hello to and welcome to. Let me show you my input. It's again in HDFS, right? So this is my input and I'm getting my output hello and welcome, and the remaining is hi will be in the another partition. Okay, about Spark Lens. So Spark Lens is a product which is called a profiling tool, which was invented by the company and the team members belongs to Cobol. Cobol is a company where like they give a lot of cloud related solutions and big data solutions as well as a service. So now I'm going to explain you how to integrate the Spark Lens with your Spark program, and Spark Lens is completely free and the source code is available in the GitHub, so you can just Google it, so you will get the link. So let me give you an quick intro again. So profiling tool. So what is mean by the profiling tool? So profiling is all about when you run your Spark job, you have to define the memory properties, right? So driver memory, executor memory, number of cores and number of executors, right? So there is a calculation for this. I have already uploaded a video how to calculate these properties. I mean this numbers, how to bring the numbers like 10 executors, 5 cores, 1 GB driver memory, 5 GB executor memory. So how you bring this numbers? So there is a calculation. So I have a video already in my playlist, and you can find my playlist link in the description box of this video. So some people will not do all this calculation. They will go with the DRA, dynamic resource allocation. That means they are giving it to Spark itself. Spark itself will decide some amount of values for all these memory properties. So DRA is not recommended when you go for real-time projects and clusters, because it tries to utilize a lot of a lot of the cluster utilizations will be more. So sometimes like I need only 10 executor for my job, but it occupies like 30 executors. So that means it's a waste, like 20 executors or extra, so which can be freed for some other jobs, right? So this can happen because DRA is not that much intelligent in Spark for now. So this kind of profiling tool will help us whether we are giving the correct amount of values for all these memory properties. Okay, you may get a question here. You said there is a calculation for this. So if I do that calculation, still I need to go for such profiling tools. Okay, so even you do a calculation like how to give Spark driver memory, executor memory, number of cores, number of executor, still there will be some kind of problems that we can't able to identify. Okay, here is an example. So you have given all the memory properties with the proper calculation, everything is good, but what about the data skew? Your data was not equally distributed and parallelism was not there. Somewhere the data got skewed. So that is something which we are not, which we couldn't able to identify, right? Before we submit a job, we don't know, we don't have any idea. Only my thing as a developer, what I will be thinking is, okay, I will give this amount of value, I will do all the perfect calculation for executor, driver memory, cores and all those stuff, but when I run the job, it's still job is lag. It's still going down and it's taking more time. The reason is the calculation was good, but I have some data skewness. So how can I identify this? So Spark Lens will help you to identify data skewness and the job skewness as well. Even though you do a calculation or even though you do DRA, when you use Spark Lens, it will be always good and recommended for you. It won't utilize much resource from your cluster. Okay, so I will explain you how to integrate this with your Spark. So here you can see like there is an option for Spark Shell also. You can integrate this Spark Lens with Spark Shell. So I'm giving hyphen packages and the Cubal package name, and then hyphen conf spark dot extra listener equal to com dot Cubal dot spark lens dot Cubal job listener. So this option sometimes will not work if your cluster is within some virtual private network. So in that time, what you can do, there is a Cubal Spark Lens jar file is available in the Maven site. You can download it, or you can build the GitHub project of Spark Lens and generate a jar file and use that jar file with hyphen jar command along with your Spark submit or Spark shell. You can use it. Or directly, even in Spark submit also, this line, if this is allowed in your cluster, you can straightforward, you can do this, or else download the jar, take it to your cluster, and then with that jar you can able to submit. So when you submit this with yarn, right, so you can able to find the Spark Lens report in std out, in yarn logs std out. But if you are doing it in shell, I will tell you where you can see. I will tell you now, because I'm not going to show you with Spark submit. That's why I'm giving all this information to you. So now I'm going to start with my Spark shell. So I'm going to give executor core as 1 and then num executors as 1. Okay, now I will start. So your Spark Lens will start the calculation from here. Okay, when you see this in your Spark shell, then the Cubal Spark Lens is working fine. So your Spark Lens will start considering the point where Spark shell is trying to create the context. From that point onwards, it will start doing the time calculations. Okay. So I have the word count program here. I'm gonna run, and there will not be much difference in the time what I'm going to show you now, because my data set is very less, but I will try to explain as much as possible like what you have to see in your real-time cluster when you use Spark Lens. Okay, that's all. I'm writing the file to HDFS and I'm reading the file from HDFS. The word count is done. So with respect to Spark Shell, an important thing is you have to kill the cell, then only you can able to see the report. I'm giving control C now. You can see there, control C. Okay, see, you got the report. So I will go up again. You can see I'm just giving when I give control C, it says saving Spark Lens data to this location. Also the print version is here, so it's also printing the same here. So Spark Lens will give you a lot of information, like 40-50% of information will be there in your Spark itself, in Spark UI and yarn log itself you can able to find. But still we have few more information which is very interesting, and I will show you what are all the information that I used to follow in my experience. So only I'm going to show you that. I'm not going to explain the complete stuff. It's not required also. But on your interest, if you want to learn much, you can, yeah, you can go ahead and you can learn. So the very first thing what I will be seeing is, okay, my host is only one host, it's one node. Okay. Okay, so it's when you come here, you can see driver wall clock time. So how much time driver has taken for starting the means for this job? 29 seconds. But if you see the executor time taken is only 2 seconds. Executor is where your task will be executing, right? But if you see, driver is taking almost like 90 percentage of time of the job, right? So we have to check why driver is taking much time. Okay, that we have to see. And here the data set is really small, so that the executor's wall clock time is less. That's the reason. So in real time, for example, executor time is like 1 hour and the driver time is around 3 hours, then it is dangerous. You have to consider why driver is taking 3 hours. You have some kind of actions that is running in driver, like collect is a very good example. The driver will work hard when you do collect, because the entire shuffle thing will happen in the driver, right? So then that is wrong. You have to change it. So here driver has taken 29 seconds, but executor just took only 2 seconds, and then the total time is 32 seconds. Okay, now I will see this one, critical path. That means minimum possible time for the app based on the critical path. Critical path means infinite resource that you give DRA, dynamic resource. You give dynamic resource, and if I'm giving dynamic resource, or Spark itself is taking the calculation of on its own of doing the resource calculation, then what will be the minimum time it will take? It will take 31 seconds. Okay, now I will calculate the memory and I will calculate the executor. In that case, how much time it will take is what the second property. It will take 30 seconds. So there is just 1 second different, but in real time, if you give DRA, imagine in one example I have seen when I have used DRA, it took like 1 hour, but when I calculated all the memory power properties perfectly, and after that when I execute, what happened is the job got completed in 20 minutes. Right, so that is what the second property, perfect parallelism without zero queue and proper calculating of cores and executor memory and driver memory stuff. This will be your predicted value. This will be your minimum time. And what if I run my job with one executor, one core? So that is what I did now, right? So with one executor, one core, it will be 00H har and 00M. Yeah, it's less than minute. It's seconds only, right? It's just 32 seconds the overall, right? So yeah, it's correct. And this is what we have to consider in the real time. The first two properties you have to consider. And the next thing what I will be seeing is the app level wastage metrics. Okay, driver, it wasted almost 91% of resources wasted, and executor wasted only 5% of resource. So why? We have to check why driver is wasting almost 91%. How this happened? So this is something we have to check. So as like we have to give less driver memory or more, or cores should be get reduced or high. So that is something we have to check. Yeah, and one more interesting thing, I will always use this. So this will give you the count of executors, that how much you can give. If you give one executor, then the time is 31 seconds and it will utilize the cluster of 2.91% it will utilize. If you give 5 executor, then it will take only 0.58% of cluster utilization the same time. That means you can give 5% of, means 5 executors also for this, but again depends on your calculation, but still your calculation and this is almost, I believe it will come same. Okay, so and yeah, if it is not same, then you have to consider this particular information also. So this is all the information, the three things what I showed you is what I used to consider, and that's all with respect to the agenda of the video. But more you want to dig, yeah, you can just go ahead with global official document and you can learn a lot. Hash partition in Spark. So before explaining hash partition, I just wanted to explain you few more things and then we can go ahead with what is hash partition. And I request you to watch the complete video so that you will understand better. Okay, so let me get into the topic. So in general, so like we will be having any massive parallel processing technology, you go MPP technology like MapReduce or Spark or any other massive parallel processing technology, you will be having two phases. One is the parallelism part and then aggregation part, right? So in traditional MapReduce term, if I want to say, so you will be having map part and then finally you will be having the reducer part. Okay, so this is parallelism, this is aggregation. Okay, fine. So even in Spark also we have the same, so the parallelism part and then the aggregation part. So you have these two things. So here, so we can call this as an input task and we can call this as an output task. So now the question is, number of input task is based on what? Okay, the answer is number of, if your source is HDFS for Spark, then the answer is number of blocks is equal to number of tasks. Okay, now so this particular rule is always mandatory, and is it possible to change it? Yes, that is possible. So even so if you have 2 blocks, then your input task for Spark is 2, but if I have 2 blocks but I need my input task as 3, yes, you can do. Or even my input block is 2 but I need my task as 1, you can still do that, but we are not going to see that in this video. So I just wanted to say like something else. So so this particular in this video, just you can, as of now, you can just keep in your mind that number of block equal to number of task. Okay, fine, but this is customizable, but default is number of block equal to number of task. And similar to that, output task. Okay, number of output task count is based on what? In Spark, number of input task count equal to number of output task count. So that is what default in Spark, but in default in MapReduce is 1. Okay, irrespective to the input task, in MapReduce your output task will be 1. And even in MapReduce you can change it by setting job.set num reduce task, you can change. And in Spark you can use it, you can use repartitions and Coalesce to increase and decrease your output partitions. That is possible, but as I told you already in this video, just we can keep this in mind. The rule for output task is number of input task count equal to number of output task count. Okay, Now, so I'm having like two input tasks. So my output task gonna be 2 here. Now I'm going to do a word count program. So my input is hi, 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 and then I have hello, hello, and then welcome. Okay, so here this particular file is gonna split into two because my block is 2 blocks, as I told you. So here the first so a set of partition goes to this, one set of partition goes to this input task, and one set of partition goes to this input task. So here hi, and then hi, and then welcome goes to this particular input task, and the remaining partition file, like we have one more hi, right, and then two hello. Okay. Okay. So hi and two hello goes to this task, this input task, and then hi, two hi and one welcome goes to here. So I'm going to do some word count operation like flat map, and all those blah blah stuff. So output of this particular task will be hi one, and then welcome one. This will be your output from map task, right, of word count. So same here, hi one, hello one, and then hello one. Now I'm going to do the aggregation, the sum. If I want to say in a syntax wise, reduce by key. I'm going to do this reduce by key to bring the output like hi 3, welcome 1, hello 2 is my final output, right? So now what will happen, right? So Spark will decide which set of output has to go to which output task. So which set of input tasks output goes to which output task. So that will be decided by Spark. Okay. Now imagine like hi goes to this output task. So these two hi goes here and this hi goes here, and then welcome and hello goes here. Okay. So your output will be so hi 3, and then so hi 3. Okay, that's all. So the remaining thing goes to this task. So that means hello 2, welcome is 1. So this will be your output. That means you will see two output files because your number of reducer task is 2. So your output files will be 2. Okay. So now the question is, who decides hi has to go to first reducer? That means this one, first output task. Who decides hi goes to this particular output task, and hello and welcome should go to this particular task? Who decides it? Spark will decide. Spark use an algorithm called a hash partition to decide which particular output goes to which node, which particular output partition goes to which particular output task node. So that is decided by Spark by using hash partition. Now if you wanted to do it like this, okay, I need hi and welcome here, only hello here, and that means you have to customize the partition. Okay, so how to write a custom partition is going to be my next video. So in this video we have to know how this hash partition works. Okay, that is what I'm going to explain you. So since we are not writing any custom partition, the Spark itself decides like which particular output partition has to which particular node with the help of this hash partition. Okay, now I just wanted to show you the same in practical as well. So for what I explained, I just wanted to show you in practical. So let me run a word count program, and then I have a I'm just going to save my output as word out in my local. Let me run this. Okay, so I'm doing all this word count stuff, and if you see like all these are parallelism transformation, and finally this is your shuffle transformation, which is your output transformation, and this all your input transformation. If you want to know like how many input tasks and how many output tasks got created, yeah, I will show you that. So my input, so this is my first transformation, like I'm reading a file. So what I'm going to do, I'm going to get the number of partition which got created for reading the file. It is 2. So that means your input task is 2, then obviously your output task is going to be 2. That also we can check. So reduce data dot get num partition. Okay. Okay. 2. So that means your output files will be 2 files because your output partition is 2, so that your output files will be two files. Let me open this. You can see here there is two output files. Part-r000 is the first partition, part-r001 is the second partition. So parts file starts from 0. Okay, and you can see here hello and welcome is in first part 000. Okay, and then in the second part file hi. Okay, now again the same question. So who decides that first part file should have hello and welcome, and who decides second part file should have hi? Why not welcome in second partition, and why not hi in first partition? So because we haven't written any custom partition, so Spark itself uses a partition algorithm to decide the location of the keys in your output files, and Spark uses an algorithm called hash partition. So now we're gonna see what is the internal mechanism of hash partition. Okay, so this is an interview question that people are asking even in interviews, and MapReduce also use the same hash partition algorithm actually. So some people like still they have the confusion of explaining this hash partition. So that's why I just made this video. So what is the algorithm name hash partition? Okay, now what is the formula? That what is the algorithm? Okay, hash of the key mod of means like this one. Okay, symbol, this is the mod symbol, number of output task count. Okay, so here what is your output task count, and I showed you, right, it is 2. Okay, and hash key. Okay, now what is your what is mean by key? So we had this, right, hi mapper output, like the first parallelism transformation output, right? So hi 1, and then hello 1, and then welcome 1. Okay, so here this is your key and this is your value. Okay, so here this is your key and this is your value. So that means hash of the key, hash value of the key. Okay, so here, so we have 3 high, so you will be having the same keys will have same hash value. That's a point to remember always. And then hello will have a hash key and welcome will have the hash key. Now we don't know what is the hash key, so I'm going to generate a number on my own. Okay, so before that I will just see the output. Okay, hi is in second partition. Okay, so now I'm going to generate this number. So this is I'm generating on my own. So this is purely a predicted value. It's not something given by your Spark or something like that. Don't get confused. Okay. So I'm generating this value just to derive this algorithm. Okay. So here I'm giving the number as 12171. Okay. And for hello, I'm giving as 278. And then for welcome, I'm going to give like 1078. Okay, so as I told you, it's a predicted value. Now, what is the hash of the key for hi? For hi, it is 12171. And what is mod here? Mod of 2. That means, so when you divide a number 12171 and 2, when you divide a number, you will be getting a remainder, right? So this remainder is what? Mod value. Okay, so the remainder is what? Mod value. So when your denominator is 2, any number it can be, but when your denominator is 2, what will be the possible remainders? It is 0 and 1. That is a mathematical rule. And when your denominator is 3, what is your possible reminders? 0, 1, 2, and so on. So if your denominator is 4, 0, 1, 2, 3, it won't be more than that. Okay, it won't be more than that. It won't be more than your denominator value. The remainder will not come like that. Okay, fine. So now if you divide, when your denominator is 2, any even numbers that you divide, what will be your remainder? 0. When your denominator is 2, any even number divisible by 2 is 0. Any odd number divisible by 2 is 1. Okay, and that means here the remainder, so this is your odd number, so that means your remainder is obviously 1. So the output is 1. Okay, now next hello. For hello, the number is 278, again mod of 2. So any even number divided by 2 is 0. The remainder will be 0 obviously. And then for welcome, it's going to be 1078. Again, it's an even number. So when it's mod of 2, then obviously 0. So now what this 100, this output denotes what? Okay, I'm going to tell you that. So this output denotes the position of the output task. That means So this 1 denotes the first, sorry, this 0 denotes the first partition, your output partition, and 1 denotes the second output partition. And you can see here, so the remainder of high is 1. So that's the reason high is in first partition, I mean second partition. So the partition starts from 0, 1. So this is your first partition, this is your second partition. Okay, so the remainder of high is 1, and that means this high and the value has to go to second part file. This is your second part file. And for hello and welcome, the remainder is 0, so it has to go to first partition, and that's the reason it goes to first partition. And this is what the algorithm that Spark uses to decide which output partition has to go to which file. Okay, so this is what it is. So here the Spark internally does this. So it is not, it's the data is skewed, right? So it's not eventually distributed, and that's the reason we go for a custom partition. So that is something I'm going to explain you in the next video. So here from the output, what I have decided, right? So hash key is something that I have generated, but what the confirmation I got from the output is, so hello and welcome had some hash key which I was not aware of, but it should be an even number, that I know, because that's the reason hello and welcome has came to first partition. That I know, because I know whether it's an even or odd number, that I know very clearly. So since it comes to first partition, I come to know the denominator is 2 and the hash key is going to be, for sure it's going to be an even number. That's why the number what I have given, the predicted number, I have given that as an even numbers here, and that's the only thing. The confirmation what I got is, I know like what will be the end number. So based on that I have decided this. I can give any even numbers here. And then for second, I'm surely know that this particular number, the high hash key is going to be odd number, because it comes to the second partition, the remainder is 1. So obviously I know this is an odd number, and that's why my predicted value is an odd number here. That's the only thing. Okay, don't get confused. And sometimes people used to ask me whether by increasing and decreasing the partitions will fix the issue. Like means people used to ask me like this: if I increase my number of reducer, then can I decide my data has to go to which partition? Can I decide that by increasing the partition? No, the question is not making sense, right? Even you increase or decrease, still you can't decide which particular output file should have which particular key. That you cannot decide even when you increase. Maybe by increasing you will have some, you will end up with some empty partitions also. Okay, I will show you that also as an example. Now what I'm going to do, I'm going to increase my partition. Okay, so here I'm going to change my output directory as 1, and here I'm going to make a repartition. That means I'm going to increase my partition to 3. Okay, so now like you will be having 3 part files, but still I don't have a clue that which record goes to which file. Okay, let's see. I don't have a clue. Okay, so let me open my word output 1, and I can see 3 files, but I don't know which file will have what key value. And you can see here hello is in first partition. Now the denominator is changed. That is important. Now your denominator is 3. Okay, so when your denominator is 3, what are all the possible reminders? 0, 1, 2. See, 0, 1, 2. That's all. So, and you can see the empty partition, first part file is empty. That means for the given hash key, there is no remainder 0 got created. So all the reminders for hi, hello, welcome was 1 and 2. That's it. And that's the reason your first part file is empty. So that is empty partitions got created. So skewness will be there, empty partitions will be there if you go for hash partition, and that's a disadvantage. And that's the reason we go for custom partition. But still, even though this is a disadvantage, why I have made this video, we need to know what is the internal mechanism of hash partition and how Spark decides it. So like even in the interview they are asking this. So that's the reason I'm just giving this video for you. And this is what hash partition, and MapReduce also use the same algorithm, and the same Spark is also using. Spark custom partition. So here this is just a word count program, and this is my input file, and it's a regular word count program, and I'm finally writing it to a text file. So let me comment out all the custom partition related stuff. Okay, so now I'm gonna write this into an output file. So now let me run this program. So here the output folder will be get created in my project folder itself. Okay, it's just a typo issue, like, yeah, please ignore it. Okay, let me refresh. Okay, so here you can see the code got executed, and yeah, I don't have that console view. Okay, so that's fine. So here the code got executed and the folder got created, and here there is two part files got created, and let me show you my input file. So hi, hello, and then welcome, welcome. There is two hello and two hi and two welcome. Okay, so here we don't know which welcome resides in which file, hello resides in which file, hi resides in which file. So that we are not aware of, right? So let me open this first part file. You can see hello and welcome resides in first part file, and in the second part file I have hi. So this is the question. So how Spark is deciding this, like hi should go to second partition, hello and welcome should go to first partition? How Spark is deciding this? So Spark is deciding this with help of the default hash partition. That is what I have explained, the in and out of hash partition and with its formula in the previous video. I recommend you to watch that video. As I told you already, the link is shared in the description box of the video. Now I want to write a custom partition so that I have to decide which output should go to which part file. So that is the agenda here. So let me again delete this folder. So things that you have to do for implementing a custom partition. So I have written a separate class in the same code. I've just closed this code here, and then I just write a new class within this. So the very first thing, you have to create your own class for partition, and you have to do extends is like inheritance. In inheritance we do extends, right? Partitioner. So partitioner is the source class in which your default hash partition logic resides. So I'm overriding, I'm extending that class, and then I'm writing my custom logic. Point one, you have to extend the partitioner class. Second, you have to override a method called getPartition. This is very important. Sometimes even in interview they used to ask, what is the method name in which hash partition resides? The answer is getPartition. So first we have to extend the class partitioner, and in which getPartition is a method in which your hash partition logic has written. So I have to override that logic by using the override keyword in Scala, and I'm overriding the method getPartition. Now I am writing a normal condition. That's it. So if key dot toString, so key is here your words or key, is equals to welcome, then return 0. Return 0 means it has to go to first part file. That means part-r0000, and then if key else key dot toString equal ignore case hi and equal ignore case hello, then it has to go to first partition, that is part-0001. So in this case here I am deciding that welcome should always go to first part file, and hi and hello has to go to second part file. What happened previously, hi was in a different part file, welcome and hello was in a different part file, right? Now I'm changing the logic. Now here you can ask me, what if I have a new word in my input file? So then again you have to write one more condition. So this is my logic. You can implement your own way of logic to implement this custom partition. So as I told you, if a new word is there but the condition is not here, then for the new word it will take the default hash partition. Only for the given condition of words it will treat your code as custom partition. Any other new word which is not there in the custom partition will go for default hash partition. Okay, now I have written a class. Now how can I say to my code that you should use this custom partition and you should not use any other hash partition or the default partition? So here this is the answer. So this is your code. Now this is the last line where your logic get completes, and then you are going to call an action as save as text file. So before calling the action, what you have to do, val, I'm creating an val partition data, and then word count. So this word count dot partition by. So this is a function which you have to use to call your custom partition. And then I'm creating a new keyword. I'm allocating a memory for the object, and then your class my partition. And here you have to give 2 because you have written a logic for 2 part files, right? So you have to give 2. That's very important. Okay. So and then now copy this and remove this word count and give this partition data and then save as text file. Okay, so now let me run this. Let me run this code. Okay, so it got executed. Now I will refresh this. Okay, so the output folder got created. Now the first part file will have welcome. See, welcome. And the second part file should have hi and hello. So hi and hello. That's it. So custom partition is working. So this is how we have to implement custom partition. I will give you a walkthrough once again. So the first point, you have to extend partitioner class. Second point, you have to override the get partition method. Third, you have to write a logic. And fourth, you have to call your custom partition class within your Spark code. Fourth, you have to pass the respective number of final output task as 2, which is equivalent to repartition. Okay, so this is the same process we use in traditional MapReduce also. The same class, same function, the same way we used to do for MapReduce custom partition also. The logic wise it is same. And even the hash partition, the default Spark hash partition, the formula is same, the algorithm is same for MapReduce also. Connecting Spark with MySQL or any other RDBMS through JDBC. So by default, we used to connect Spark with Hive, and Spark internally uses the Thrift server to connect with Hive. And there is some use cases even in Spark with Hive, you can connect with JDBC also. So by default, you can use the Thrift. Spark internally uses the Thrift to connect with Hive, but still there are some use cases where we still used to connect Spark with Hive via JDBC also, but I will tell that in a different video, because you can ask me a question like if Thrift is what internally used by Spark to connect Hive, then should I have to use JDBC to connect MySQL or Oracle? So you may get this question. So for this, I will give you an answer in a different video. For now, like we are going to just see how to connect Spark with MySQL or Oracle through JDBC. So I will tell you some use cases as well. So in real time, we always used to get some requirement like this as well, because most of the source systems have been not migrated. The source databases has been not migrated, because that is kind of a critical thing which to do. Actually, all live events are captured in the current traditional RDBMS only. So here what we are trying to do is we are trying to replace the transformation part. So we imagine, I will tell you a use case. There was a MySQL database, and data has been getting stored over there, and people use some traditional tech stack like Informatica or Ab Initio to do the ETL stuff. When I say ETL, extract, transform, load. So ETL is all about you transforming some data. So you do some joins and generate a report, right? That is again we call it as an ETL, which you can do with Informatica and Ab Initio. They are some traditional technologies. So now the plan is I want to remove this Informatica and Ab Initio from the system, and I have to replace that with Spark. So that means still MySQL is a source, Oracle is a source. I don't want to change that. What I want to change is to change the transforming part, which is Informatica and Ab Initio, or Informatica. Let's keep only Informatica. I want to replace Informatica with Spark, but the source is still Oracle. So in that case, you have to write all the transformation what they have written already in Informatica. You have to rewrite that in Spark. Okay, with the programming or like codings and SQLs, those stuff. So in this case, you have to connect Spark with Oracle to read the data first. So that is the use case. And when I say this RDBMS or Hive is not only the source for Spark, also destination. So you write some output of Spark to some Hive tables, or even we write output of Spark to some RDBMS or NoSQLs. So whenever I say, it's like for both read and write. So here in my case, MySQL is a source system. In some other cases, MySQL will write the target tables, target data to a MySQL database again. Okay, fine. So both source and target could be MySQL, or source could be MySQL, or target could be Hive, source could be MySQL, target could be NoSQL, right? It depends. Fine. So here I will tell you like how to do that first. So here you have to download MySQL connector jar from internet, which will be available, and then you have to invoke Spark Shell. So I'm going to show you with Spark Shell. You want to write this as a code, as an application in IntelliJ or Eclipse? Yeah, you can do it very well by now, right? So Spark Shell -- jar. I'm adding MySQL connector. Because of adding this jar only, I could able to connect my MySQL, or else I won't. I can't, right? So if it is Oracle, then you have to download Oracle connector. So there will be a separate connector jar for each RDBMS for JDBC. Okay. So you have to use this command, enter, and now you have to do a setup in MySQL as well. So for installing MySQL, there is a command sudo apt-get install. I'm sorry. So this is Ubuntu. The Linux what I'm using is Ubuntu apt-get install MySQL-server. Okay, this is a command to install your MySQL database, and then you have to set your username and password. So if you have already watched my Hive video, how to install Hive video, I have explained how to do this MySQL setup. Okay, so once you install this, you have to log into MySQL. So MySQL-u root and -p. My username is root, so -u is for username, and then -p which will ask for password. Root is my password. So I have entered into my MySQL. Now I'll give show databases. So I have already created a database as test, you can see here, or else you can use command create database name, and you can create your own database. So I'm going to change my database now, test. Okay, now show tables. So I have a table called T1, so I'll do a describe here. So I have two columns, serial number and p name. Serial number is an integer column, p name is a varchar column. Select star from T1. So I just have one record, so 1, Gautam. That's it. So with respect to MySQL, things are done. So back to thing. So here now I'm going to show you how to do this. So if you see here, so I have val data frame MySQL equal to spark.read.format JDBC. So because the format what I'm going to use is JDBC, and if you have if you are using Spark version greater than 2, it is going to be Spark, because sometimes people used to go for SQL context, so that is not required, because when you start your Spark, it says Spark session is available as Spark, which includes Hive session, SQL session, and everything. So you don't want to have SQL context. So just you give spark.read.format JDBC, and we do have some options in which we used to pass all the DB information. So first thing, you have to pass your MySQL host name, which is localhost. You have to give JDBC :MySQL localhost, and then the database name test, and then driver name. So com.mysql.jdbc driver, for each and every database there will be a driver name. If it is Oracle, it will be different. DB2, it will be different. For MySQL, it is the driver name is same. And then option DB table, that is like table name. So this DB table is a syntax. Okay, so this is a key. The value is the table name T1. So here you have to change your table name, and then username is root, password of MySQL is root. So let me run this. Okay, so if I run this, so you can see here it is able to read my data, because I can able to see the data types of the table. Now what I'll do, I will just do a show of this, enter. Now you can see 1, Gautam, I can able to see the data. But the problem with the JDBC with Spark, right, it used to launch only one worker, one thread. So that means there won't be any parallelism. So that means this is not recommended to use in real time. That is how people used to think. But there is no other go when the source is an RDBMS. We used to do only with JDBC. So how to do this in an optimum way? Like how can we increase the parallelisms, and how can we do the partition based reading and all those stuff? So here I have introduced few other options. Like you can see after this password, you can see I have added something called partition column, number of partitions, lower bound, and then upper bound. So that is what I have. The definitions are here. I will tell you. Partition column is similar to like we use partition columns in Hive, right? So why we use partition column? So that is when we do a read select with the where condition of the partition column, the query performance will be high, the read time will be get reduced, right? That is why we use the partition. And the partition column, what you are preferring here, it's supposed to be numeric data or timestamp. So if, for example, here if you see the partition column and I'm giving serial number, so instead if I give p name, so p name is actually a varchar. If you see here, it's varchar. But if I give p name, I'll be getting an error saying that the name of the column should be numeric data or timestamp type that will be used as partition. You will be getting this as your error statement. Okay, so make sure you are using this type of data type based columns. And then lower bound and upper bound is something like for the partition column, we are deciding the range of data needs to be get read by the select query, by the read operation, right? So I'll explain you more on this. So lower bound or upper bound is based, we used to give some range for the partition to be get created, and the data should be get distributed while doing the read for each partition. Okay, so here the number of partition, how to decide? Okay, I'll explain you the lower bound and upper bound in some in next 2 minutes. I'm going to explain you. Okay, number of partition. So deciding number of partition is again like based on the volume and other stuff you have to decide. So and one more thing, like since here it is two different tech stack, right? So you have to involve the Oracle or team or MySQL team from whichever you are going to read. So it's not like you are deciding some partitions on your own, and then because you don't know what is like how in Oracle it happens and how threads happens in Oracle or MySQL, you are not aware of it. May or may not, but we'll go for worst case. Now imagine you decide something like 5 partitions you are deciding, and then Spark is not able to read, and then like your source team will blame you. See, Spark couldn't read it, so you have to do something with Spark. Or you should not blame Oracle team or MySQL team saying that. So it's not like blaming each other. We have to sit together. One person from Oracle team and one person from the Spark team should sit together, and you have to decide. You have to discuss like how this works. Like if I do a read operation, how it works. Because end of day for that Oracle or MySQL guy, so you don't want to mention him like we are going to read with Spark or something. Like just tell him I'm going to read via JDBC. That's it. So because like if a JDBC call comes, how much partition will be good for this particular table? Ask him. So he will be having some idea, because they used to suggest this for many other teams for different JDBC calls. So JDBC is not only for Spark, right? Even you write a normal Java code or Python code, you can do JDBC, right? So you just check with them, just do a group work, and that is what the reality answer I can give you. Okay, fine. So here number of partition we are deciding as 10 now. Now there is a like formula, like how internally based on the lower bound, upper bound, and the number of partition that we have given, based on how internally the data will be get distributed as a partition range. So there is a formula internally that Spark used to consider. So the formula is upper bound divided by number of partitions. So here lower bound I have given as 0 and upper bound I have given as 1000. So it's based on the I'm deciding the range on which the data can be get distributed. So that is what this 1000 is all about. Okay, if you see here like 1000 divided by 10 minus 0 divided by 10. So 0 is lower bound, so 0 divided by 10 equal to 100. So we call this as partition strides, the range. So that means like we have 100 as a range between partition. So internally Spark used to have Spark internally used this kind of an query understanding only. So select star from table name where partition column between 0 and 100. So the 0 and 100 is not the value within that partition column. That is very important. It's not a value. I'm not denoting the value of that column. It's a range of that partition column. Okay, so don't consider this is a value when I use the word between like a SQL query. Don't confuse like that. So now it will consider this 10 partition. It will create 10 partition, 10 SQL statement like this, and the partition stride, the range will be 100, like 0 to 100, 100 to 200, 200 to 300, 300 to 400. So it will be like that till 900 to 1000. So you can increase the range like by increasing the upper bound. But it's all trial and error. You have to work out actually. So you have to do a POC and make sure like based on what bound we give, the performance is getting increased. So that is something you have to decide actually. So now there is one more called predicate. So if you use predicates, you don't want to use any of the above thing, just use only predicates. But if you are not using predicates, then please go for these 4 options. The 4 options are partition column, number of partitions, lower bound, upper bound. So if you're gonna use predicates, you don't want to use those 4. So what is this predicates? Predicates, it's like you can the option what you are giving, right? So here dot option, directly you can use the word predicate, and then within the value you have to give the where condition state. So whatever you used to give in where condition, so where field name or where a date column greater than 2021, a year column greater than 2021, directly you have to give the where condition, like a condition statement. So each condition statement you give with the predicate is actually a partition. So that is what it explains, a list of condition in which in the where class each one defines one partition. So for example, if I give year greater than 2021, it's actually it consider that as a partition. Okay, and then what else? So the remaining database connection informations like username, password, URL, and those stuff. So let me run this as well, just to show you like there won't be any syntax issues. I'm gonna run this. So I'm going to run this upper bound, lower bound, partition column, and then number of partitions. So now I'm going to run the same show thing. I'm getting the output. So since I don't have the huge volume of data, I'm having less volume, I was not able to show you the internal mechanism how it happens. Maybe I will try to make it in some other video, but this will work for sure, because JDBC connecting Spark is actually a hard task for us to prove them. The performance will be really good, but then there will be some tweaks that you have to do, because you have to change the lower bound, upper bound, and number of partitions frequently. Not much frequently, based on the volume of data that increase, you have to change. Even in the Spark, again, num partitions has to be get changed when even we are reading it from Hive. Yeah, it's all same, right? So this is how something that we can do when we are reading Oracle or MySQL. How to write a Spark UDF. Okay, so Spark UDF user defined function. So getting into the topic, so UDF is something we call it as user defined function. The UDF is very familiar terminology. So we used to have the same UDF creation in Hive as well, and Spark, even in MapReduce we do have, and even in NoSQL databases like HBase and Cassandra we still used to have this UDF. So I'll tell you what is UDF and why it is required. So we all are familiar with the predefined functions. For example, let's take Hive. Okay, or MySQL or Oracle, whatever it is. So even outside the world of big data also, still we have this user defined function. So I'll tell you like predefined functions. So if you take Hive, right, so you have functions like min, max, sum, right? So you do have these functions and you use this function in your SQL statement, right? So if you use min for a column, it will give you the minimum value, and you have something called count is a function, and then a max is a function, average is a function. So we do have this predefined function. So now imagine I have a requirement and I don't have a function which is already exist in Hive, not gonna help for me for this particular use case. So I have to do something different, but that function is not already available in Hive or in Spark. So you can write your own function and you can define that as a UDF. So I'll show you how to do that. So today my requirement is like I have two columns, serial number and then name. So I'll have like 1 comma Gautam, 2 comma some name, and 3 comma some name, so on. So if you see in my second column, the name column, the name, the first letter will be small letter for all the records. So my requirement is I have to change the first letter alone to uppercase. I don't want to convert my complete name column value to uppercase. I just need to convert only the first letter of the name to be converted as an uppercase. Now for this we don't have any predefined functions available in Spark, so that I'm planning to write my own function. So that is called custom function, or you can call it as a user defined function. So once you have done with the user defined function, you created a logic. Now how come you will inform to the Spark that treat this as a UDF? Because when you say like you give some function name, all of a sudden, how come Spark understands, okay, this is a user defined function and this is not a predefined function? How come Spark categorize it? So all these things I'll gonna explain in this video. Okay, so first of all, let's try to create a data first. So what I'm doing here, I create val call a sequencer list with serial number and name. I'm preparing the header for my data. And then val data equal to sequence of, I'm just created 3 records, 1 comma Gautam, 2 comma Nandini, 3 comma Saravana. This is a name. Okay, it's a name. And then I'm converting the data to DF and I'm passing my calls. So which is like I'm passing my schema. Okay, so let me run this. So if you run this, so let me enter into Spark Shell. So I'm going to show you in Spark Shell. You can do it with .scala as well. And the same format is what we do in .java as well. Means if you are using Java, and then it's the same way of informing the Spark how to use UDF and all those stuff. The procedure what I'm going to show you with Scala is same, only you have to change it to the code to Java. That's it. Okay, so I'm preparing the data here. Okay, now you can able to see here. So I have like 1, 2, 3 records, and then Gautam, Nandini, Saravanan, and you can see it's all like small case because my input itself, the first letter is small. Now my agenda is to convert my first letter of my name to uppercase. Okay, so back. So for this I'm going to write a code. Okay, so this you can see as a separate code. I created a uCase function, and then I'm just passing one argument. I'm expecting one argument for this function. So string is a data type and string quote is a variable name. So in Scala, we used to first pass variable name and then data type, and then the delimiter between these two is colon. In Java, we used to give data type as first and then variable as second. So this function accepts one string argument. Now inside, so val dt equal to string quote split by space. So I'm just separating that with a space, and then I'm passing it to a map function, and then I'm doing an iteration. So f dot substring of 0, 1. For example, let's take a first name. Okay, Gautam. So what it will do, so f dot substring of 0, 1. So it will take the first letter G, and then I'm converting it to uppercase. So that means this will just convert to G. Now then I'm doing a concatenation here. That means, so you need the balance, right? So plus you need OWTHAM. So the remaining piece of my name, the remaining letters. So I have to concatenate it. So for f dot substring 1 comma f dot length, and then I'm converting the whole piece to a string. So that means the output from this line will be GOWTHAM. The first letter will be capital letter. Okay, so now you have written a code for your custom logic, but that is completely fine. But how come I will say that this function should be act as a UDF in Spark, and how I will inform to the Spark that treat this function as an UDF, how to do that. Okay, so if you see here, this is where the magic happens. So I'm creating a function called custom UDF. You can give any name here, and this UDF is a syntax, the predefined function to which you can pass any of your function, and after this point, after you execute this line, then Spark will consider this U case as a UDF because you are passing your function to UDF. That means your function has been turned as an UDF in the name of custom UDF. Okay, so this is, if someone asks you what is your UDF name, this is your UDF name. So just copy this, go to your Spark shell, enter. Okay, so okay, I have to execute this. Okay, so I haven't executed this, so let me first execute this. Now let's go for this. Now you can see the UDF created. So the UDF what you have created for this U case is custom UDF. Now let's see how to use this UDF. So first let's go with the data frame. So first of all, if you see here the very first line, line number 23, I'm just selecting serial number and then name, and I'm doing a show. So I'm not using any UDF here. So as is, I'm just selecting it. So if you see here, still I'm not getting the first letter as capital letter because I'm not using any UDF here. If you see in line number 24, tf.select call serial number, and then I'm using my UDF. You can see here UDF of call of name. So when you run this, now the first letter of your name will be in caps. See, G caps, N caps, S caps. So first letter of your name has been converted to uppercase. Now, if you want to use the same with Spark SQL, if you are doing it in Spark SQL, you have to register this. So this way you have to register. So spark.udf.register custom UDF. The function name of this custom UDF is ucase. You have to register this. Okay, and then you can, for the DF, you can create a temporary table, and then spark.SQL, you can use a normal SQL to fetch the columns. Just pass the UDF like this, like how you pass min max function in your SQL statement. Similar to that, you can do this. So in real time, we used to write a lot of UDF, and you need to know how to write an UDF and how to use it in the Spark code. So that is the agenda of the video. So if you see, like most of the time, without UDF, you can't see any Spark applications in the real time. Mostly they used to do this time conversion, like time, date time to timestamp, or timestamp to date time, something like that. And then they used to have some complex logics, like 3 to 4 lines of complex logic for each column. I cannot write a 3 to 4 lines of code for each column. So they will convert that complex logic to a UDF, and they will use it as a one single word, like how we did here. So like this is how you will see a lot of UDF in the system. Like for example, you have to do a currency conversion. So we don't have a predefined function in Spark. So you can write a custom logic for currency conversion, INR to USD, USD to INR, something like that. So the main agenda of the video has been completed. So this is what the logic, that whatever you want, you can write on your own. But the video helps you to understand how to write your logic in Spark as a custom UDF, and how to convert that as an UDF in the Spark, and how to use it. The difference between repartition and Coalesce in Spark, and we are going to discuss practical thing as well, so please watch the video completely. So repartition and Coalesce is a very important topic, and performance wise also we use this a lot. So generally what the definition we used to say when to use repartition and when to use Coalesce. So repartition, people used to suggest us to increase. If I want to increase the partition from the current partition, then go ahead with repartition. Coalesce is something which I have to use for reduce the partition. For example, currently your input partition is 100, and then you have to reduce it to 5 partition, then go for Coalesce. Currently I have 100 partition, and you want to increase this to 150, then you go for repartition. This is a general definition. So with respect to repartition, we have the full shuffle. So the repartition from 100 to 150, in this case the full shuffle will happen, and whereas the network IO will be increased, and that's where the performance problem comes. So but again, we have to tune it. So when I use repartition, for sure you will have the shuffle, full shuffle will happen for the data across the nodes, the executors, but still the performance needs to be get tuned. But when you use Coalesce, since it's used for reducing the partition, right? So the shuffle will not happen. So when you use Coalesce, we are avoiding shuffle, but when you use repartition, we are doing a full shuffle. So here, for reducing the partition, people always suggest us to go for Coalesce, not repartition. This is the general definition. The last point which I told you is what the general definition I used to get from the internet. The last point what I told you is If you want to reduce, please go for Coalesce. If you want to increase, repartition. Okay, here is a question on the last point. So why can't I use repartition to reduce the partition? For example, I have 10 partition, I want to reduce it to 5. The general internet guidance is to go for Coalesce. But my question is, from 10 to 5, from 10 partition to 5 partition, to reduce this, why can't I use this repartition to do that? So that is what we are going to discuss today. Okay, let's get into the practical part. So let me start my Spark shell with the general memory configuration with driver memory of 5G, executor memory 2, and executor core 5, num executor 5. Okay, so now what I'm going to do is I have two set of examples, one with Coalesce and one with repartition. The logic is going to be the same. So here I'm going to perform a join. So first we go with Coalesce. So I have df1, df2, and df3 is where I'm doing a join of df1 and df2. So df1 has a Spark range of some value. I'm converting it to a df with the column id, and then I'm creating another column c1 with the value na. I'm just adding a literal to it. So the output will be like id and then c1, two columns. ID columns will have the range of values, and then C1 column will have NA for everything, for all the rows. And then I'm doing a join here and the inner join. So then I'm going to do a print statement for the get partition. So let me first run this 4 lines in my Spark shell. Okay, so the output of print statement will be 200 because the default shuffle partition is 200. So the next line is Coalesce. So here the default partition which I showed you is 200, and I want to reduce it to 5. So if you see here, I'm using 5, and then I'm writing it as a parquet file in my Linux file system. Let me change the output folder here. So now I'm going to run this. Okay, so the job gets started. So let me restart the Spark UI. Okay, it started here. It created 13 input tasks and the job is running. Let's wait for the job get complete. Okay, so it's almost done. Okay, so it's completed. It took 36 seconds duration and 3 stages. I will just open you the stages and I will explain you the DAGs and all those stuff. So just let's open this. Okay, so if you see here, like we have 3 stages. So the stage 0 is for the df1. So the first df which we have done here. So the first df, and then the next stage is for df2, and the last stage is for your join. Okay, and if you see here, 4 tasks got created for df1 and 4 for df2, and finally only 5 tasks that got created for the join as well as writing as a files. So now if you see, the output files will be 5. So the folder is 43. So let me change my folder to 43 and I'll do an lstr. You will see 5 part files. Okay, now here is the question. See, I just showed you the print statement of df3 get partition, right? So it showed you 200, but I don't see any 200 here. See, I don't see any 200 here. So it just 5. It's not 200. So what happened here? So when you use Coalesce, right? So this 5 will override the previous parent data frame or RDD's partition. So the print statement of df3's get partition count is 200, but then I have given Coalesce. So this 200 has been overridden by this 5. So that means the join df executed the join in 5 parallel tasks only, and then 5 files. It has written as a 5 files, and that's the reason there is no shuffle here. 5 tasks got created and it executed the whole join just in 5 tasks as a parallelism, and then 5 output files, so there is no shuffle required. Fine. Now let me go with the second example. The same, so I will just copy. So the df name will be 456. Okay, so it's the same, but we are going to use repartition here. So let me show you the print statement of df6 again. It's again a join, and you can see 200 is here. Now I'm going to trigger the repartition. Let me change the directory to 44, the output directory. Okay, run this. Okay, now let's go to the UI. Okay, let me refresh this. Okay, if you see here, in Coalesce only 13 tasks got created, but if you see here, it has 200 plus 13, 213 tasks got created. Okay, I'll tell you why. but just wait. Okay, it got completed. If you see, this job, the repartition job, got completed in 18 seconds, like, whereas the Coalesce, it took 36 seconds. Generally, if you go in internet, right, so they used to say Coalesce is much faster than repartition. That's what people used to say. The reason is, in Coalesce we will not have shuffle, but in Coalesce we are losing the parallelism actually. So if you see here, in my case, whatever I showed you, the repartition was faster than Coalesce. Okay, but at final I will give you the conclusion, but just first of all we can get into this DAG for the repartition. So if you see here in the means in the Coalesce we have only 3 DAGs, but if you see in the repartition we have 4 DAGs. So that means the first DAG is for DF4. Okay, here it starts with df4. Okay, 4, and the second DAG is for df5, and then this DAG is the join DAG, and then the last DAG is actually the final write. Okay, if I click this, you will see shuffle here. See, this shuffle was not there in the Coalesce part. See, in Coalesce we don't have shuffle, but here it got created, the final write. So before write, the shuffle has been happened. Now I will just, let's go down. If you see this 4 task for the first df, that is df4, and the second df5, 4 to 4, it's all okay. But if you see, we have this 200, that means the join got executed in 200 parallel tasks, and that's why here we got good parallelism, and the job got completed faster. Whereas if you see in Coalesce, we are not using the 200, even though I showed you the print statement of Coalesce, right? It printed like 200 here, but still we don't see 200 because the Coalesce will override the 200 with the whatever the value that you have given. So repartition will not do that way. So repartition, still it uses the parent RDD's actual partition, whatever it is, 200 here. In our case, it's default. So it runs the join with 200 parallelism, and finally 5 tasks it is used to write the output as 5 part files. So that means, so here the shuffle required because you have the output in 200 partition, and finally it has to be written in 5 partitions, right? So here the full shuffle will happen. So in this case, the full parallelism has been achieved, and that's why like repartition, it was faster than Coalesce. But as I told you already, like let's come for the conclusion here. So you can ask me like, then why in internet we have people are saying that Coalesce is faster than repartition. So it's also correct. So in some cases, Coalesce are faster than repartition. That is also correct. But if you go for an interview or somewhere, like people used to be like with one statement always used to say, we cannot use repartition for reduce. We can use only for increase. Coalesce only can be used for decrease. So you change the statement. So repartition can be used for both increasing and decreasing the partition. And the conclusion here is, so before choosing repartition or Coalesce, completely based on the transformation and the data what you are going to use. So before you decide whether it is repartition or Coalesce, please do a POC and then conclude whether it is repartition or Coalesce. Not all the cases Coalesce is faster. See, in this case, repartition is faster. So better do a POC and then you conclude it. About how to integrate Apache Spark with Apache Hive. So here we are going to do a kind of a POC, a proof of concept, that I'm going to read Hive tables in Spark, and then I'm going to do all kind of transformation in Spark so that my processing will be faster compared to doing the same in Hive. Okay, now how to enable the integration between Hive and Spark, and that's what we're going to discuss. And what is the prerequisite for this? So you need to install Hadoop, then you need to install Hive, and then you need to install Spark. Now once you have done with these 3 installations, then what is the next step is you have to open your bashrc file, which will be in your home folder. Bashrc file is where we set all our environmental path and variables. So I'm using Linux OS Ubuntu. So in Ubuntu, the file name is bashrc. Just open this, go to last line of the file, where you can see like I have all the environmental variable and path whatever I'm installed. I am just setting it here like Java home. So what are all the properties you have to set, I will tell you. But if you have already installed Hive, Hadoop and other stuffs, right, you would have done this already, but I'm repeating it again. So you need to set Java home, Hadoop home, Hive home and Spark home for this particular exercise. And finally, please add this path and like path variable, and add all your variables with $/bin in your export path. So this is important. So once it is done, just save this file, escape:\wq, and then you have to execute this file. The command for execute is, I repeat, you have to execute this file .bashrc, that is source space .bashrc, or you can give dot space dot bash or c. Okay, so once this is done, just open a new terminal and then start your Hadoop, change your directory to Hadoop, your installation directory, and then you have to use this command sbin/start-all.sh to start your Hadoop. So once it is started, just execute the JPS command and see whether all 5 daemons has been started. So once this is done, now you have to change your directory to Apache Hive and then just start your Hive shell. bin/hive is your command to start your Hive shell. Okay, and if you see here, when I give show tables, I can able to see all these table name. So I haven't created any database, so the default database name is default. So if you want to create a database, you can create a database, then you can use the database with the command of use the database name, and then you can create a table, or directly you can create a table under default database. If there is no database selected, that is default. Okay, and the database name is default. Now here I have these many tables, and you can see there is one table called test. So let me just show you. If I select star from test, I can able to see only one record, one column, and one row. This which is just one the value. If I describe it, you can see here I'm just describing it. I'm having serial number. So I haven't create. I'm not showing here how to create a table. So like you are aware of it, I believe, or you can. So in my Hive installation video, I have showed how to create a table also, or you can Google it for creating a very simple structure of table and just insert a record so that we can read it from Spark. Okay, so now this is done. Now the next step is like you have to start your Spark shell. So just change your directory to Spark and then use this command bin/Spark shell. So I'm going to show you how to do this Hive Spark integration through shell. So in our next video, I will show you how to do the same in some IDE like IntelliJ or Eclipse, how to write a full-fledged Scala code to do this or Java code to do this in my next video. Okay, now I'm going to show you the same but in shell. Okay, so before you start, okay, you started Spark shell, so that directly I can read Hive tables from here. No, you can't. You have to do 2 more steps to achieve this. So the very first thing is like go to your Hive folder. Okay, so which will be in your home wherever you have installed it. In my case, it's in home, but wherever you have installed it, just go to your Hive folder. You will be seeing a folder called conf. Just open it, and then you can see hive-site.xml. If you have already installed Hive, then for sure you have configured this hive-site.xml. So conf, if you have configured it already, just you will be seeing this file in your Hive folder. Copy this hive-site.xml and go to your Spark folder. Again, in my case, my Spark directory is in my home folder. I'm just opened that folder, and then you can see there is a folder called conf in Spark. Open this, and then you have to paste your hive-site.xml here. So that means you can see here. So then only your Spark will come to know like what are all the configurations that you have given for your Hive. Okay, this is first step. There is one more step to complete this process. Now come back to your Spark folder, and there is a folder called jar. Just open it, and you can see there will be a jar called MySQL. Okay, so MySQL connector. So this jar by default, it will not be there in your Spark jar folder. So you have to download this MySQL connector and then you have to paste it inside your Spark jar folder. The reason why we need this MySQL is my Hive metastore is getting stored in MySQL database, and that's the reason I need MySQL here. And you are already aware, I hope so, MySQL metastore will be get stored, MySQL metastore data will be get stored in an RDBMS database only. Okay, so if you have configured Hive metastore for MySQL, then you need MySQL connector in Spark jar file. If you have configured Hive with any other RDBMS databases, then you need to download the respective connector jar, like Oracle means Oracle connector, or any other DB2 means DB2 connector. You have to download that particular connector and then you have to paste it here. In my case, I'm using MySQL for Hive, so I've downloaded Hive connector jar. So once this is done, then you can just get into your Spark shell. Now what I'm going to do, you can see Spark session is already created in the name as Spark, so I'm going to use the same val A equal to, so I don't want to create a Spark session, but if in case you are going to write a Spark code in in IDE like IntelliJ or Eclipse, then you have to take care of writing, creating the Spark session. Maybe it will take 2 to 3 more lines of code where you have to enable your Hive support function. There is a support function to enable Hive. So those things are not required when you are doing it in shell. But if you are writing as a code in an IDE, it's required. So as I told you, I will show you in my next videos how to do that in some IDE. So now spark.sql, and then you have to invoke .sql, spark.sql, and then within double quotes you can select your Hive table, select star from test. Okay, and that's it. So here you need to give database name dot table name. So my database name is default dot test. So I haven't selected any database for creating table in Hive, and that means it is default. If you have any custom database name, then you have to specify it here, else it will say like table not found. Okay, so mine is default dot test, enter. So once this line is executed, the A is a variable name by which you can invoke an action, for example show. So you will be seeing the data. So just like we can wait for the command to get executed. Okay, so now a dot show is the action which I'm triggering. So now your Spark job will be get started. Okay, now you can able to see my data one, right? So the same what I showed you here in Hive. When I select, I will show you again. So select star from test one, and the database table column name is serial number, so we can able to see it here, and that's all. So this video is agenda is just to show you the connection, but in my upcoming video, let me show you like some complex queries like joins between two Hive tables in Spark, and performing some other transformations and actions. Kind of an interesting thing I will show you in my upcoming video. The difference between groupByKey and reduceByKey. So generally, if you Google it in internet, people used to say reduceByKey performance-wise is good. So groupByKey is not good. So how come this performance difference comes into picture between reduceByKey and groupByKey? And if you get a chance to solve some transformations, solve some problem with a transformation, and you think both groupByKey and reduceByKey can help you, in that case, please choose reduceByKey. I will tell you why. And these two are wide transformation. That means in Spark, when wide transformation has a lot of shuffle. Okay, so generally what is shuffle? So I have like 3 input partition and 2 output partition. That means so each input partition has to send the data to both the output partition, right? So we call this part is shuffle. Okay, so when you do shuffle, what are all the things happens in between? So you will have network IO. So the data that passes here, it's over the network. So the more network you get, the more traffic you will get. So that's again a problem. Network IO, and then memory IO. So it's all about like Spark is all about memory, right? So the data that get transferred between machine node to node through network, and again it requires memory to do that. And sometimes disk IO, because when memory is full, then obviously the data, intermediate data will be get written on disk. Okay, so in MapReduce there is no way to do this storage in memory, but intermediate data storage between map and reduce is disk. But in Spark, memory predominantly, but when it is like the memory is not enough, then it will get stored in the disk. So the main goal for any Spark developer is to reduce the shuffle so that you can increase the performance. The job time will be get completed soon. That is what the main goal people always used to do. So here there is no way to completely avoid shuffle, but you can try to reduce the shuffle. So reduce the shuffle means you are reducing the network IO, you are reducing the memory IO, you are reducing the disk IO, and so that the job will move faster. And reduceByKey is suitable for it. So with the help of reduceByKey, you can able to reduce the IO by reducing the shuffle, the data movement between the nodes. Okay, now I'll tell you why groupByKey is not doing that, and how reduceByKey is reducing the shuffle part. I'll tell you. So before that, I will just show you a sample of both reduceByKey and groupByKey. So the agenda is not just to see the sample or the code. The agenda is to really understand the difference between reduceByKey and groupByKey with respect to the performance. So anyway, we can see the program as well. So this is a word count program. So I have, I'm reading the file and then I'm converting it to map. So for each word, we are just adding one, which is incrementally it has to increase. So it's a well-known traditional example. And then I'm applying reduceByKey and I'm getting my result. And the same way I'm doing it for groupByKey, you can see. So with the groupByKey also, we can able to do the word counting. Okay, so let's run this code. I'll show you the output. So if you see here, hello 2 times, welcome 1 time, and hi 1 time. Okay. So now I'm going to do the same with groupBy as well. Okay, so you can see hi 1 time, welcome 1 time, hello 2 times. So I'm getting same output with both reduceByKey and groupByKey. So, and as I told you, this is a white transformation. Both of them are white transformation. Data shuffle will be there. Now let's get into the architecture part. So I'll deeply explain you how reduceByKey is an added advantage. So imagine that you have some data. So let me go with hi. Hi is 3 times. You have 3 hi, and then you have hello, which is 1 time, and is 2 times. Okay. So now this is my input. Okay. So, and this input is splitted into 2 blocks in HDFS. So you'll get 2 input partition in Spark, right? So I'll use the traditional MapReduce way to explain this architecture, the performance part, so that it will be very easy for you to understand. Finally, I'll match this with a Spark term. Okay. So here 2 blocks, so 2 mapper. So okay, mapper 1 and mapper 2. And in map side, the logic what we going to write is I'm going to split this word according to the delimiter which I'm having, and then I'm going to add 1 with it. Like that means the output will be hi 1, hi 1, hi 1, and then hello 1, is 1, and is 1. So you will be getting like this. Okay. So now the data can be get splitted to 2 input partition. It could be like anything in any order. So there is no guarantee like first mapper will get all high, second mapper will get only is. No, it's not like that. So now the first mapper output is hi 1, hi 1, and then is 1. Okay. The second mapper output is hi 1, and then hello 1, and then is 1. Okay, so what I will do, I will add 1 more is to my input file. So that is the third is coming for second mapper. Okay, this is my output of first mapper and second mapper. And we will be having the output partition. Traditionally, we call it as reducer. Okay, so in the reducer side, what I'm going to do is I'm going to do the summation logic. So these words will come here and the summation will happen. So intermediately, okay, so the intermediately what happens here in MapReduce generally shuffle, we call it a sort by key, group by key, and that means so you will be getting the data like this, high off from both this mapper. When the data comes here, it will be like this, and then is, which is like 3 times again, and then hello, which is like 1 time. Okay, then this comes to your reducer, and finally you will get hi as 3, is as 3, and hello as 1. Okay, this is your final output. Now here the data that get transfers from mapper, that is mapper output, to reducer, that happens via network. Okay, and memory IO, network IO, disk IO, everything happens. Okay, now imagine here each of this word uses a separate network, just for diagrammatic purpose I'm saying. Okay, just imagine. So data transfer to the reducer, first data, and then second data from the mapper 1, third data from mapper 2, and I will repeat the same for this mapper 2. First data from the mapper 2, second from mapper 2, third, 4. So now imagine 1, 2, 3, 4, 5, 6, 7. So it uses 7 network IO to transfer the data from mapper to reducer. Okay, in between, because this part, right, whatever I have explained, so this actually runs on reducer side machine only. This part, this shuffle part, happens in the reducer side. Fine. So now if you see here, imagine it takes this 7 network IO. Okay, it won't be like for each word, each network. No, it won't be that way. But for diagrammatic purpose, I'm explaining you this way. So this is how your groupByKey works. groupByKey works along with your mapper. So here this mapper 1, mapper 2 is called in Spark terminology. I can say partition 1, partition 2, or input task 1, input task 2, and this reducer is output task or output partition. That's it. Okay. Now let me redraw the same diagram. Okay, let me redraw the same diagram for reduceByKey. Okay, so you have mapper 1 here, and then mapper 2 here, and then finally your reducer here. Okay, now the same. Okay, so here what reduceByKey actually does is, so before reduceByKey I want to tell you something. In MapReduce world we had something called combiner. Okay, in MapReduce there is a concept called combiner, which we call it as a mini reducer. Okay, so that means the combiner will run on mapper side machine, but it runs the reduce logic. So once the map completes, okay, so on top of the map output, the reducer logic on each mapper will be get executed. So combiner is something, a mini reducer that runs on mapper side. Now the output of the first mapper will be high 2, because the reducer side what you have written is summation of the key. Same key comes, the value you are doing in the summation. So the reducer happens in the first mapper. So here high 2 is 1. That's it. In the second mapper again you run the reducer, means what will happen? So high 1 time, hello 1 time, and then is 2 time. Right. Now this data again it has to come to reducer for summation. You can ask me why 2 times we are doing the summation. Straight away we can do the summation in the reducer itself, right? Or straight away we can do it in the mapper. Yeah, in mapper we have done, we got high 2, but again we have one more high in map 1, right? Again I have to do high 1 plus high 2, then only I will get high 3. Okay, so now here why we are executing the reducer logic mapper and then again we are executing in the reducer, I will tell you. Now network IO. So now mapper output travels to reducer via network IO, and if you see here, now we are reducing the network IO 1, 2, 3, 4, 5. So initially it was 7, but now it was just 5. Because we have executed the reducer logic on each input partition, and this is what reduceByKey does. This is what reduceByKey will do. So when you use groupByKey, there is nothing, there is no change with respect to the shuffle, nothing, as is everything will happen. But when you use reduceByKey, the logic of reducer, the output logic, the output task partitions logic will be get executed on each input partition itself. So because of this, what happens? The outage, the output of your mapper, the volume of data is getting reduced, and unwantedly moving the data during the shuffle is also getting reduced. Now you can see the network IO is got reduced. So this way we can able to achieve more performance. This is not introduced in Spark actually, it was there in MapReduce itself in the topic in the name called combiner. So we use this combiner to increase the performance in the MapReduce. So the same way people are asking us to use reduceByKey when you need a wide level transformation for this kind of use case, rather than using groupBy. If you use reduceByKey, you will have good performance. So this is what like reduceByKey gives to you, and that's why this is performance wise it is good. So in an interview, if someone asks you regarding this performance optimization, especially between these two transformation, try to explain them in this way. It will be very good, so they can easily able to understand. So thanks for watching. If you really like this video, please do subscribe channel. And one more thing I want to tell you is, so if you want to see this time difference for the two jobs with groupBy and reduceByKey, you have to play with a large volume of data. With small volume you cannot see the time difference. Go with some large volume of data, then you can able to see the time difference between groupBy word count and then reduceBy word count. Spark Dedup. How to do dedup in Spark. So this is the practical video of this, just a one-liner syntax. I can even complete this video in just 1 minute also. So I want to explain the use case of this dedup first of all. So how in my case I faced this dedup and how we have resolved it. So the dedup issue. So I want to explain you as a use case. Okay, so first of all, let's understand what is dedup, deduplication. What does that means? So when you have some duplicates in your table or in your record, so removing the duplicate, the process is called dedup. So now imagine that you are explaining a very big story of your project, and in the very small portion you are explaining some cases like dedup. In that case, so interviewer can ask you, when you say that you have fixed dedup issues, so now I am the interviewer, imagine. So the interviewer can ask you how this duplicate entered into picture. So removing duplicate is the process called dedup. When you say I have done dedup, now the question is why the duplicate enters into picture. So a typical answer is you can say the source itself has the duplicates. The data that comes from the source team, they itself has the duplicates. But that is an acceptable answer. But if you want to explain more realistic answer, it will be better. So today I'm going to explain you one such use case which I have done. So we have a lot of use cases for duplicates, but I'm going to explain you one of the use cases for you. So for that I'll just give you my a mini project architecture of mine. So if you see, like, I have MySQL. So I have to use Spark to read this data. Okay, so I'm doing a simple read one-to-one, and then I'm loading this to Hive. Okay, so I'm loading this to Hive. So Hive acts as an intermediate data storage, like staging. So intermediately I have to store. So after you store, imagine the table name is A. Okay, so after storing this data, I have to again do a Spark processing, and then finally I'll be loading the data to Oracle. Right. So write Oracle write. So you can ask me that you can do directly from MySQL to Oracle write via Spark. So why you want to bring the data to Hive and then to Oracle? So that's a different use case. So we have a different use case, like for Hive, why we have introduced Hive here as an intermediate storage. So I don't want to explain that now because the video will be very lengthier. So I'll make a separate video of explaining the complete use case of it. So now the thing is, imagine this is the case. This is the architecture. Okay. So MySQL to Spark, and then again Spark is writing the data what it has read from MySQL as an intermediate table in Hive. The table name is A, and then again you do a Spark processing, reading the A table, and then you do some process and then write it to Oracle. This is a case. Now I want to schedule the whole case, and the scheduler should happen 5 minutes once the job should run. Now imagine first schedule has been executed, so first schedule is running fine, and then the second schedule after 5 minutes again it is running fine. Now when the third schedule gets starts, or somewhere at the mid it get failed. For example, the third schedule gets started, so it is the Spark is reading 200 records from MySQL, and in Hive it is like 75 records has been written successfully, and the balance 125 is in process of writing in Hive. But what happened after completing the 75 records right in Hive, the job get failed. The third schedule was failed. The failure reason could be different things. So maybe the infrastructure issue or code issue or some issue with the scheduler itself. So it could be a lot of issue. So now imagine whatever the issue it is, we have fixed it. Imagine, and then I'm asking the scheduler team to please restart the schedule. So when they restart, what happens here? Now again the job runs, and again it will read the 200 records, and when it writes to Hive, what it will do, it will write 200 full again. So already 75 has been written, but again it is writing the 200. It should write only 125 balance record, but since it's a restart from the first, now the table A will have 200 plus 75, 275 records will be there for the third schedule run. Now here 75 records are duplicates. So now I'm reading this data via Spark processing and writing to Oracle. In Oracle, I'm getting an issue, deadlock issue. For writing duplicates, you are getting deadlock issue in the Oracle. So in Oracle, like, we have the problem of deadlock. Various reasons are there. One of the reason in Oracle write will get failed is when you write duplicates, when there is some primary key constraints are there, you will get this kind of issue and the write get failed. Now after write gets failed, we come to know, okay, there is some problem with the data, and then we queried Hive, because Hive is act as a source for this Oracle, right? So when we try to query the Hive for that particular sequence of the third schedule, for the particular third schedule, we checked in Hive, we come to know we have 275 records for the third run. So that means 75 records are duplicates. We did this group by count of serial number, first column. And each column is like around 75 rows has more than 2 counts, which is 75, right? Because like 75 records should have more than 1 record because they are duplicates already. Now you can ask me a question here. So why can't you avoid the duplicates? Even after the restart, you can consider of having only 125 record as a balance. Why again 200? Okay, that is a different case. Now we have the fix for it. But imagine before the fix. So there was no check. When the restart happens, it will do from the first. But then we did a fix after it. But now the problem we are speaking about before the fix. Whenever you do a restart, it is again writing the data from the first. And with respect to Hive, you will not have any problem because Hive accepts duplicates because we don't have constraints on it. So it accepts duplicates. But when I write it to Oracle, I'll come to know. Now the problem occurred. Okay, so now the problem has been occurred. Now how you will overcome it? So the overcome thing is you have to do a dedup, which you have to drop the duplicates from the table A and then you have to write it to Oracle. Now we enter into Spark dedup. So in Spark we have a function called drop duplicates. It's a one-liner function. You can use it. Drop duplicates. So after you do a drop duplicate, create a new table as A underscore dedup. A underscore dedup. So now what you have to do, previously Spark used to read this table and then write it to Spark. Now you should not use this, because if you use this it will have the duplicates data, right? Now you have to consider this table, read this A dedup and then write it to Oracle. Okay, so this is how like we used dedup for certain cases. Now I will practically show you. As I already told you, it's just a one-liner thing. So first you have to read some data, right? So I'll show you by reading some data. Okay, so I'm reading a data. I'll show you this DF as well. So it has like 5 rows. So if you see 3 columns, C0, C1 and C2. So serial number, name, and then imagine the salary. Okay, let's take it as a third column as a salary. So if you see here, 2 Rahul 1000 is repeated again, 2 Rahul 1000. So this is a duplicate. The whole records of a particular row is duplicated. Now I'm going to use this drop duplicate without, I'm not passing anything to the function. When you do this, what it will do, it will consider the entire row. Now if you see here, so 2 Rahul 1000 has been removed. One record has been removed. So we have only 4 records, right? So now I want to drop duplicate based on a particular column, not the entire records. I don't want to check the entire record. I want to pass with particular column. Let's take this. So if you see here, I have passed C0 here, and that means you have to do drop duplicates based on the first column. It's like doing distant of in the SQL, right? So now if you see, when you take the first column, 1 is repeated 2 times. So that means, so okay, let's take, this is the actual DF, right? So 1 is repeated 2 times and 2 is repeated 2 times. So you will have 1, 2, 3 as a final. You can see here. So now you have did the duplicates, drop duplicates based on one particular column. So both the cases we use. So this also you can use. I have used both, and this kind of drop duplicates also I have used. So most of the cases we used to go for drop duplicates with the certain columns. We used to do a drop duplicate based on a particular column or more than one column, like primary key or composite key, something like that. So in this video, as I already told you, I can even complete this video in 1 minute just by showing this demo. I wanted to explain the full use case of how the dedup occurred and what is the fix for it. PySpark UDF is slow or not. So generally, if you start learning on your own and you search on internet, somewhere you will come to know that people used to say PySpark UDF is slow. What is UDF? User defined function. So we do have some predefined functions, right? Like min, max, uppercase, concat, and these are some predefined function. Some function which is not available in Spark and you want to write on your own is what UDF, user defined function. And if you want to know how to write an user-defined function, I have given the video, and that video is in my playlist. The playlist link is in the description box of this video. You can have a look. Fine. So now what I'm going to do, I'm going to show you whether the UDF and PySpark is slow or not. Okay. If it is slow, why it is slow? So 2 things we are going to cover in this video. First of all, I have to create a data frame with some data. So I'm creating some data here, and then I'm just creating the structure, the schema, and then I'm creating a data frame with the data, comma, the schema. Now, if I do a print schema, I'll get the schema. Also, the data will be there in the tabular column if I give show. Fine. So now what I'm going to do, I'm going to write an UDF in Python, which is PySpark. Okay. So here, you can see I'm just doing an import statement which is required for me to write the UDF, and concat underscore UDF is the UDF name, equal to, I'm using the lambda function, string plus yes. So concat means joining joining 2 strings, right? For example, if I have Gautam Saravanan, if I use concat, it will be Gautam Saravanan, right? So I'm just adding 2 strings. So here S is my string, whatever I'm going to pass, and I have one more constant string, which is yes. So for the every given string, the S should be get added, concatenated. Fine. So now I'm going to use this UDF, df.select concat UDF. So the column name which I'm going to pass is first name. So here you can see in the schema, I have this first name dot alias of name. So the column name is going to be the name. You can see in the output here. And I'm using timeIt function just to record the execution time, like before and after, the start and end. And I'm just doing the minus operation to get the execution time. Now I'm going to run this. Now you can see in the output, I'm getting my first name with yes as last. It got concatenated, right? So it took 0.3 seconds, right? So now I'm coming back because you can ask me like the concat function is already there in Spark, right? So PySpark, right? Then why you are writing it as an UDF? So only with if I write UDF with the predefined function only, I can show you the difference between the time taken of predefined function and the UDF. That's the reason I've just took the existing function which is already available in Python. I made it as UDF and I'm showing you. Now I'm going to use the concat which is already available in the Spark itself, PySpark. So here you can see the same procedure, but I'm not writing the UDF. Directly I'm passing my concat in the select statement. First name comma lit of s. So I'm just doing the concat and then I'm giving name as the column name. So I'm going to run this code. So you can see the output. So here it takes 0.2 seconds. So the UDF is taking 0.3 seconds. So what I'll do, I'll just run it one more time. And again, the second thing also, I'll run it one more time. You will still see some time difference between these two. And if you go for huge volume of data, you will see the very good time difference. Now, I've just proved you that UDF is taking time. Okay. You can ask me whether it is only in PySpark or Scala and Java. So in Scala and Java, we don't have any problem because they are JVM based. Only in Python, we are getting this. Now, what I'll do, I'll just show you a diagram and I will explain you why here this particular PySpark UDF is slow. See, the Apache Spark engine is implemented in Java and Scala, language that run on the JVM, which is Java Virtual Machine. So the use of Python API requires an interaction between the JVM and the Python runtime. So here this is possible by the help of py4j, which actually connects the JVM and Python runtime. So thanks for py4j. Now which allows this py4j, which allows us to call code from the JVM. At the same time, each Spark worker will have a Python runtime running too. For example, you are executing an UDF. When we execute a data frame transformation using native or SQL function, each of those transformation happens inside the JVM itself. Okay, so which is where the implementation of function resides. But if we do the same thing using Python UDF, something very different gonna happen here. First of all, the code cannot be executed in the JVM. That is the first point, because it's Python. It will have to be in the Python runtime. To have this possible, each row of the data frame is serialized and sent to Python runtime and returned to JVM. So this is why the time is taking. Okay, so that is what this image explains to you. So we have some projects like Apache Arrow, which is actually helping us to tune these kind of problems, but we do have some solutions. But with respect to PySpark alone, if try to avoid UDF, try to use the predefined function. So that is the only thing I can tell you. And even you can raise this in an interview, the challenges that you faced in PySpark when you say that your language is PySpark, then you can say these points as the challenges that you have faced. So which will like the interviewer will get some interest on the answers, and you can explain him what we can do, what alternate we can do. Maybe we can write the UDF alone in some other language. So you can say in that way. Moving average in Spark. So recently one of my follower have asked me, like there was a interview question about this. So calculate moving average using Spark. So first of all, what is this moving average is all about? So this is the terminology used in the statistics. And also this is one of the important terminology people use in share market, that is stock market. So you'll be seeing this moving average of 50 days, moving average of daily, moving average of last 3 months. So I'll tell you what exactly it is. So in a statistical definition, right, what they used to call a moving average is a calculation to analyze data points by creating a series of averages. So that line is very important. Series of averages of different subset of the full data set. So that means like generally how you will calculate the average. So I have like 10 records. So then you will be doing first record to last record, you will be doing the summation and then you will be divided by 10, right? So that is an average that you are taking for all 10 records. But when I say moving average, for each record means, so for every record you have to take the average. So for every record, how can I do that? So for every record, it's like you have a series of data and you have to get the series of average. So and that is what we call it as a moving average of salary in a company, or I can say moving average in a stock market for a specific brand of stock. So this is how they used to calculate, or this is how they used to expect us to calculate the moving average. So I just told you the example, but I haven't given you the formula or the way how to bring this calculation, right? So I'll tell you that. So let's get into the practical part now. And one more thing, this moving average is also called as like moving mean or rolling mean. So this is something I just wanted to tell you. Fine. Okay. Now if you see here, like I'm going to show you with at some 10 records, it's like a salary based on the role. And then with this, I'm going to take the moving average of a salary for a given role. That's it. Now imagine like if you go for websites like Glassdoor, right? So you will be searching for what is the salary for a 5-year experienced data engineer. So you will be getting some output from different websites. So one such as Glassdoor, and very sure like all 5-year experienced data engineer will not get the same salary. Some ups and downs will be there, but how they are calculating with one value is it's all about average. Either it will be a complete average or it will be a moving average. And another live example I can tell you is stock market, right? Fine. So I just created a column by using sequence, and then I'm created a data set again by using sequence. So and then I'm just creating an RDD by parallelizing the data. Fine. Now I'll run this, and I'm using two imports. One is window. I'm going to use a window function, and then I'm using an implicit function also. Fine. So let me run all this. Okay, created a column and data set. Now the next point, I'll just clear my screen. So the next thing is I have to create an RDD. Okay. So yeah, I created an RDD. Now I'm just converting it to a data frame. Also, I'm just creating a column for it. So you can use this one, which is in line number 21, or this one, line number 23. Both are same. Since already we created a val columns, it's already available. So I'm going with line number 23. So now I'm just converting it to a DF. So I can do a show here. I'm sorry. So this will give you the data frame. So you have name, role, and salary. Fine. So now what next? So, and that's all. So this is the line, very important line, the requirement of the code itself. So val moving average, that is move average AVG equal to df from RDD is the variable which you can see in line number 23. I'm just passing it here, and with column, which will create a new column for the given transformation that you are doing. So now moving average, comma, average of salary. So you are getting the average of salary, but then you are doing a window function here. Over is a window function. So window.partition by role. So role based, you are doing a partition, and then you have something called rows between. Like since we are using the window function, so you need to know like how many records for the given window it has to be. How many records I have to bring it to a window. So that is what like the row between. The rows between is a main important part here. So -1, 1. So this is between actually. So that means -1, 0, 1. So -1 represent the previous row, 0 represent the current row, 1 represent the last row. Okay, so if you consider here, I'm going to get the average, and that is a moving average for row by row. So if you see here, if I consider if I take the record Mike, right? So when I take Mike, so it will consider the previous record Rahul, current record Mike, next record Peter. So I'm yet to give you the formula of how to calculate the moving average. So for that, I'll first show you the output. Just copy this line, and then like you paste it here. Fine. So now I'll just clear my screen. So now I'll just do this moving average dot show. So now you will be seeing one more additional column because we have used with column here. Yeah, moving average. And now you can get the records here. Now, the first thing I want to tell you is role based we have done. Okay, role based we have done the partitioned by row, and it is like the function what we have triggered is average, and rows between we have given. So it's role based. Fine. So what about the first? I'll just pick you one record which is in middle. Okay, John, 65,000, and if you see the moving average for this particular record is 72,333. And how is that calculation is? So I'll just show you here. So the rows between what we have given is -1, 0, and 1. For every given record, you have to consider the previous record, current record, and next record. So in that case, for John, it is current row. For John, you have to consider the previous row's salary, which is 70,000. Plus then 0, which is the current record, which is 65,000 is the salary, plus the next one, which is 1, right? So next one, -1, 0, 1. Next record is 82,000. Okay, now equal to 217,000. Okay, divide by 3. So what is the output you are getting? 72,333. Yeah, that is what the moving average of the second record. Now you can ask me an interesting question. What will be the moving average of first record? Because we don't have a previous record for first record. So what generally Spark used to do when it is a first record, it used to consider only the current and next row. Okay, not the previous. So in that means if you consider the first row, which is 70,000, which is the current row, plus the next 65,000. Answer 135,000. So 135,000 divide by 2. It's not 3 because we considered only 2 rows, right? Current and next, because there is no previous. So 67,500. And the same way for the last row for the given partition. So the last row in the partition is this one, Saran. It's not Kumar. Okay. So in that case, it will consider the previous row and current, not the next. For each partition, first and last row will be calculated this way only. Okay. But whatever you see other than first and last row, it goes with 3 records like previous, current, and next. And the same thing happens for the developer. This is the next partition, right? One is test partition and tester partition, and the second row is developer partition. And again here this one is the first record, so it will consider the current and next, not the previous. And then for last developer, it is previous and current, not the next. But in between whatever you see the record, it will consider previous, current, and next. Okay. So this is how the moving average has been getting calculated. So this video, it's like I showed you with the salary example for the moving average, but in internet, if you see, like, a lot of programs are there even for stock market, so you can just go through, you can just search for it. And this is something I got from so many people in recent days, like they are asking this in an interview. So that's why I made this video, a topic in Spark mlib called FP growth. So in Spark, we have Spark Batch, Spark Streaming, Spark SQL. So in the same way, we have something called Spark mlib, which is called Machine Learning Library. So under which we are going to discuss about an algorithm called FP growth. So FP growth, a full form, it's like frequent pattern growth. So generally, like, I can tell you an example before starting this. So you might have heard about market basket algorithm that generally people use as a marketing strategy to identify how frequent an item set occurs and how frequent this item can be placed together with some other item so that the sales opportunity will be get increased. So that is what we call it as an MBA algorithm. So MBA algorithm consists of so many pieces. So one such piece is to identify the frequency of an item. So that is what FP growth gives. Okay, so now we are going to discuss. So this is actually 2 videos actually. So one video I'm going to explain the basic today, and continuation to it, I'm going to explain you the next level of the same market basket algorithm in the next video using Spark, how to do it. Okay, so today let's make it as so simple. So the very first piece that we are going to discuss in this market basket algorithm is FP growth. Okay, so here, as I told you, it is to calculate item frequencies and identify the frequent items occurs. That's it. Okay, so now to calculate this, right, so just we need to give some input to get the frequent items that occurs in my transaction. So we have to give 2 informations. I need to give it as an input to my algorithm. One is support, we call it as minimum support, and then minimum confidence. So before getting into it, you can just see my item set. So I have 3 transactions. As a shop owner, I have 3 transactions, 3 bill. Okay, so first customer is getting milk, bread, egg. Second customer, milk, bread, juice, and egg. Third customer, milk and bread. So now I need to identify list of frequent patterns that occurs, item set that occurs in the overall transaction. So based on that, I can rearrange my objects. So for example, I have egg in one shelf and then milk in another shelf. So if I have the probability of the combo of these 2 items is giving me higher sales, then I can just bring these 2 objects in a same shelf, so that in a same shelf, so that my sales will get increased. Okay, now minimum support. What is minimum support? Item occurs as frequent. So that is what the minimum support is all about. So how to calculate it? Now imagine you want to understand the frequency of milk. Imagine. So you have total, like, you have 5 transactions, out of which 3 transactions consist of milk, means the minimum support calculation is 3 divided by 5. You can see here 0.6. So now the confidence. So confident, how often an item occurs together. So that is where, like, the confidence comes into picture. the confidence that you are giving as an input for each item set in your transaction. So for example, you have X as a separate item and just X only sold out. It's like 4. Now combination of X and Y, the people who buy Y also buy X is 2. Only 2 people are interested in getting this combo of Y and X, but just X there is 4 transactions. So that means 2 divided by 4. So that means 0.5 is the confidence where people who buy Y also will buy X. Okay, so like that we have to build a general, it's all trial and error. The numbers what you are going to give as an input for minimum support and confidence, it's all about trial and error based on your sales and based on your daily transaction and based on how frequent you have to build this model. It's all depends and it changes. Fine. So let me show you an example so that you will be getting a better clarity. So I'll just show you the Spark code. So here I'm just doing the ML import FP growth and then I'm creating a data set. So I have this 3 records and then I'm just converting it to a map and then I'm saying this records are delimited with space and then I'm converting it to a DF and I'm naming it as items. So next I'm creating an object for my FP growth class and then set the minimum support and minimum confidence. Here we are giving as 0.5. So it's like a very what to say, an average numbers that people used to start with, but you can still reduce it, but reducing it will give you the list of all the item sets. So that is, there is no use of it. So always people will start with a decent of this 0.5, but again I'm telling you, so it's all about trial and error, as I just wanted to pick one item and with that item I calculated the support and confidence. But if you want to calculate with more items, then the calculations will get changed. So now I'm just building the model in line number 10 and then I'm just printing my model. I mean, it's the output. I'm just giving a show. Now back to my Linux. Okay, so I'm just imported. I created the data set and then minimum support 0.6 and confidence is 0.5. Now show. Now you can see here. So I have bread, which is like 3 times. So so if you see here, I have bread 3 times. The frequency of bread is 3 times. The overall transaction is also 3. So the frequency of bread is also 3. So it starts from higher order. So if you see here, bread 3 times and then milk is also 3 times. And combination of next high level combo is milk and bread combination is 3. But if you see, there is no other combination that comes for 3, which is like equal to the total number of transactions, right? No, right? And then next egg, 2 records. And then egg and milk, so which is the next leading product. It picks egg actually. So with that, what is the leading combo of it? So egg and milk, egg, milk and bread, and egg and bread. Now we can able to see this. So imagine, you can ask me why juice is not there in the list or juice and egg is not there in the list, because it is very minimum. It is very less. It's just one transaction out of 3 and there is no need of calculating it. So now imagine if you reduce the number like from 0.6 to 0.1 or 1, minus 1, if you reduce it, you will be get printed with all the records. So there is no use of it to calculate this frequency patterns, right? Now imagine what if I put 1 for my algorithm. For means I'll give 1 as a input for my support and confidence. So now I'm going to give 1 for my minimum support and minimum confidence. So when you give 1, what happens, you can see. Now I'll just build this and then show. So you can see here, so before when I give show, when my support and confidence was 0.5 and 0.6, I got these many records. But when I changed it, both support and confidence is 1, I'm getting only 3 records, because it gives you the higher amount of items that got a transaction of with respect to the overall records that you have. You have 3 records, transactions. Out of 3, this particular combo and this particular individual item is present in all the transactions. So that is how it is giving you. So bread 3 times, milk 3 times, and combination of bread and milk is again 3 times, but no other product or like occurred for 3 times, or the individual item occurred for 3 times, nothing, right? So when you increase it, you are getting in this way. So if you want this way, you can go with 1, or you want to reduce it to get more number of items in the combos, then you can reduce it to 0.7, 0.8, 0.6, something like that. So this is all about the frequent pattern of an item we are identifying. That's it. So next level is association rules. So that is what the core algorithm part we implement in market basket algorithm, that I will show you in the next video. So that gives the confident and support count, the number for each of the transaction and each of the item that happened actually. So with that, we can able to confirm a lot so that the marketing team will make use of crosstab in PySpark. So crosstab is a very familiar concept that we do have in Python, in Pandas as well, but in PySpark, how to do that. And before getting into crosstab, I'll tell you what this crosstab is all about. But before that, I just wanted to show you a small example before we start knowing what is actually a crosstab. Fine. So if you see here, I have a data set for today's exercise, and I've just created a data set and I'm converting that to a data frame. So you can see here I have name and age. So I have 6 records here, and then I'm creating an header as name and age. Now I'm creating a data frame, data comma header and df.show. Let me execute this first. Okay, so now if you see here, I'm getting the name and the age. If you see Gautam 29, Rahul 25, and again Gautam is repeated 29 and Rahul is 25, and one more record Saravanan 30, and again Gautam is repeated with a different age of 23. Now I want to do a group by and get the count. Imagine. So that is very easy, right? So df dot group by name and then dot count dot show. So now you will be getting Gautam total record as 3, that is with the age of 29. So if you see here the age of 29, I'm having 2, plus with the age of 23 I have 1 record for Gautam, so totally 3. Rahul, so with the age of 25 I have 2 records, so only 2, so 2, and Saravanan it's only 1. Now what exactly the crosstab is? So crosstab, otherwise called as contingency table. So what exactly this crosstab does is, you have a data set and actually the frequency between 2 or more than 2 variables. So crosstab actually shows us the frequency between 2 or more than 2 variables. In statistics, this crosstab is very familiar topic actually. So it represents a matrix format of table, the data into a matrix format, and then it shows the frequency distribution of data between the variables. Okay. So this all like seems to be a technical term to understand, right? So let me show you an image, then you will really understand what exactly a crosstab is. So this is actually a crosstab. So if you see here, female cake, female who loves cake 4, and then female who like ice cream 3, female who like donut 6, and then male again cake. So here female and cake is variable, and we are just seeing the values. For female is to cake is 4, and female is to ice cream it is 3, female is to donut. So here we have female is 1 variable, cake as an 1 variable, and female is 1 variable and ice as another variable, female as 1 variable and donut as another variable. So now we are getting the distributions of data between these 2 variables. So this is what actually a crosstab is all about. So now how to achieve the same with respect to PySpark? So now df dot crosstab and then name. So it just takes 2 arguments, so name and age dot show. So now we will be getting a crosstab here. Now if you see here, name age is a column that has been created on its own, like we can have a custom column name as well. So here if you see Gautam, this is 1 variable, and age 23 is another variable. So Gautam is to 23. So we have 1 record, like you can see here the last record here, and then Gautam 25 no record 0, and Gautam 29 we have 2 records. So this one, the first record, and the third one. So similarly Rahul and then Saravanan. So this is what a crosstab is all about. This is just to identify the frequency table, or otherwise called as a cross table. They used to call it in either way. And also we have something called contiguous table, which is in the statistical world they used to call it in that way. So this is all about getting the frequency of your table. This is what all about this crosstab is. So this is actually asked in one of the interviews, so that's why I just wanted to make this video, so you can practice this more. You have more sub options as well. You can just practice this, how to remove null values in a data frame using PySpark. There is a lot of ways to do, so I'm going to explain you one by one. So this is actually an interview question, so that's why I just wanted to make this video. So just we have to create a data frame now, and just we can have some data sets being get populated. So I have a data set, so you can see here I have 5 records, and these are like around 5 rows and 4 columns: name, job, age, and salary. So I have just created, I'm just going to create a data frame with this schema, and total number of rows I'm having 5. So it has null values as well. So wherever you see none, it's actually a null value. So I'm going to execute this. So now df.show. So now you can see like I have 5 rows and then 4 columns, and if you see in the very first row I have job as null, and in the second row there is no null value. Third row I have 3 columns as null, and fourth row no null, and finally for fifth row everything is null. So now we have a functionality called drop NA. It's a function. So by using this you can get rid of null values, and we have different types of using this drop NA. The very first one, so drop NA, how? It's a keyword. Now I'm going to give any and then dot show. So now when I execute this, if you can see here, any, like it just takes the first row and it checks it has any null value. If so, it will exclude that, it will eliminate that, and it will take the second row, it checks is there any null value? No. So Jack record has been come, and then third Mike record. So it has any null value? Yes, it has more than one null value. So it just removed this particular row. And then fourth row doesn't have any null values. And finally, last row has all columns of that row is null. So it is excluding that as well. So next one, like any, you have something called all. But when you give all, it checks for entire row which has a null value, it will be get removed. So if you see here, the last row has been removed. So when you have all rows, it's null, then you can use this to get rid of it. Now next thing, how to specify it in column wise. So I just need to remove it in column wise, right? So first of all I'll just make df.show. Now let me do here, so I'll just remove this. There is something called subset. So column wise you can able to remove the null values, means you can remove the row based on the column wise null values. So I'll go with salary dot show. Okay, so if you see here in salary column, I have 2 null values which has like third record and then fifth record. So this 2 record, the entire row has been eliminated. So I'm getting only 3 records. So this is subset, that is column wise you can able to have a filter condition. Now we have something called threshold. So I'll tell you what is threshold after showing you the output. Thresh equal to 1. I'll go with 2 first. So what it actually does is it just check for the first row, and the threshold is 2, means it checks for is there a column in the first row has equal to 2 or more than 2 not null values. If you have more than or equal to 2 not null values, then that row will be get presented. So if you see here, the very first row has more than 2 not null values. It has Gautam and it has a age 29 and it has a value for salary as well, right? So then it will print it. Second, so if you take the second record, Jack engineer and then 35, it doesn't have any null values and it has more than 2 or equal to 2 not null values, so second record will be get printed. If you take third record, it has not more than 2 not null values or not there. Only one not null value is there, so it is excluding it. Then fourth, its entire row will be returning because there is no null value, and final row has been eliminated because there is no not null values. Now if I change my threshold to 1, then I will be getting the record Mike. See, because at least you have one row in the one column in the entire row has a value, right? It should be equal to or greater than 1 not null values. That's very important to underline, not null values, right? So these are the different types how to get rid of null values records, the entire row. Okay, so as I told you, this is an interview question, so that is the main reason I just wanted to make this small exercise as a video. Spark data lineage. So how to get the Spark data lineage information in your command line or in your log. Okay, so first of all, what is lineage? So generally when you say a lineage in your relationship in a bloodline, we used to say son, father, and then grandfather. So that is actually kind of a lineage we used to say, right? So similarly here in Spark, we have the lineage of the transformations, the list of transformations that you are doing. Imagine you are first reading a file, transformation gets started, and then you are doing some join, second transformation, and then you are doing some filtration, third transformation, and then you are applying some map on top of it, fourth transformation. So you have all these list of transformation which has been recorded in Spark. So this is what a lineage that get maintained. It's about your RDDs and data frame transformations information will be get maintained by Spark. It is not actually the data, the input data. No, that is not. It actually records the information about what are all the list of transformation has been get executed. As you know, it is a lazy evaluation. Until you invoke an action, your transformation will not get started. So now all your transformation will be get stored somewhere, and this is what like in Spark Web UI we can see in the DAG format. Also you can see you have a specific syntax which you can use to get the information in the logs as well, and even you can do that in the terminal as well. Fine. So this is I just need an example to show you, right? So that's why I just use Spark word count. So in this video I'm not going to explain this word count program. I have a separate video for that. You can check that from my playlist link, where I have given the in the description I have given the playlist link which has all the big data videos where you can find Spark word count program. Fine. So now the very first line I'm going to execute is I'm going to read a file which is my input file which has some words. I'm just reading it, first transformation, and then I'm applying flat map. This is for delimiting, saying that my records has been space delimited. So next is I'm just passing map, so to split that into key value pair, and then I'm invoking reduceByKey. This is for grouping. So we have sortByKey and groupByKey, which actually does the final summation. Okay, so this is a wide transformation. Fine. So now what I'm going to do, this is my final df dot collect just to get the output. Okay, so you got the output. So now the agenda of the topic is how to get to know the data lineage, how to print the data lineage. So this is actually interview question. So many of you who is watching the video, you are already aware of it, but still few they are not aware of it. So one of my viewer, he asked me like how to print the data lineage, how to get the data lineage information. So for that, what you can do, your final df dot to debug string. So it could be your final df or it could be your final RDD. So debug string. So you can see debug string. So this will actually gives you the data, complete data lineage, where you can see first you are reading the data, and then you do a flat map, and then you are doing a map, and then reduceByKey. So top to bottom. So now you can see, so first we are reading a file, and then we are doing a flat map, and then we are doing a map, and finally the reduceByKey. So this is what the data lineage is all about. So you can ask me like I am the one who have written the code, so I know the list of transformation what I have used. So why I need to use this debug string to get the lineage information. So imagine that you are working on some existing code, or you are just running the code, or you are just testing the piece of code with someone else developed it, and you just need to know how it is working in the runtime. What are all the lineages been getting called? So you can use this. So and the second one is you can ask me, now you are just showing by printing it in the console, but what happens in the real time in the production? We used to build it as a jar file, right? So this works for PySpark, Scala Spark, Java Spark, and everything. So in real time we used to build it as a jar. So in your code you can add this to debug string, and you can just add, so this will be get printed in your log. In your web UI, Spark web UI, you can able to see in Yarn application master, you can able to see, or if you have integrated any logger, so this will be get printed on the logger also. Okay, and moreover, this will be helpful when you start exploring persist, cache, and checkpointing. These are some of the concepts where we used to store the intermediate data. Okay, I'll be covering this topic in my upcoming videos, or if you can find these videos already in my playlist, please go through it by the time. Okay, so now this agenda of the video is to just get the information of the data lineage. So we are just printing it. You can see in your Spark web UI, so you will able to see that from your DAG. You can see here, right? So this is also stage by stage, you can able to see the list of transformation that has been happened, right? So for one stage is for all narrow transformation, and for every wide and narrow there will be a separate stage, wide transformation and narrow transformation. So there will be a separate stage. So narrow transformation is a transformation without shuffle, wide transformation is a transformation with the shuffle. That's why it just created a separate stage for it. And understanding the Spark physical and logical plan in a layman terminology. So I'm just going to show you a code. So this code, it creates two data frame, and then we are going to perform a join, a left join. So that's it. It's so simple. So the agenda of this session, the agenda of this video is to not to walk through this code, because it's a typical join data frame to data frame join code only. So here I'm gonna use this code to show you the physical and logical plan. So before getting into that, let's quickly have a walkthrough on this diagram. So this is the complete diagram, like what happens if I submit a SQL query or a data frame in Spark. So what internally happens with respect to the plan. So the first thing, when you submit from the left hand side, if you see, either it could be a SQL query or a data frame. When you submit, what happened is it creates an unresolved logical plan. And what does that mean? So unresolved logical plan validates the syntax of the query. It just validates the syntax, okay? And it doesn't validate the semantics, meaning it won't check for column name existence or data types or table name. So that information, for example, you would have given a column name as serial number, but that column was not even present in the data frame. So that kind of checks will not happen in the unresolved logical plan. It just checks, okay, syntax wise, it's all good. Okay, then it goes to the next phase. So here we have something called catalog and analyzer. So what this catalog and analyzer does? So catalog is kind of a repository which holds all the information about your table, Spark table, data frame, and data set. And here the data from the meta store is pulled into the catalog, which is an internal storage component of Spark. Okay, it holds the metadata information about all your data frame, data set, and everything. Now, the analyzer, what analyzer will do, right? It actually verifies the semantics like column name and column existence, and then the table name, whether the table exists or not. So all these verification will be done by analyzer from the metadata about your data frame and data set, which is available in the catalog. Okay, so now it's all done. So it does the unresolved logical plan, which is syntax wise and semantic wise. Both the thing is completed. Now it moves to logical plan. So logical plan is it's like it holds an abstract of all the transformation steps that you need to be performed. That's it. So the next is optimized logical plan. So this box. So this what this optimized logical plan. So after the resolved logical plan is generated, it is then passed to a catalyst optimizer. Okay, so optimized logic plan is something internally it does. What it does is it has the catalyst optimizer. So now which will apply its own rule and it will try to optimize the plan. Basically, catalyst optimizer performs logical optimization. For example, it has few points. So the first point is it checks for all the tasks which can be performed and computed together in one stage. It will check for that. And the second thing is in multi-join query. For example, you have some multi-join query and it decides the order of execution of query for better performance. And the third example, it tries to optimize the query by evaluating the filter class before any of the project, that is before any of the steps that you have. So this in turn generates the optimized logical plan. So next part is physical plan. So physical plan, like it is simply specify how your logical plan is going to be executed on the cluster. That's it. So it generates different kinds of execution strategies and then keeps comparing them in the cost model. So you can see here it has something called a cost model. What this cost model will do, right? So now physical plan generates more than one plan. Okay, so it generates more than one plan for the same logical plan. So now this cost model will give you information for each of the physical plan which it is generated, right? It gives the estimation of the resource gonna be used and the time gonna taken for completing the job. So out of all these cost model provided for all the physical plan, it selects the best physical plan and then it sends for the execution. So this is what a physical plan used to do. For example, I can give you an example. Let's say like we are performing a join query between two tables. In the join operation, we may have a fat table and a thin table with a different number of partition scattered in a different nodes across the cluster. Now Spark decides which partition should be joined first. So the type of join it has to be happen. So these kind of like better calculation it does internally. So that is what this physical plan along with the cost model happens, and it finally chooses the best physical plan. And then the last final thing is once the physical plan has been selected, right? So it's like I have the last box, selected physical plan. It's a time to generate the executable code, which is what we call it as a DAG for the query that is to be executed in the cluster in a distributed fashion. So this process is called code gen, and that's the job of Spark Tungsten execution engine does. So the code gen is, I'll show you another image for this code gen part. So imagine, let's say like I'm passing a query. So you can see here, I'm just showing my notepad. So here you have this query. So this is what an input that you are sending, and then all this plans all completed, and finally the tungsten engine, it tries to generate a code gen, right? So what actually does, it gets this query as an input for the tungsten engine, and then it generates a code something like this: long count equal to 0, and it has a for loop for iteration, and we have given the limit as 1000, right? So this is what the executable code internally the tungsten engine generates. We call it as a code gen. So this is all the plan. Whenever you execute any of the data frame or Spark SQL query, this is what happens internally. So this has been widely asked in the interview as well. So what I'll do now, I'll just show you, I'll execute this query, the complete code, what I have here. It has 2 data frame, and I've created column names and all, I've done all. So now I'm just going to run this. So the agenda is not to get the output, it is just to see the internal plan, like the logical and physical plan. So for that, what you can do, final data frame name, that is result dot explain, and then you can give extended equal to true. So when you run this, you can able to see the passed logical plan, which is unresolved plan, and then analyzed logical plan, and then optimized logical plan, and finally the physical plan. So all whatever we have discussed in the diagram, I can able to see here when I execute this result.explain extended equal to true. So for example, if you see this parsed logical plan where it is not checking for any of the column names, but if you see in analyzed logical plan, it checks for the schema. So that is what, so unresolved logical plan checks for the syntax, but analyzed logical plan checks for the semantics as well, the information about the column existence, table name existence, and etc. So optimized logical plan, and then finally we have the physical plan. After this catalyst optimizer have been completed, the optimized logical plan will be get generated, and then you have the physical plan. So in the physical plan, you will be getting more than one physical plan, and based on the cost model, it picked the best one, and with the best one, it internally generates the code gen used by Tungsten. Okay, what it's executable code, what Spark can understand for the query that you have sent. So this is what I wanted to show you for the diagram, whichever I have explained. The Hadoop multinode installation. So before getting into it, I just want to give you a quick introduction about this multinode. So the Hadoop cluster infrastructure, we used to call it as master slave architecture. Okay, so one master and remaining all slaves. So before version of Hadoop 2, that is in the version of Hadoop 0 and the version of Hadoop 1, there is only one master concept. So we call it as single point of communication. When there is a single point of communication, short form we used to call it as SPOC. When there is an SPOC, for sure you will be having SPOF, that means single point of failure. What happens if that one master goes? Everything is gone, right? All your Hive job, the HDFS jobs or MapReduce jobs, Peak job, everything is gone, SQOOP job, and everything is gone. So after Hadoop 1 version, that is in the initial of Hadoop 2 version, they have introduced a concept of 2 master, that is more than one master concept. That means you can have active master and then passive master. If something happened to active master, passive master will take over. So that means the high availability enter into picture for the cluster. So that means there is no single point of failure. Okay, so from Hadoop 2 onwards, we got this option of having more than one master. So today you can ask me which type of multinode you're gonna explain. So I'm not going to show you active passive master configuration today. I'm just going to show you how to do a multi-node with one single master. Okay, so in my upcoming video, maybe I can show you active passive master, how to do that in multi-node. I'll show you, but now today I'm going to show you Hadoop multi-node with Hadoop 2 version, but only one master concept. Okay, because as a developer, if we go, we are not going to get more into this Hadoop installation stuff and all those stuff. But still, like to understand and visualize and to feel how the multi-node looks like. So that is where like we are getting into this. Okay. So if you want to get the complete video of big data, I have shared my playlist link in the description box where you can find the complete tutorial of big data. Okay, so let's get into the topic. So I created three mission in AWS. So in cloud, I have done. So it's not like you need to have cloud mission. It's not like that you can have even physical laptops or desktops in your lab or in your office. You can connect those missions with the LAN and the same network is fine. So here I'm going with AWS, or it could be a different cloud provider. You can create instance or mission in the Google Cloud or Azure or whatever it is. So I created three instance in AWS. So we call it as node. We can try to call the jargons which people use. So each and individual mission is called as a node, and group of node is a cluster. So you're in an interview. In an interview, you are getting a question like, what is the cluster configuration, or what is the cluster size? When someone asks you, you have to say how many number of node that you have in your cluster. So group of node is called the cluster. Individual missions are called node. For example, you can say my dev cluster size is 30 nodes of cluster. My production is like 100 nodes of cluster. So you have to say like this. So here I created three missions. So in AWS, whenever you create an instance, you will have two IP address. One is public IP address and private IP address. So public IP address used by humans to interact with the mission. So we used to connect with this IP, public IP. When a mission to mission connection, it goes via private, which is the equivalent of the public. So don't get confused. If it is a normal physical laptops or desktops where you can go with one IP address only, but in cloud in AWS I have this two, but don't get confused. Just try to imagine these two IP addresses are same. Just imagine in that way. So now I am going to decide which node is should be act as a master and which node should act as a slave. So I take my first node as a master as well as slave. That is highly possible. So the recommended one in the real time, master node should have only master daemons. It should not have any slave daemons, and that is the best practice. But now since I have only three node, I will try to show you three slaves by making master also to act as a slave. Okay, so I have one node which is master, also slave, and then two dedicated node for slave. Okay. So now you have to create this mission and try to check whether these all comes under the same network. So I use a tool called Mobex Stream. It's a tool where I can open multiple terminals to connect my remote mission. So you can do with Putty also, but I'm instead of Putty, I'm using this so that multi-node will be very easy for me. So I just opened three nodes, and you can see I have three instances that I have connected. So master, slave 1 and slave 2. So totally I have three missions. So already everything is done from my end, but I'm going to show you like as a step-by-step process. I will show you. But before getting into it, so by the time you are aware of Hadoop distributed file system, the theory stuff, and then you know how to do single node also. If you are not aware of single node, I have mentioned that single node video link also in the description box. Please go ahead and first watch that video, and then only you can able to understand this multi-node. Okay, so now you know, like we have 5 daemons, right? So what are the daemons? Name node, resource manager, node manager, data node, and secondary name node. So whereas name node and resource manager is a master daemon, node manager and data node is slave daemon, and we have one secondary name node. Okay, so totally 5 daemons. So if I make my first mission as just a master, means only 2 daemons should run. Okay, node manager, name node and resource manager. But in my case, my master node is also act as a slave. So that means, so in my master node, 5 daemons should run. So this is my master node. Let me do a JPS. You can see the IP address ends with 116. So 116 is this mission. So which is both master and slave. You can see all 5 daemons is running. You can ask me why all 5 daemons are running, because my master node also act as a slave. So you can see data node and node manager. Also my first mission is going to act as a secondary name node. So if I go to active master, passive master configuration, then secondary name node will not run on active master. It will run on passive. So as I already told you, I'll make a separate video for that, and that we can discuss in detail. Okay. So now I will go for one of the slave node and I'll do a JPS. And how many daemons should run in slave? So any guess? You can pause the video and think for the answer. So in slave node, 2 daemons, which is data node and node manager. Data node is slave for name node, node manager is slave for resource manager. Okay, so data node is for HDFS and node manager is for MapReduce jobs. And similar to that, name node is for HDFS, the master resource manager is for MapReduce. Okay, so and then there is one more slave node. Let me go there and do a JPS. So it's like data node and node manager. Okay, so the very first step, what is the very first step to do? You have to download, and the prerequisite packages you have to download. Let me go to my home. So you have to download Hadoop, some version of tar file, and then JDK. greater than 1.8. So now if you just download these two, Hadoop and JDK in all the machines, including master and slave, and then untar it, just you have to uncompress it. So the command is tar space hyphen ejectxvf and then the file name hadoop hyphen 2 dot tar zz. So this will unpack your compressed file, and the same command for your JDK as well. So tar space hyphen ejectxvf and the JDK. So just unpack it. So once you've done it, untar, you will see the folder as Hadoop 2.9.1 and then JDK 1.8.045. So you have to do this in all the three machines. Okay, what is the next step? So you have to do the environmental variable setup. So where you have to do that? So just do ls-a. This will show you all the hidden files and directories. The file and directory which starts with the dot, right? So that is hidden directories and files. So this is the file where we used to set all our environmental path and variable. So here you have to set the environment path and variable for Java. So the last line, you have to come to the last line. So just click escape shift G, which will take you to the last line. So the last line will be fi, the close loop of if, the close of if loop. So next to it, you have to add export Java home and the path of your JDK and then export path. So these two lines are very important. So add this, come back, save the file, and then you have to execute the file with the command dot space dot bash rc or source space dot bash rc. So this will execute your bash rc file. Okay, so now the very second step is setting up the environment variable, which is done. Okay, what is the next step? So the next step, it is like kind of a network topic you are supposed to know. So generally how we are connecting to this remote machine through SSH. So you are aware of SSH, right? Secure shell. So SSH is something that you can connect your remote machine through SSH. For example, SSH space, you give some IP address to which you can connect. So when you give the IP address and click enter, it will ask for the password because you have to be get authenticated. Right. So for example, from master node, I'm connecting to slave node means, so I'm giving SSH, the slave node IP means it will ask for the password. Okay, and you are connecting to putty is actually an SSH. So now why we are looking into this topic, right? So when you start Hadoop, how you will start Hadoop in multi-node? So do you go to each node and you will start? No. So we'll start Hadoop only from the master node because it is master slave. So you don't want to go for each and every node to start the daemons. You just start all the daemons from the master node only. If you take, there is a NoSQL database called Cassandra. Cassandra is a peer-to-peer, it's not master slave. So in Cassandra, you have to go to each node to start the daemon. But in master slave, that is in Hadoop, it is not that case. So when you start Hadoop daemons from the master node, what happens internally? So master will connect to all the slave nodes via SSH and it will start the daemons. For example, this master node will connect to the slave node and it will start these two daemons, data node and node manager. So that means each node internally have to do SSH. When you do an SSH in a very fresh node, it asks for password and like you will get an error like authentication error. That means master node couldn't connect to slave node because slave node is not allowing the master node to connect via SSH. So for this, what you have to do? So the step what I'm going to tell you is common for all the three nodes or all the nodes in the Hadoop cluster. You have to generate a SSH keygen. The command for it, SSH hyphen. So this is not part of Hadoop. Any cluster installation you go, this is something common. SSH hyphen keygen space hyphen T space RSA. Okay, I have given the command in the step you can see here. I'm going to share this in my blog and I'm going to share that link in the description box of this video. Please have a look on it. So you have to generate an SSH key for all the nodes, for all the all the node keys in all the node under this path. Okay, I just ignore this line. Okay, this is not required now. I'll tell you what is this. So here, generate the key. Okay, this is what I was supposed to read. So SSH keygen hyphen T RSA 4 times press enter. Okay, after you go for this command, just blindly enter 4 times. Just press enter. So this will create an image. So I've already done it, so I'm not going to do it now. But when you just do a 4 times and enter, it will show you an image. Okay, you can able to see an image in the terminal itself, and that image is what the key you have generated. Now you have to do this for all the nodes. So now once you generated this, right, where I can get the key? Okay, so after you do this SSH hyphen keygen space hyphen T RSA, you can see a directory called .ssh would have been created in your machine. Go to this directory. Now do an ls-lstr. So now this id underscore rsa.pub is what the key that you have generated with the command ssh hyphen keygen space hyphen T RSA. So I'm gonna do a cat for this file. So I got some key. Okay, so this key is actually an authentication key of this node. So like that you have to do for all the 3 nodes. Now collect all the keys from each of the node, do the keygen again here, go to SSH directory. I'm gonna do a cat of this id underscore rsa.pub. Okay, the same. You have to do that SSH hyphen keygen space hyphen TRS. You have to execute here. 4 enter again, and then you will get an image, and that image is what this key. So this key is unique for this node. And then go to this third node, do SSH cat id underscore rsa.pub. Okay, so you got the key. Now collect all these keys. So you can see something I've done here. Node 1, node 2, node 3. I've collected all the key, and these keys are not same. They are unique. So now collect all the keys. What you're gonna do with this? You have to share these 3 keys in all the nodes in a file called authorized underscore key that you can see here. Inside this SSH directory only, you will see this file. If this file is not there, for sure it won't be there. You have to create this file. So don't do any spelling mistake on this file. It is authorized underscore keys. Yes, it ends with S. So open this. So paste all the keys here. That's what you have to do in all the nodes. So just go to all the nodes. vi authorized underscore key. See, I've pasted all the 3 keys. I've pasted here. So you have to do this in all the nodes. Just do it. So now once you have done this, right, now each node can do an SSH without password. That is passwordless communication has been enabled. Now I'll show you a demo. So what is the mission IP? This mission IP 172.31.94.116. Okay, from this node, I'm going to do an SSH for the second node that ends with 192. That means from master node, I want to connect the slave node. I'll do enter. It won't ask password. See, it entered into 192. Initially, I was in 116. See, it's not asking password. So for me, it's not asking password. Means for sure, when I start Hadoop for master node, it can go to any slave node, and the slave nodes will not ask for the password. Okay, so passwordless communication is done. If you haven't done this step, you cannot start Hadoop cluster and multi-node. You cannot do. Even for single node, this step is mandatory. If you see my single node video, I have explained this in detail more. I have explained more in detail for this. Fine. So let me come out from the second node. Okay. Fine. So now the third step was we have done the SSH setup and everything is done. Now change your directory, go to Hadoop folder. Let's start with the configurations. Okay, so I'll go to all in all the node. Let me change, and the configuration is going to be same for all the nodes. So I'll tell you the answer for how to make one node as a master and remaining node as a slave. That I will tell you. Okay, so now let's go to the master node. So there is like I want to show you, like there is 3 env environmental file for which we have to share the Java information. So this is etc/Hadoop is where you will have all the configuration file. Let me do an lstr. So this is where all the files you will have. Okay, so now I'm going to get only the env file, env that ends with .sh. Okay, .sh. Okay, so you can see we have this 5 env.sh, but we have to only add the environmental variable of Java in these 3 env.file. So let's open one file. I'll just show you all the files. So somewhere here you have to add the Java home, the same what you have added in the bash rc file. So add this in all the 3 env files. So mapred env, Hadoop env, I'll show you again here somewhere you can paste. Okay, it is here, and then yarn env. Okay, so you repeat the same step. So here I have this Java home. So you repeat the same in all the nodes of your Hadoop cluster. Nothing different. So go here again the same and go to slave node 2, same. So just Java path. You have to give the correct Java path. Okay, so we have done almost 40% of configuration for multi-node. What is the balance? Okay, so next we have to configure for 5 daemons, right? So lstr. The very first file is core-site.xml. core-site.xml. Okay, core-site.xml is a file for name node. Okay, so open this core-site.xml in the master node and add this property. So this property, if you see the value, I have given the IP address and then 50,000. So what is this IP address? This IP address is the first node IP address. That is this node, right? So see, it ends with 94.116. So the same IP is what I'm giving inside here. So that means this node is going to act as a master. The IP address which you give in this file, that IP is going to be a master node. Now go to slave node, and in slave node also you will be having the same files, right? Open it. So this is slave 1. Open core-site.xml. And you can see I have given the master node IP address only. So people used to do a mistake here. What they will do, right? So if you see this slave node IP address ends with 8582, people tries to give this IP, that is the slave node IP in the core-site.xml. That is wrong. So any IP that you give in core-site.xml will act as a master. So how come slave can act as a master in this case? Okay, so always you have to give the same configuration information of master's core-site.xml in all the slave nodes core-site.xml. So in only this way, slaves will come to know which node is a master. So that means we'll go to second slave node mission, add master node IP address here, so that this slave node will come to know this first node is a master. And same do it in the second slave as well. etc Hadoop vi core-site. So here also, if you see this node ends with 192 is IP address, but if you see I have given 116 IP address, means I'll tell you the last 3 digit of IP address only. So master. So again in the second slave also I am giving the IP address of master. So that means whatever you give in the core-site.xml of master node, repeat the same in all the slave nodes core-site.xml, and that is how slave nodes comes to know which node is actually a master. Okay, now you can ask me, how come master node knows which nodes are slave? That I will tell you. That is the last step. I will tell you later. Okay, so let me close this. What is the next file? So the next file is, let's go to the notepad. So the next file, yarn-site.xml. So this is for yarn, resource manager. So go to your first node, which is master node, and open yarn-site.xml. Same like core-site.xml only. So these two properties is what important for yarn. And if you see here, I am giving the first node IP address for resource manager. So only in this node the resource manager will start, and resource manager's port number. So you have to give the same information only in all the slave nodes yarn-site.xml. Okay, let me go for yarn- in the first slave node. See, I'm giving 116 IP address only, and that's how slave nodes comes to know which is resource manager, which node is a resource manager. So go to the second slave, yarn-site.xml. See, it's same. So core- and yarn- you have to use the same in all the slave nodes. What you have used in master nodes, same, you have to repeat same in all the slave nodes. Let's come out from all the slave nodes. Just come out from the file. What is the next configuration? Let's go to notepad. hdfs-site.xml. Okay, in hdfs-site.xml you will be having two properties. So the first property is where, like, you will see dfs name node.namedir, and the second property is data node.data.dir. So this is a path where you can see home, Ubuntu, Hadoop to dir. Let me go to my mission, and I'll come back from home, and I will do an lstr. You will see Hadoop to dir. So before you installing Hadoop multi-node or single node, you will not see this directory. You will not see. So, but before that, like after you do this configuration and you start the Hadoop, you will see this directory. So what this directory actually has? So if the first directory will have the metadata information of your blocks, and by this time you should have know like what is metadata, right? So Hadoop stores the metadata information of blocks in name node mission, right? So this directory which will have the name node, that is metadata information of your blocks, and the second property is where actually your blocks get stores. So you have 3 nodes of cluster. When you upload some data, the data will be get splitted into blocks and splitted to multiple nodes, right? End of day, somewhere in the nodes it has to be get stored in the disk and in some directory, right? That directory for blocks is under this. So for these directories you will not have access in your real time. Okay, so how the blocks get stored in what directory is what I'm trying to say. Now you can ask me a question: do I need to give both the properties in all the nodes? There is a catch over there. I will tell you. Master node will only have metadata in real time. So because master node will never act as a slave, but in my case I'm making my master node also to act as a slave. So in my case, if you open this hdfs-site.xml, I'm giving both the properties. But if it is a real-time cluster, then they will give only the first property, because master node will not be a slave. If that is not a slave, then blocks will not get stored over there, right? So even if you give this second property in the real time, no use, the directory will be empty. But in our case, master is also acting as a slave, right? So I have to give both the directories information, because master will save the metadata in the name dir, and in the same master node, slave is a slave is also running, so blocks will get stored under here. Now what will be there in the slave node? I will tell you. So hdfs-site.xml. So here I'm again having two properties. You can ask me whether we need in slaves also two properties. No, not required. So you don't need this first property because in slave node metadata will not be get stored. So I have given this, but this is dummy here. So even this directory will not have anything. So in slave nodes you have to give only data dir only. Okay, so the second slave also I will show you, hdfs-site.xml. See, here also first property is dummy because slave node will not store the metadata information. So you have to give only the data dir. Okay, come out from this file also. So till now the configuration is same across all the nodes. Okay, now what is the next step? So map-site.xml is the next file you have to configure, but you will not have map-site.xml. Instead, you will have map-site.xml.template. So do a rename by using copy command. Just take a copy of it, map-site.xml. Remove that template. Okay. So once that is done, just change your directory vi mapred-site.xml and just add only this property, because for mapred the engine we are saying as yarn, not the mapred. That is the only change we are doing. So I'll show you here. This is also same across all the nodes. So just yarn. I'll show you in the one of the slave also. vi mapred-site.xml. See, same yarn. So till now all the files are same, the configuration across all the nodes including master and slave. So what is the next? Slave. Okay, this is very important. You will be having this file called slave. I will show you ls-lstr. See, you have the file slaves. If you open this file slaves, you have to give all the slave IP address. Okay, and very important, only in master node. You will have the slave file in even in slaves also. See, I'll open here. See, it's there. So it will be there in your machine because it's the same Hadoop tar file, right? There is no difference between the Hadoop tar for slave, Hadoop tar file for master. So it's the same tar file, right? Only the configuration gets changed. You are making the configuration to change the first machine as master, remaining slave. So this slave IP address, people even used to give it in slave nodes slave file also, but that is no use. Okay, it won't throw any error, but it is useless. So you have to give the list of slave IP address in master mission slave file only, and this is how master knows which are all the missions are going to act as a slave. Okay, so slaves, how come it knows where the name node is running? With core-site.xml. How come master nodes, how many slaves are running? With slave file in the master node. That's it. Okay, so here if you see, I'm giving the master node IP address also in the slave file, and that is why my master mission can also act as a slave in my case. If I remove this, in master node, data node and node manager will not run. You can try. If you want, you can try in that way. So we have done with all the configuration, and finally what you have to do. So here the environmental Java home, which I already told you. And finally you have to do a format. So the format you have to do only from the master node. So you should not do from each of the slave nodes. So you have to do it only one time after the installation, not for the each time of restart. Only once you have done the installation, only one time you have to do the format, and that too from the master node only. We are formatting the name node. Name node -format. Okay, so once you enter this, execute this, what happens? For example, if you have any errors in the XML files, you are missing some closing tag, or you are giving the wrong path, you will get all the errors during this format. So by reading the error, it is easy to understand. You can rectify the problems, you can correct your errors. So once there is no error, when you execute this command, you will see a lot of logs in the terminal. By the end, you will see successfully formatted. You will see the word. If you couldn't find it, just copy the complete log, paste it in the notepad, and search for successful word. It will be there. Okay. So once this is got formatted, now you can start your Hadoop. Okay. And starting Hadoop also, you have to do that start command should happen only from master node, not from slave node. So let me first stop the daemons, which is already running. Okay. Let me stop this. So I'm going to stop only from my master node. Before that, I'll do a JPS faster. JPS in all the missions. So see, already data node has been gone because I executed the stop command. So in this, data node and node manager is still there. So yeah, data node is gone. See, I'm just doing the stop only from the master node. all the daemons in the slave node is also getting killed, right? If you see, after executing it, it says stopping data node in 3 nodes, and then secondary name node, and then resource manager is also got stopped. Now node manager is also got stopped. So now go to the slave node, you will not see that node manager also now. See, there is no node manager. And here again, no node manager. In first node, 5 daemons, right? So nothing. Now you start it. Now remove this, stop and run it. Now I'm running all the start command only from the master node. By the log, you can see it will start the daemons and the slaves also. So starting name node only in this IP, and then it says starting data node in this 3 IP address. It's getting started, and secondary name node in 1 IP address only. You can see the IP address here. And then resource manager is also getting started, and node manager in the 3 IP address. Okay, now if I give JPS here, I will see 5 daemons because this is master node. Master is also acting as a slave in my case. Now slave node, I should have only 2 daemons, node manager, data node, success, and the third node, JPS. Yeah. So 2 slaves and 1 master. So sorry, 3 slaves and 1 master node. Okay, so this is the overall multi-node installation setup here. Now let's go to the UI, the Hadoop name node UI. So let me go for it. So here, the IP address of your master node, and then the port number is 50,000, sorry, like 70. Yeah, so 50,070 is what the default port number, the web UI for name node. So here my IP address is different because this is AWS IP address. If it is your physical IP address, you can just go with IP address :50070. That's it. So you don't want this DFS health HTML and all. Just give this. That's it. Okay, so now this is the front view of the name node UI. If you come down, you will see like total number of live node is 3. Yes, we have 3 live nodes, right? So if you click it, you will get the information. See, 3 live nodes with the IP address you can see here, and each of this machine has 8 GB capacity actually. So you can see if any node is down or dead, you will get all the information here. So now let's go for the file system. You click this utilities and then browse file system. So here you will see whatever the files that you have uploaded to your HDFS, you will see I have already uploaded a file called test123. So let's do one more upload. So let me create a file as demo. I'll add some word here, hi. Save this file. Now upload this file to HDFS. So Hadoop, sorry, let me change my directory to Hadoop. Okay, bin/Hadoop space DFS space -put and /home/Ubuntu, and demo is the file name. So then space / what is your destination file name would be. So demo, give 1 2 3, demo 1 2 3 4 5, something like this. Now upload. So now this will be get uploaded to your HDFS. Now go back and do a refresh here. You will see that file gets uploaded. Yeah. So demo 1 2 3 5. So here 3 replications. So now this file is getting stored as a blocks, and the blocks has been distributed across the nodes to all the 3 slaves. We have only 3 slaves, so 3 replica. Each node will have the copy of this demo 1 2 3 file as a block. So this is what the overall multi-node. An end-to-end project in Spark Streaming, which includes Kafka, Spark Streaming, and Cassandra, the NoSQL database. So this is going to be like a project. So please watch this video completely. If you skip it, like you will not understand in between. So please watch the video completely. Yeah, let's get into the topic. So first, let me explain you what I'm going to do in theory, and then let's move into practical. Okay. So imagine I have an application. Okay, so I have an application, an e-commerce application where people are trying to purchase a product by clicking the product image or product button. So backend, what I'm actually going to do is I'm going to do some kind of a sentimental analysis, and that is an end goal. So here I'm going to capture the click events of the user, and then I will try to understand what they are trying to visit in what page, what product, and if they are not doing the purchase, I have to understand why they are not doing it, even though they are clicking that particular product these many times in a day, but still they are not purchasing the product. So I have to identify that. So for that, I have to first gather the data and I have to store it somewhere, and that is what I'm going to do today. So I'm going to capture the click event through Kafka, and then it goes to Spark Streaming, and the process will happen over there, and then finally it gets stored in Cassandra, and from Cassandra the reporting team, someone or some other reporting team can get the data and they can understand what is happening over there. Okay, so let's imagine we have an application and I'm going to use the Kafka, which is a data pipeline tool for streaming data, and this is not data processing. People used to sometimes say Kafka is a streaming data processing tool. It's not a processing tool. It's a real-time data retrieval or stream data retrieval. That is a data pipeline. So from Kafka it goes to Spark, and which is Spark streaming, and then it goes to Cassandra. So this is a high level overview of the project what we are going to do today. So let me get into some technical aspects, or somewhat like second level of information I'm going to give now. So if you take Kafka, there is two things in Kafka. Kafka splits into two, which is Kafka producer and Kafka consumer. Kafka producer is where the data that get produced, and Kafka consumer is where we consume the data. So here the Kafka producer, it has this, for Kafka producer there is a Java code, and then for Kafka consumer also there is a Java code, Scala code, Python code is also there. Imagine it's a Java code. So what you have to do, imagine there is a product image here and there is a button. People are trying to click this button where they want to see the product, what it is and all those stuff. Now I have to write this Kafka producer code. I have to integrate to this web application back to this button. Back end of this button click code. Okay, so that means when the user click this button, it captures all the user events and that goes to Kafka producer. Means when I say Kafka producer, it produces the data. Now here the Kafka consumer will consume the data whatever the Kafka has been produced. So now Kafka consumer is something that I'm going to write inside Spark streaming. Okay, so this is not badge. Okay, let me write it as Spark streaming. So that means within Spark streaming, the first line is to connect Kafka, and then I'm going to get the data from Kafka, and then I'm going to create a Spark streaming, and then finally I'm going to write it to Cassandra. So this is what Spark streaming code will have, which also has the Kafka consumer. So that means this is Kafka producer and this is going to be the Kafka consumer. So with respect to Kafka, it's a messaging queue tool. So if you want to have a brief understanding of Kafka for some extent, there is a video that I have already uploaded. I'm sharing all the prerequisite videos for this particular end-to-end project video. I'm sharing all those video links in the description box of the video. For example, if you want to do this project, you have to install Kafka, install Spark, install Cassandra. So there is a 3 separate video for that. You can have a look and then you can do a setup. And then to understand what is Kafka, there is already a video, and for Cassandra also there is already a video. So for Cassandra, if you don't see the link, please wait. Within a week I'll upload all the basic Cassandra video series, and if the link is already there, please have a look on those videos as well. Fine. So now like this is what I wanted to tell you. This is what actually we are going to do. So this exercise, this project is even asked in interviews, especially when it comes to Spark streaming or even the Storm streaming. Okay, there is an alternate technology stack for Spark streaming, which is Storm, right? So even in some interviews, they're asking, give me an end-to-end Spark streaming, like from Kafka to streaming to Cassandra, and they are also giving 1 week of time to do this exercise. Whatever I'm going to show you for next 20 to 30 minutes, the same thing they are giving a time of 1 week to do, right? So, and also this helps you in the interview as well with respect to Spark streaming, and also this is actually an end-to-end project which will help you to build a bigger level of project based on this video. Fine. So let me explain you the process, what are all the tech stack and process we are going to do the installation, right? So let me explain you that. So we need Kafka. Okay, so Kafka is the first tech stack, and then we need to set up Spark, and then I need to set up Cassandra. Okay, so what are all the services which is going to run for Kafka, which is Zookeeper. So Zookeeper is a daemon that runs for starting Kafka. You need Zookeeper, which runs in the daemon name of core_main main, and then you need to start Kafka daemon. So these are the two process which we need in Kafka. For Spark, which is already like we are aware of, right? Master and worker, so 2 daemons. And I'm going to show you the program, the code, the Spark streaming code in Spark shell. You can the same code you can write it in a project, like by using IntelliJ or Eclipse. You can build a Java project, and then it's a Scala code actually. You can build a Scala project, and then you can build a jar file, and then you can run it via Spark submit also. But to make it simple, I'm doing it in Spark shell. So even you do this in Spark shell, there will be a process running in background which is Spark submit. So 3 processes. And for Cassandra, there will be a process Cassandra daemon which will be running. And today I'm going to show you this exercise with a web application as a front end. So I need a web application process as well. So I'm using a server called Tomcat Tomcat, which is a service web server which I'm going to run, and the daemon process for this is Bootstrap. So this is highly optional, so don't consider this as a mandatory one. Just for you, for the video purpose, I'm to make it more realistic, I created a web UI using a web language called JSP, Java Server Page. So this is highly optional. So you can ask me, if there is no front end application like this, how can I test this application end to end? I will tell you the alternate way to test this application as well. Okay, I will tell you that as well. So that means, so in my mission, I'm going to have all this process running. So make sure that much amount of RAM you are having it available in your machine. So here the environment, I'm going to use AWS, which is cloud. In cloud, I created a virtual machine. We call it as EC2. That is the name of virtual machine people use in AWS. And this is also highly optional. If you don't have any cloud, I don't have GCP or AWS cloud, completely fine. Leave it. So you have already your laptop. In laptop, you already have a Ubuntu or some other Linux, and you already have all the setup. Or like it's a new Linux laptop, but you need to do all the setup. That's completely fine. Do it in your laptop itself. Given condition, if you have at least 4 to 6 GB of RAM, that will be fine. So since I do all the exercise in my cloud missions only, and that's why I'm using AWS here, but this is completely optional. Don't get confused. Okay. So here I created a virtual machine. In AWS, we call it as EC2, Elastic Compute Cloud. I created a mission. So in that mission, I installed all this Kafka, Spark, Cassandra, and I've started all the process. And then I'm going to show you the code by running it in the Spark shell in the virtual machine. Fine. So this is also done. Now let me get into the practical thing. So I'll just open my AWS. So this is my cloud console. So don't get confused again. So I just have my one virtual machine which is running, which has a public IP address. So this is an IP address which I have to use to log into my virtual machine. So these steps you can ignore if you are using the complete whatever I'm going to show you today, which you are going to use it in your local machine. You can completely ignore this. Okay, so authentication. So there is no password in AWS, like instead we used to have the key file. So let me open my machine. Okay, so the username for my virtual machine is Ubuntu. So let me open it. Let me increase the font size. So I will just go with 14. Yeah, so I hope it's much better now. So if you see here, so I have all the tar files and then I have untarred it. So as I told you, the installation videos, all a separate video I have already uploaded. Please go through that video and do a setup. Like you need Kafka, Spark, and Cassandra needs to be get installed already before starting this exercise. Fine. So first what we can do, let me get into Spark and then I will start the daemons. So sbin / start and all.sh. So that's a command to start your Spark daemon. So when you start it, you will have master and then worker. So let me test it by giving JPS. Yeah, it's there. Now what is the next thing we have to do? Let's start Kafka. Okay, so I'm going to share you the steps along with the code in my blog. So that blog URL also will be in the description box. You can have a look. So this is the version of the Cassandra, Kafka, and Spark which I'm going to use. Sometimes if you change the version of this, like change the version between this components, right? So the connectivity will not work. So make sure that you are using the same thing. So to start Kafka, first you need to start Zookeeper. So let me copy this. Command is to start your Zookeeper. Zookeeper acts as a metadata service for Kafka. So let me run this command in the background. So the service will be running in background so that I don't want to open multiple terminals. So I'm using the no hub. This is a Linux command to run any foreground process in background. Okay, so no hub, and then I'm going to write all the logs. What is going to what it is going to get print with this command, right? So I'll have the log name as no hub out, and then ampersand symbol. Yeah. So now if you give JPS, you will see a daemon called quorum peer main, which is Zookeeper daemon. Next, you have to start Kafka. Start Kafka. So no hub, and then no hub dot out. And then ampersand symbol, right? So this will start Kafka. Okay, so you can see the Kafka daemon is started. So now we have started Kafka also. So what is next? So you have to start Cassandra, right? So Cassandra, there is no very big installation step with respect to Cassandra. So all you need to do is just untar the Cassandra file after downloading, and then you just run this command, and that's all. So there is no installation in Cassandra actually. If it is required, yeah, there is few steps to do, but as a fresher, like you are doing a Cassandra stuff, right? So just to start with the practical, there is no big steps to do. Untar it and start the Cassandra service. That's it. So this is a service which we are going to start now. So no hub, and then the service, and I'm going to run this in background. So for Cassandra, you will not see the daemon name in the JPS, which will be running in background. To check whether Cassandra is working or not, you can log into Cassandra shell. So we have this Hive shell, Spark shell, MySQL shell, Oracle shell. So similar to that, for Cassandra also we have the shell. So if it is entering into the shell, it is working. Okay, so we call all the shell as REPL. Even Hive has a REPL, Pig has a REPL, and then like Cassandra is also having REPL. So we do all the Cassandra DML, DDL commands, the select, insert, delete, everything under this shell only. So Cassandra is running. So for just for checking, I've just entered into it. So for our exercise, we are going to capture the click event, and then we are going to process in Spark streaming, and then finally we are going to store it in Cassandra, right? So for that we have to create a table and database with some column names, right? So let's go for it. So in Cassandra, we used to call the databases as key spaces, and this is a command to create the key space. So the key space name is Spark data, and the replication is simple strategy, and replication factor is 1. I have explained all this in my Cassandra video. You can have a look on it. And then so let me create this, but before doing it, let me drop. So I have already created it. So let me drop the key space. Spark data. Okay, it's not there. It seems. Okay, so let me. Okay, so I'm sorry, I gave a wrong command. So drop key space and then Spark data. Yep. Okay, so yeah, it's dropped. So now I'm going to create a key space which is called a database, right? So which is equivalent to creating a database, and then use Spark data. Like it's similar to MySQL. So once you and Hive, in Hive also we do this use, right? And then you create a table. So create table name. Table name is custody data, F name, L name, which is last name, URL, and then count, and then the product. So these are all the information which I'm going to capture from the user, right? And you can able to see something called counter. So counter is actually a data type in Cassandra, and you can also see in primary key I have given all these. So I will give you a very quick information about what is this counter and primary key, why you have given all the 4 columns in primary key. At last, I will tell you why I'm doing this. So first, let me create. Now I'll do a select star from cust data. Okay, so it's empty, right? Fine. So why F name is in red color and count is in some pink color, right? So it's all like we need to understand the basic things about Cassandra. So as I already told you, like there is a video, you can have a look on it. So you will understand all this information over there. So let me come out from Cassandra shell. So let me do a JPS and see whether all the daemons are running. Yeah, so I have the Kafka daemon, Spark daemon, Cassandra is also running. So what next? What else I need is I need the Tomcat web server to deploy my web application. Okay, so how we used to generate a jar file in Java and Scala, right? So similar to that in JSP. JSP means Java server page. It's a web programming language, server-side programming language where people used to write program to develop a web application. So they used to archive that as a var file, web archive, like jar file. In web application they used to say var file. So you have to deploy that var file in this web server, and then only like you will able to see the web application UI in the browser. Okay, so let me start. So I have already placed the server, means the var file. So you don't want to get confused about all this information. So this is completely optional for you. You don't want to do at all. I will tell you what is the alternate way to test the end-to-end application. Okay, I will tell you that. Don't worry. Okay, so it's running. So let me show you my web application as well. Okay, so this is the URL. Let me. Oh, sorry. So for every restart when I do my AWS mission, right? So the IP address will get changed. So that's why it's not loading actually. So let me change my IP address. If it is your local, then you have to give localhost here. Yeah, so this is my web page. Okay, so this is a web page which I created. So whenever the user feed all the information and then they choose the product, and when they click the product, like by giving a OK, so the events will be captured. Okay, now what I'm going to do, I'm going to enter into my Spark shell. Okay, so let me go back to my notepad. So here you have to start your Spark shell with these two packages. So the first package is to connect Spark with Cassandra, and the second package is to connect Spark with Kafka. So you can give hyphen packages and this package name automatically. The jar file, the dependency will be get downloaded from the internet for every time you have to do this. Okay, it's not like a hard setting; it's like soft setting. So you have to do this every time. It's not permanent. So I will tell you one. Warning as well. So this hyphen packages will not work if you are doing the same exercise in your company laptop or company server machine. Okay, so this will not work. They will restrict it. So for that, what you can do, you can manually download these two jar files from the Maven site, and then you can place the jar file somewhere in the machine, and you can use hyphen jars instead of hyphen packages with comma separated. Then this will work. Okay, so I'm doing it with hyphen package because this is my own environment, right? So it will work. Enter. Okay, so once we enter into the Spark shell, let's try to give all the imports, the necessary imports, whatever it's required, I have to give. So when you enter into the Spark shell, right, by default the Spark context, the session will be get created in the name of Spark. So you have to stop this because we are creating one more session for Spark streaming. So you cannot have more than one session created in the Spark shell. Okay, I will tell you. I will show you that error. So first imports are done, and the next line I'm creating an app name, I'm creating a Spark conf, and then I'm setting an app name, and then I'm setting properties to connect Cassandra, the IP address on which my Cassandra instance is running. Okay, so that is done, and the next command is I'm creating a streaming context with the Spark configuration, and for each and every message that comes from the Kafka, right, the time interval which I'm giving is 20 seconds. So you can increase and decrease by increasing and decreasing the value here. So I'm creating a context here. So if you run this, right, you will get an error. You can see only one Spark context may be running in this JVM. So you have to stop the Spark session which is already running. So that is in the name of Spark, right? I showed you here. Okay, you can see here. So it's available. Spark session is available as Spark. So let me stop this. Okay, now you can run the previous command. See, it is working. Right, fine. So next you have to mention the Kafka topic. Okay, so I'll tell you what is that. Let's go top. See, we started Zookeeper and then we started the Kafka service as well, and then you have to create a topic. So in Kafka, the producer and consumer will work only to a specific topic in common. So that is something required. In Hadoop, we have Flume, which is an alternate for Kafka, but in Flume, there is no concept of topic, but here there is a concept of topic. So we create multiple topics, and each topic will work with the Spark consumer and producer. Okay, so this topic we are supposed to create. So what I will do, I will open a new window. I will open a new window, and then I will change my directory to Kafka, and then I will run this command. So you will see like topic created. So if you want to list the topic, there is another command that connects with Zookeeper. Zookeeper is a metadata for Kafka. It connects and brings the topic list. So I have only one topic. You can able to see here. Okay, so we have created the topic, right? So let me close this window. So now you created the topic. So this topic is what you have to mention here. So we have to convert this topic into a map. So we are doing it here with the number of threads, like what number of threads in which the topic has to run. So for the parallelism, so I'm giving 1, and then I'm converting it to int, and finally I'm converting this to map, and in the variable it gets stored as topic map. So this is for mentioning the Kafka topic name. Next, you are creating a Kafka util.create stream. This is for enabling the streaming between Spark and Kafka. Okay, so val line Kafka utils.create stream SSC is the streaming context that you have created. Localhost 2181 is the Zookeeper host and port number, because Kafka needs to know the topic and other information from the Zookeeper because it has the metadata information. So Spark group, you can give any name here. It's a group name for this job, and then topic map is actually your topic. Okay, so I'll just run this command. So I've just feeded all that information. Okay, I didn't run this. Okay, first I will run this, and then I will run this command. Yeah, okay, it's working now. So next, you can, if you want, you can print and see. And what is the line number 68? This is a line for connecting Cassandra from Spark. So lines.map, for each line, I'm saying the data that comes from Kafka from the front end is comma separated. And then I'm for each column, I'm mentioning as array of 0, 1, 2, 3, 4. And then save to Cassandra is a command that comes with the Spark Cassandra API along with this data stacks package. Okay, so here you have to give the key space name. So what is the key space name here that we created, which is actually the database name, and then cust data, which is actually the table name, and then some column is actually a keyword inside which you have to pass the list of column names. So now I'm going to run this. Okay, so now a connectivity for Cassandra to Spark has been created. And now what is next? I have to start the streaming actually. So ssc.start, which will actually start the streaming now. So now what is the next step I have to do? I have to open a new window. So the data, what I'm going to populate, where I'm going to populate with the web application. Finally, where the data goes to Cassandra. So now I have to log into my Cassandra SQL shell. Apache, let me increase the screen. Cassandra bin/SQL/sh. So the key space name is Spark data, and then select star from cust data. Okay, so now let me go to my web application which I have created. So what I will do here, I will go and say like Gautam. Okay, it's already there. Last name SB, and this particular user is actually showing interest on the mobile. So when I click OK, so what JSP application it will do, so it will capture. So inside JSP application only I have written my Kafka producer code, the Java code, which will actually retrieve this web URL, from which URL I'm actually watching the products, and then the last name, first name, and then the products and everything. So let me click OK. So I have also printed a custom message here. Data has been produced. Please check the Kafka console consumer. That means you can check in the consumer as well, or you can check in the Cassandra. So select star from C. The data has been populated here. I will also show you the Spark shell window. See, you can see some logs has been printed here because the data has been populated, which comes to via Kafka. It comes to Spark streaming. In Spark streaming, we have written a consumer of Kafka, which will receive, and then it stores to Spark. It stores to finally to Cassandra. Okay, now I will tell you like how I will believe the data that what you have given, the web application only comes to Spark. So we have to cross check that as well, right? So what I will do, I will open another window. I will show you the data, how it comes to Kafka. Okay, so let me get into Kafka consumer. So there is two more process. If you see here in Kafka, there is something called console consumer and console producer. This is completely for testing purpose. So you can use the Kafka console consumer to check whether the data has been consumed by Kafka or not. Imagine some data has to come from Kafka to Spark, but finally the Spark has not given the data as an output. So now here the problem, I need to know whether the data was not consumed by Spark or Kafka. You need to know, right? So now with the console consumer, you can check whether the data comes to Kafka or not. If it comes to Kafka, then the problem is with Spark. So now this is the command, consumer command. I'm giving consumer.sh zookeeper port and IP address, and then which topic it is, and from beginning is it will retrieve the messages from the beginning of the topic got created and the data got populated, right? So now I'll run this consumer here. Now see, the first message what I've sent through the web UI has been come here. So now let me show you the web UI here. So what I'll do, I'll go with some name. Okay, Saravana, and then P, and he is watching some product of fashion. So okay, so when I click OK, see, it comes to consumer. That means Kafka is working perfectly. So this is where I have written my Kafka producer as a JSP application. This comes to Kafka consumer. That means it comes to consumer. Kafka means Kafka is working fine. So automatically the data has to go to Spark. Automatically the data has to go to Spark. So let's check the output in Cassandra. See, the data has come to Cassandra as well. So that means end to end it is working fine. So now I will tell you how to do without web application. Okay, so imagine there is no web application now. So let me open one more window. So you can populate the data for Kafka via Kafka producer. So the console producer. So there is one more command. So you can test the end-to-end application with this command. So you don't want to go with web application or something like that. So just go with Kafka console producer. This is for generating the data for your application. So this is your consumer, right? So let me minimize the screen. See, whatever I'll give in the producer, it comes to consumer. You can see both the terminal. Please listen both the terminal. So I'll go with the name Rahul, K, some address HTTP, and some number I will give as IP address, and that's all. So comma, the product is like dress, and then I'll give the number of count he visited. Okay, so I'll give 1. So default is always 1. Okay, enter. So now this will come here. See, in left hand side, consumer, it comes to consumer. That means you don't need a web application. You can directly test with the producer. I created a web application only for the video purpose, just to give you a feel of having it as a real time. So let me go back to Cassandra and see whether the data has inserted or not. See, the Rahul data has been inserted. So now I showed you end to end, but I want to tell you one more thing with respect to the Cassandra table. So the sentimental analysis, what I'm trying to do here is how many times a particular user is visiting a website. I want to increase the count. For example, Gautam from the same IP address, he is watching the same product for 3 times in a day. That means I have to capture the count 3. So now the reporting team has to do more process on top of it. Like 3 times the user is watching the product, but why he is not purchasing it? So I have to identify. Okay, let me try to give some offer only for that particular user. I will give some kind of an offers or discounts to him, because when you watch something products in the Amazon or Flipkart and you are not purchasing it, immediately you will get all the advertisements and all the pages whatever you are doing visiting, right? So this is how internally they capture the data and do this. So now what I will do, I will show you. So the counter data type, what it actually do is, whenever the value of each column comes as the same value, then this count will get increased, and that is the reason we are giving all the column name except the counter column name in the primary key field. So this is a rule in Cassandra. When you use this counter data type, the non-counter columns, that is fname, lname, URL, product, so these non-counter column should come under primary key. So that is a rule in Cassandra. And you may ask me one more question. Primary key means it won't allow duplicate, right? But in Cassandra, primary key means it's different concept. So primary key in Cassandra will allow you duplicate. That means it will do an upsert. Okay, so for this you need to see all the Cassandra videos as I suggested already. So now what I'm going to do, I'm going to explain you the actual counter use case now. Let me use my web application. So I will try to give the same information, Gautam. Okay, let me give the same name, Gautam, same last name, SB, and product same mobile. Okay, so now Gautam SB is just showing the interest on mobile second time in a day. Okay, give OK. Now I'll come here. So now the data goes to Kafka to Spark, and finally it comes to Cassandra. Now you can see the count will be get increased here. Let's wait for 20 seconds. Yeah, so you can see the count got increased. That means the same user from the same URL, he visited 2 times. You can see here in the Kafka console producer, this 1 is actually default. Always you have to give 1 only, because we don't know how we will increase. So it should be always 1. Now I will show you in producer window also. Let me copy the same, enter. So now I will show you through producer, console producer also. Now here if you see the Rahul K, this IP, this product dress will be get increased to 1 more count. Let's wait for 20 seconds. Either you do it in web application or you do it in console producer, both are same. Okay, so anyway it is same. So you can see here too, because sometimes people used to ask me why you are giving this 1. Do I need to change this 1? No, we don't want to change this 1. So this is a hard-coded value. So always you give 1 only, that is completely fine, because every time the user visits, it's 1 occurrence, but the counter will take care of incrementing this value. Okay, so now imagine a new value comes, so that will be a new record actually. So I'll do this. So I have a record as Bharat, some value D, and again fashion. Okay, so now this will come as a new record, because there is no record already with the L name, last name, first name, and URL matches to this value what I have given now. See, it entered as a new value here. Right, so now again Bharat visit from the same website with the same product, the count will get increased. So this is what the sentimental analysis we are trying to do with the counter option available in the Cassandra. Okay, so I hope you enjoyed this video. So this complete video, I hope it's helped you really. So as I already told you, this is actually a project, and some companies give some 2 to 3 days or sometimes 1 week of time to do the setup, and they will ask you to give a walkthrough on this in the interviews. I'm saying they will give some time to do this. So this is what something is actually a project. You can articulate this, you can even add this in your resume.
Hi, so what is the difference between on-prem and cloud? So on-prem means, for example, you work for a company and a project, and your company is planning to build the entire server in the same building, right? And the entire maintenance cost has been taken care by your company itself. For example, in the next 30 days or next 1 month or 2 months, you are not working anything on the server that you have built. So still you have to pay the maintenance cost, electricity cost, and etc. And what happens if some disaster comes into picture? And what happens, you have another branch in a different country and they want to access the server. So it's all the pain point when you build a server by yourself on your company. So this is what an on-premises is all about. So what is cloud? So same thing what your company has done is being done by someone else, a third party, and then you are going to rent these services. For example, you have built a server for like around 10 TB with like more than 300 terabyte of RAM. So now the same thing has been done by a third party vendor. So he buys a land in a different regions and he built the servers, server farms and etc. And now like he is giving the service as a rental service for us. And we don't want to worry about the disaster. We don't want to worry about the remote access problems and latencies, and everything will be taken care by him. And only you have to pay for what you use. For example, the next 1 month, you are not using any of the cloud services, the storage or the processing unit or the data read and write, nothing. You are not using any of this, then you don't want to pay anything. And also you are running an Hadoop or Spark cluster, and imagine you are running a batch jobs. So weekly, only once you have to run your Spark job. Now you have to create a cluster, and then whether it is one time in a week or not, you have to run the complete cluster for 24/7 if it is an on-prem. Now imagine in cloud, they are giving an option that you can create an on-demand cluster. That means only once in a week, you will be creating a cluster and then you will be running all your scheduled jobs, and then the cluster will be get deleted, but not the data. So this is what we call it as an on-demand cluster, which is also provided by all these cloud providers. So if you see the leading cloud providers in market, AWS, Amazon Web Service, and then Google Cloud, and then Microsoft Cloud, which we call it as an Azure, and we have something called Snowflake also. So these are some of the list of cloud data providers, and we have many other cloud data providers like Databricks also. So now you understood the difference between on-prem and cloud. Let's move on to next topic. So now you can ask me a question like, do data engineers need to learn cloud computing? Definitely yes. So as a data engineer, big data skill set should act as a primary skill set for us, and cloud should act as a secondary skill set for us. So cloud provides you infrastructure, and not only infrastructure as a service, they provide big data as a service also. So we are moving from on-prem to cloud computing for various reasons, like pay for what you use, create on-demand cluster, and then maintenance of infrastructure, and then reducing the latency. So they provide a lot of advantages for you to move on to cloud from on-prem. Now, if you take cloud providers, the leading cloud providers in market, AWS, Google Cloud, and Microsoft Azure, and Snowflake also, and Databricks also. So if you go for these different cloud providers, they provide big data managed service in their own name, but if you still see the technology stack will be same. For example, if you go for Amazon, they provide big data as a service in the name of EMR. And again, inside EMR, if you see, it's same Hive, same Spark, everything will be same. And the full form of EMR is Elastic MapReduce. And if you go to Google, they provide the big data service in the name of Dataproc, and still the same Spark, Hive, and everything. And in Microsoft, they provide big data service in the name of HD Insight. So now these cloud providers are giving these big data service in the different name. And all these cloud providers also give an alternate data services for big data also. It's your choice to pick which one. For example, so if you take AWS, they provide big data managed service in the name of EMR, Elastic MapReduce. And if you see in EMR, we still have the same Hive, Spark, and everything. But also Amazon Web Service provide alternate service of all this big data in their own cloud, in their own name. For example, if you take Hive, they provide Redshift. AWS provide Redshift. And if you take Google, similar to Hive, they provide something called BigQuey. And not only for Hive, they have for Spark and other services in big data, they have alternate. But it's up to your solution architect choice to whether use it or not. For example, in one of my use case, we used Google Cloud and we are using Spark in Dataproc. Dataproc is a big data managed service provided by Google. And instead of loading the Spark output in Hive, we used BigQuery, which is being provided by Google. BigQuery is faster than Hive. So here my solution architect decided to go for Spark in Dataproc and then BigQuery instead of Hive. So what you have to do now as a data engineer, so just pick any one of the cloud providers, like whatever it is leading in market. As I already told you, we cannot predict what the company going to use, the company which you are going for an interview is using. We cannot predict, right? So just pick anyone. I'll recommend go for AWS first and then Google Cloud. It's on my own personal recommendation. You can even pick Google Cloud as first and then you can learn AWS as second. So just Amazon provides more than 100 plus services. So just pick only data analytics service where you will be seeing EMR, the big data managed service, and then you will be seeing other services also. For if you take AWS, I will recommend you to learn EMR and then Redshift and then S3, and these are the some of the services I will ask you to learn other than big data service. Okay, similar if you go to Google Cloud, I will strongly recommend you to learn BigQuey. So these all things will act as a highlighted in your resume. Cloud is, it's completely necessary one for a data engineer to know, because everyone are moving their on-prem big data environment to cloud. So of course you need to learn. Any one cloud you learn is completely enough, and certification you can take even later. You just learn cloud and then just attend some interviews and share your cloud knowledge to the interviewers, and then later point of time you can take the certification. So certification is not that much important for now, I mean to say cloud certifications. So all these cloud providers gives data engineer certification, so it's something you can take later, but now it's important you need to know some of the data services, at least big data managed data services you need to know on all these cloud providers. So in this course video you will be seeing two big data managed services from different cloud providers, AWS EMR and Google Dataproc. I have made a video for these two, you will be seeing in the same tutorial video. And apart from this, you have to check other data analytics services provided by all these cloud providers, and pick any one and then start learning.
About EMR. So EMR, Elastic MapReduce, which is a service in AWS, that is Amazon Web Service Cloud. So EMR is a fully managed big data cluster for enterprise. So you already familiar with Hartanox and Cloudera, like DataStax, Hortonworks, Cloudera, Databricks. So similar to that, EMR is an enterprise big data cluster service. So people can use on their real time. So we have Apache setup, right? Apache Hadoop, Apache Spark. So all these are like, we call them as a vanilla flavors. So they are not for enterprise. So people will use all Hadoop, Spark as is like Apache, but the thing is someone has to provide support for it. So Apache will not give support for you, but I will use the same Hadoop, same Spark, same Storm or HBase, but Hartanox and Cloudera has the same components, but they will give support, and we call them as enterprise service providers. So Hartanox and Cloudera, they are leading in market for providing big data services. Similar like number 2, number 3, I can say in the list, AWS EMR. And similar to that, we have in Microsoft HD Insight is for big data as a service that Microsoft provides in cloud, and we have IBM big data service provider called Big Insight is a service that IBM provides in cloud. And similar to that, Hartanox and Cloudera, and we do have this AWS EMR. It's on cloud, big data on cloud. So the full form of EMR is Elastic MapReduce. But whenever I say the full form of this EMR, people used to ask me a question. Will AWS EMR will only support MapReduce, that is, or only support Hadoop? It's not like that. The name is something like MapReduce, Elastic MapReduce. It in turn supports Spark, Hadoop, all components in Hadoop like Hive, SQOOP, and then in Spark SQL streaming, and even it has some data science components and some visualization tools like Zeppelin, and even it has some NoSQL databases. Let me show you the list of component what it has. So the creation of this EMR cluster is very simple. It's like 2 to 3 clicks. The cluster will be get created. Everything will be pre-installed, and you don't want to do anything extra. Similar to how Hartanox and Cloudera has been prepared on the whole and provided to the developers. And the same way, EMR is also into picture. So as I told you, after Hartanox and Cloudera, EMR is something people are considering highly. Even we have Microsoft and IBM's big data cloud, but still the more people use EMR, the Amazon's big data service stuff, which is EMR. So let me tell you like how to start with this. So for this you need the Amazon console access. When I say console access, to access Amazon Web Service provides lots of services, not only EMR. So to access all these services, you need a login to connect, and then you have to work with those services. So Amazon has, it is a paid service, but it has a 1-year free account for few services for some extent. Okay, so if you are more interested on this, so I have given my Amazon AWS playlist link where I have already uploaded a lot of AWS stuffs on how to create an account and what is free tier and what all comes under free tier. So those stuffs I have already included, means I have already made as a video, and I've shared that playlist link in the description box of this video. You can have a look. And EMR is not comes under paid, means it's not comes under free tier of Amazon, what it provides for 1 year. So EMR is not coming under free tier, but still you can use. So the charges will be very less. Okay, just for exploring, right? So again, it has the same HDFS Spark SQOOP, but everything I've done in Apache, I did Hive. I want to work with Hive. I already did with Apache Hive, Apache HBase, Apache Spark, and I did everything in my local machine with Apache. But EMR is just for an experience of a real-time flavor. Just you can create EMR, work with some commands, and then add in your resume that you know EMR. Right, end of day it's going to be the same Hive, same scoops, same Spark, and same stuff. Even if you go for Hartanox or Cloudera or EMR, that's the technology stuffs are same, only the environment is different. So just to explore, you will get a touch of enterprise cloud service provider, big data service provider. Just for that, you can just install EMR and in cloud, and you can access few services, and you can kill the mission. That's it. They won't charge you much, not more than, if you just work for some 1 hour, the charges won't be more than 100 rupees, or even it won't be more than 50 rupees in INR, I'm saying. Okay, so after you log into the Amazon console, you will be seeing all these services. So these are all the services provided by Amazon. So they have, so like similar, if you see media services, networking services, they have the service for data science, and they have for security, governance, storage, and our EMR comes under analytics. So this is EMR, Elastic Map Reduce. So let me, so I will just click this. So each of this service has their own window, something like this. So if you see for EMR, we have the option of create cluster, and you can see I have already created a cluster sometime back, and I've terminated it in 26 minutes. So now I'm gonna click this create cluster. It's so simple. So once you click create cluster, you will be getting into this window, and here you don't want to do anything because I'm going to use advanced option. So the reason why I'm going to choose advanced option is, if you see here, this is what you are seeing here is not the advanced option. It just came after I clicked the button create cluster. So if you see here, they have different EMR versions. I choose some version, and if you see here, if I choose this, I will be able to use only Hadoop, Hive, Hue, Mahout, Pig, and Thais. But if you see, there is no Hive. So if I want to use Hive, I have to go for the second one. So my thing is, like, my requirement is I need Hadoop, Hive, and Spark to be get installed, but that comes under each of different thing. I cannot choose multiple things at a time. So that's the reason I'll go for the advanced option, where you can customize and pick the tech stuff to be get installed by EMR for you. Okay, let me go to this advanced option, and here I can choose the same. Again, you can choose the EMR version. I will go with the latest one, and you have 4 steps to create this cluster, and here you can choose whatever the tech stuff you need, and these are all the tech stuff provided by EMR. If you click it, this will be get installed by EMR itself, and you just, like, it's a ready to go cluster, so it will be created in that way. So what extra you need? So let me go for Jupyter. I'll take this. I'll need Thais. I'll need Joplin. It's similar to Jupyter. Joplin has a notebook, and it gives you the outputs and charts. I need Zookeeper. I need Flink. I need SQOOP and Phoenix and SQL interface for HBase, and I need HBase too. And then Pastro is similar to Hive. Okay, whatever you need, you can click. Of course, I need Spark. So you can choose all these things, and then, like, other things you can leave it as is. You don't want to get more into it. And since EMR is by AWS, AWS has a file system similar to our HDFS called S3. So S3 is not exactly a file system. It's called object store in AWS. So since it's the EMR is provided by AWS, they give 2 options for you to store your data. In general, we know in Hadoop we use HDFS as a default file system, but in EMR they are giving you the option whether you can choose S3 or you can choose HDFS. HDFS, but Spark, MapReduce, Hive, Pig, all these components will work on S3 also. But my recommendation, please go with HDFS, because the technology, the big data tech stack will work well if the file system is HDFS means, rather than going with some external file systems like S3. Both are distributed, but still I recommend you to go for HDFS for better performance. Okay, so I'm not going to change any of these options. Let me go with HDFS, and I've just given some of the things here, and then I'll just click next. Okay, so here the option is you have to choose all your hardwares, like how many cluster means nodes you need in a cluster, then how many masters you need, and then how many core nodes you need and task nodes you need. So its cluster is group of nodes, right? So you have like 10 nodes, and we call them as a 10 node cluster, right? So you can decide like how many masters and cores and tasks you need, task nodes you need. And if you see here in AWS, for each and every configuration of a mission has a name. If you see, if you choose this m5.xlarge, this is a name of a pre-configured and empty mission. So this mission has 4 cores and 16 GB of RAM. So if I want to change it to something different, if you see here, if I choose this mission, it has 32 cores and 16 memory and 640 SSD. So this will be one mission configuration, one node configuration. So the mission that you choose, based on that, the cost will be increase and decrease. So you have different options. You can choose anything that you want. So let me go with like 1 master node and 2 core nodes and 3 task nodes. So that means in total it's 5 node cluster. So I will leave it as it is. So then you can, if you want, you can change the mission configurations. So if you see here, like everything is m5.xlarge, which is 4 GB RAM and 16 GB memory. But if you want, you can change. So I'll go with this, and then next. So here, this is for general cluster settings for where the logs has to get stored and those stuffs, and tag name for your nodes. So it's all, you can leave it as default, and then next. So here comes the security. It's all about what I can say, like the password that you use to log into your cluster. So similar to that in AWS, it gives you a key pair, a file. So that file will be used as a key, as a password when you try to log into that node. Okay, so if you see here, a security key pair is required. So I have already created a security key pair test. Okay, so if you see here, there is a separate steps has to be taken to create this key pair. So let me show you that as well. So because as I told you, it's completely with respect to AWS, there is a concept of whenever you create a mission, you have to connect with the key pair. So that key pair you have to generate, and who the people who has that key pair can able to connect with the node. It's similar to the password what we have. So let me show you that quickly how to do that. Just click EC2. It will be under compute. So EC2 is Elastic Compute Cloud. So just click EC2, and you will in the left hand side you will see key pairs. Just click this. So after you click this key pair, you can see test, which is something that I have already created, and that's the reason you can see when I click this drop down list, I'm getting this. So now I have to create a new key pair. So just let me do this create key pair. And then it is asking for PEM or PPK, because always you go for PPK. So because it's for PuTTY. So PuTTY is a tool which we use to connect the remote mission. Like the people who are watching this video, like mostly you have been worked with this tool. I guess PuTTY is a tool which used to connect a remote mission. So I have given the PuTTY download link in the description box of this video. So you can download PuTTY, and then you can use it to connect any remote mission, not only cloud, even your a mission which is very near to you, which was connected with LAN. So you can able to connect with PuTTY if you know the IP address and password. Okay, so this one you can choose, and you can give some name for this. So let me give as something like demo. So now I will just do this. I will just click create key pair. Okay, so the key pair has been created, so it's asking for download. So you have to download it. It's required because you need this file to connect with your remote mission. So let me go back and let me choose. Okay, let me refresh. So next. Okay, let me refresh this page so that I'll be getting that demo key pair in my drop down list. Okay, so okay, fine, it is coming from first. Okay, let me quickly select all these things, whatever it is required, and then next. And this is your hardware, and this is your general cluster settings. And yeah, so now if I click this drop down list, see, I got my demo, right? So that's all. So now you can create your cluster. So after it will redirect to the main page, which is your cluster informations and details. So the cluster will take some time for you to for them to create the cluster. So you have to wait for some time. So let me pass the video here, and once the cluster is live and once the IP address is generated, and then I will continue. Okay, so if you see here, the cluster has been started. As you can see, I got this public DNS IP address. So you have to copy this. Okay, so now I have my putty, which is already installed, and I've just pinned it to my taskbar. So let me click this. You have to paste your IP here, then the host name, and then now you have to browse your you have to attach your key file that you have generated with this putty. So you have the option here called the connection. Just expand this connection and you will be seeing the option SSH. So click this SSH, and then you will be seeing auth, so authentication, so the short form auth. So you have the option browse here, just click, and this is the key. Just you have to browse it and select this. Now you have to give open. So the very first time when you try to open, it will ask you for a warning. There will be a warning pop-up will come, just yes or no. It will ask, you have to give yes. Okay, I'm doing it second time, so it's not asking for me. And the login username is Hadoop. So the default username for EMR cluster is Hadoop, so you have to give Hadoop as your username. And you can see, like, after I give Hadoop, it's not asking for any password because I have given my key pair file demo, right? So that is your password. So now it entered into the EMR cluster. So let me try to change the settings. I will increase the font size. So you can see here now it's better. It's bigger. The fonts are bigger now. Yeah. So now we have to check whether the components, whatever that we have selected, got installed or not, right? So if I just give Hive, it enters into Hive. The reason, like, I'm not installing anything, as I'm showing you here, it's a fully managed cluster, which all this, whatever the components that we have selected has been installed like by EMR, not by us. It's been installed by them. And any other component which is not there in the list, but you wanted to install it in this node, yes, it's possible. You can just communicate with your admins, and you can speak with them, and you can get some acknowledgement with all the approvals, and then you can install. It means, I'm saying within, if it's a process in your company, then I'm saying this. But if it's your personal thing, yeah, you can install any component. Like for example, Cassandra is a NoSQL database which is not there in the list while we create the EMR cluster, right? I need Cassandra, so I can directly install Cassandra on this node, and I can install on my own. That is possible. Still, it's possible. It's open source package you can install. So in the similar way, I'll just come out from the Hive shell. So let me go for Spark shell. So you can see Spark shell. When I give Spark shell, it directly enters into the Spark shell, and no need of any special configuration or something like that. So this is what a fully managed cluster. So even after watching this video, right, you can add EMR in your distribution list. So in resume, people used to ask, in which big data distribution you have worked. This will be a question in your interview. So they will check whether you have the real-time experience or not by asking your distribution, on which environment you worked, Hadoop project or Spark project. So I'm currently working on Hartanox. In my previous project, I worked in Cloudera. So in my resume, I have the column with the data with the key as big data distributions, and the value will be Hartanox and Cloudera. And also I'm adding EMR because I have experience on EMR. So after watching this video, even you can add EMR in your resume as a known distribution, because there is nothing. They will ask you what is EMR. You can just explain EMR is a fully managed cluster provided by AWS, and then you can say you worked on Hive and Spark. There is no much thing you need to know about EMR. It's all about, that's it. You can add in your resumes. How to create a Dataproc cluster in Google Cloud. So what is this Dataproc is all about? So Dataproc is a fully managed big data cluster, or I can say big data as a service provider. So this cloud sellers like Google Cloud, Amazon, or if you take Microsoft Azure or IBM's Big Insight. So these cloud sellers used to give their big data as a managed service in a different name. So if you take Google Cloud, the big data service which they are providing in the name of Dataproc, where you can run Hadoop, Spark jobs and other components of big data as well, and that it's fully managed. You don't want to do anything. All the setup, installation, everything will be taken care by the cloud provider itself. Like Google will take care of everything, so auto scaling and everything will be taken care, and pay for what you use. And if you take Amazon, they give you in the name of EMR, Elastic Map Reduce, and if you take Azure, they give in the name of HD Insight. So IBM Cloud gives you in the name of Big Insight. So each of these cloud sellers gives this big data service in their different name. Now, whenever people used to ask me, like, I want to learn cloud big data engineering, so which cloud I can choose? So it's all about first you learn Hadoop Spark on your mission, and then later you can choose on moving to cloud. So cloud, with respect to cloud, again, people used to ask me, yeah, I know Hadoop and Spark well already, and I'm experienced, but still, to which cloud I can learn? So it's up to you. So you can decide which cloud you want to learn, because it's not in our hand. So it's about basically like only the company you go, or the company to which you are applying, or even not depends on the company as well. If you take my company PayPal, right, we use Google Cloud also, we use Amazon also. So it's completely depends on the project you are fit into. So what I'm coming to say, if you want to learn something on cloud, just pick any one cloud, whatever you feel it is. Top 3, top 4, because you type top, when you search for top 3 big data provider cloud service, one site will tell you Google is first, and another site will tell you Amazon. And in LinkedIn, people used to say, some set of influencers used to say Google Cloud, and some set of influencers used to say Snowflake or Azure. So it's completely depends. So you take one cloud and you will just learn it, the big data service, what in the name they provides it, and how to create it, and how to submit the job on it, and that's completely fine. Hardly you spend some 2 hours of time, and then you add it in your resume, is completely fine. Because if you go for Dataproc, which gives by Google, or EMR, which gives by AWS, end of day it's the same Hive, Spark, everything, right? Until and unless you use their data engineering services is where you need to know. But that is what the expectation from the industry. Okay, first you need to know big data, and then those big data components you need to know how to deploy it in any one of the cloud provider. So that is what the first very expectation people used to have. So I already had I made a video on how to create EMR and how to make submit jobs in it. So the video is available in my big data course playlist, and that link is in the description box of this video. And now I am going to show you this Dataproc, a fully managed big data service provider by Google. Fine. So now let me show you something. So whenever you take Dataproc or any cloud seller, so cloud providers big data managed service, you need to know list of all components, what they actually provide. So if you see, there is a page here. So if you go to this particular link, and you will see the version of their image, so the Dataproc version, so 2.1, if you see, these are the list of component it is available. And one thing you have to see here, if you see Apache Hadoop, and you can see it says installed, and that means it's already there, you don't want to do anything. And if you say Hive, it is installed. But if you see this Flink, it's optional component. While creating the cluster, there will be a checkbox. If you choose it, they will install it, or else they won't. And there is one more option called initialization action, and that means if you take SQOOP, right, SQOOP is not installed, or it's not in the optional component also. After creating the cluster, you have to follow, this is actually a link, this initialization action. If you click it, they will give you the steps to configure and run your SQOOP jobs. So that is how you have to follow. This is what you need to know. And one more thing, this Dataproc comes under which service? Because Google Cloud has so many services for AI, virtual reality, networking, database and analytics, so many things, right? So out of which, like, even we have this Web3 technologies as well, for everything they give. So if you take Dataproc, the fully managed big data service, which comes under data analytics. Okay. So data analytics is under the category we are getting it. Even EMR comes under data analytics in AWS. Fine. So now how to create this Dataproc cluster? As I told you already, so if I want to add this Dataproc in my resume, do I need to spend more time in knowing it? No, not required. This video is wide enough so that, like this video, and there will be one more video. So in this video, I'm going to show you how to create the Dataproc cluster and how to check whether all this Hadoop, Hive stuff are installed. So in the next video, I'll be teaching you how to submit a Spark Spark job. So submitting a Spark job in Google Cloud Dataproc, we used to say as submitting a Dataproc job. The command itself will be Dataproc, submit Dataproc. So it will be that way. Okay, so it's like when I say Dataproc job, it's a Spark job. Fine. So that will be in my next video. With this 2 video, you can conclude that you can add your skill set, cloud skill set. You can add this Dataproc, and even you can add EMR after watching my EMR video. The basic thing and advantage, just have some read some theoretical content of what is Dataproc and why we need to use it. I'll tell you a few points here. The first point that we are moving to this cloud, right? Pay for what you use. So that is very, very, very good thing, because on-prem, when I say on-prem, opposite to cloud. So your company has buy all the servers and they do all the setup and installation on their own, right? It costs a lot, right? So pay for what you use, all about renting service, and that's what the cloud computing advantage itself. So this Dataproc, imagine you are just going to run a job like weekly thrice, some particular batch jobs or stream jobs, whatever it is. So it's just going to happen only for 3 days in a week. In that, and the remaining days it's waste that you are paying for your on-prem cluster, right? So pay for what you use is you create a Dataproc cluster, and then you just run your badges once it is done, and then you can destroy the cluster, so that you can stop the cluster. At least instead of destroying, you can stop, or you can delete the cluster, so that the thing is like what you are getting is like the cost saving. Right. So you can ask me, when I delete it, what happens to my data? So what we do is we have the data in the outside world, that is in an RDBMS or in kind of cloud storage we will be having. But then the processing alone we use Dataproc, and the final output also we use in some we store it into some external services. Like if you take especially Dataproc, right? The Spark jobs output, they used to write it in BigQuey. BigQuey is similar to Hive, but it's a separate service, like which it's not inside a Dataproc. It's a separate data service which is given by Google Cloud, which comes under data analytics. It replaces Hive actually. So when it goes to whenever I've seen most of the people, like 90% of people who goes to this Google Cloud for Dataproc, right? They used to write their data in BigQuey. BigQuey is fast than Hive actually. Okay, fine. So you can see here BigQuery is also coming under data analytics. So this is the advantage. Pay for what you use. On demand clusters. That means you use it and then you kill it. That's it. Fine. So now let's go back to the home page of Google Cloud. So they are giving you $3,000 credit for 90 days. You can use it. It's completely free. You can see here I got like around 25,000 of credit, and it's almost like 500 I have spent for the last 3 days. So now this is a home page. Now you can search for Dataproc. So this you have to click. So here first you will be getting an option enable. You can enable that. It takes some 2 to 3 minutes, and then you will get this page actually. And I already have a running cluster, so I'm going to show you how to create a cluster, a new cluster. Just click create cluster. So this is something you will not do in your company. It's completely the admins will take care, but I'm just showing you like how to do it for your knowledge purpose, so that you will be getting the confidence to add this in your resume, right? So that's why. So create a cluster on compute engine. This is what you have to choose, not on this. It's up to you, but this is Kubernetes engine, but let's go for compute engine. What is compute engine? A compute engine is nothing but a machine, right? You need to create a cluster on a machine, right? You need a Linux server with some RAMs, with some CPUs, right? You need a laptop to install like that. This compute engine in Google Cloud is an instance, a virtual machine, right? So whereas like even in AWS, we have to create it on top of an EC2. In AWS, we used to call it as EC2 instance. That is a virtual machine name. So in Google Cloud, we call it as a compute engine, which is a virtual machine name. Okay, fine. So I'll create it on a compute engine. So you can ask me where I can choose my CPU and RAM. I'll show you that. So now you can give any name for your cluster. We can leave it as it is. Location, region, it is up to you. You can choose this zone and region under location. And I'm going to choose the single node. So I'll go with the single node cluster creation. And then if you come down, you can choose the Linux version and Hadoop Spark version. You click change here. So based on the version of Linux OS that you choose, or you can even customize the image, and you have something the version. So if you choose this, you will get Hadoop 3 and Spark 3, and mostly like if you see it's like more than like 2.5x version only you have. It's wide enough. Most of the companies are using it. So the default one that comes with the selection is Hadoop 3.2 and Spark 3.1. Yeah, that's the best one. And when you come down, right, you have this component list. So these are all some of the components which is an optional list. So you can choose. If I want HBase, I can tick HBase, and I can, even after creating the cluster also, you can have it. Fine. So now if you see configure nodes, it's all option. If you see the remaining 3 steps is completely optional. So I just wanted to show you this configure nodes where the mission type, if you see end to standard. So mission type is something based on the type of mission you choose, the configuration of the mission, like the CPU cores and the RAM will change. So if you see here, now I have this 4 CPU and then 16 GB of RAM, and then you see the disk size is going to be 500 GB, and if you want you can change this. So now I am going to create this cluster. So the cluster is creating here. Yeah. So you can see I have already created one cluster which is running. So list of cluster. So all these cluster in background, it will be running on a virtual machine, right? So for that, go to a new tab in Google Cloud in your login itself and just search for VM, and you'll be getting this VM instance, this one, compute engine. Click this. So when you click this, you will be getting all the missions which is running actually. So you can see here there is 3 Linux servers are running. So one is like my old cluster which I created before this video, and this is the one cluster which runs on one single node Linux machine that is showing here. This is our cluster which we created now, and there is one more Linux machine which I have created already. It's just a normal machine. It's not a Dataproc cluster. It's a normal Linux machine with 16 GB RAM and 4 CPUs I have created. Fine. So if you see the cluster which we created, it's still provisioning. So I'll just show you with the cluster what I created already. So this cluster 1300. So you can do SSH in the browser itself. That's a good thing that I could see in Google Cloud and AWS. Now they have this facility. Before, like, we used to have this key and then this IP address, we have to connect it via putty, but now the browser itself has that support. But still, if you want to connect via putty also, you can able to do it. Now I'll just click this. You can click open in browser window. So you will be getting this browser, the SSH browser. It's like a terminal, a Linux terminal. So here settings you can change your font size and themes and all those stuff, and you can change your Linux username also. By default, the username of your Dataproc instance or any instance is your email ID. Your Gmail ID actually. So if you see here, this is my Gmail ID actually. So if you want to change this to something else, yeah, you can change. Fine. Now what I'm going to do, Hadoop, directly I'm going to run my Hadoop commands, Hadoop fs-ls. So we don't want to install anything. It's a pre-configured managed service, right? So I don't want to do anything. All right. Now I'm going to type Hive. It enters into Hive shell. So it's entering into Hive shell. So now I can even show you the Spark shell as well. So let me exit. So you can just run some command, show databases. Oh, I'm sorry. It's show data basis, spelling mistake. Yeah, so I can see default. It's a default, only one default database is there. I haven't created anything. So exit. So let me clear the screen and then I'll type Spark -shell. Enter. So this will enter into Spark shell. So only thing is, like, whenever you say the Spark job in Google Cloud, we used to call it as a Dataproc job, and the command itself, when you do so we used to have the Spark submit command, right? Instead here you have to use the keyword Dataproc, cloud Dataproc as a command to submit your job, but it's again your Spark job. It's again your Spark job. So I'll show you how to do that, how to read data and then process it in Spark, and how to submit that as a Dataproc job and write the Spark output in Google's BigQuery. So this is something I'll show in my next video. So if you are not finding my next video in my playlist, please wait. Within this week, I'll be uploading that video as well. So you can see now we are into Spark shell, and you can come out of this as well. So we have all this pre-configured thing installed. So after completing this video and my next video, how to submit a Spark job, like a Dataproc job, you can add in your resume that you have worked in Dataproc. And the same way, you see my EMR video, right? You can mention that you worked in EMR AWS as well. So it's like, as a big data engineer, we just need to know what the service name of our big data managed service in the respective cloud seller. So they do have other products under data engineering, not big data engineering. They do other data engineering components. As I told you, this BigQuery, which is not in Apache Hadoop or any open source thing, it's only there in Google Cloud. So BigQuery is like again a query engine, like where we can do all type of ETLs as well in BigQuery. It's very faster than your Hive. There also we have this concept of bucketing, partitioning, and everything. So it's about like it's completely optional that if you want to learn, you can learn it and you can project, or else not required. So for learning and practicing, you have this BigQuery also comes under your free credit. You can use it for sure. How to submit a job, a Spark job in Dataproc, and how to execute it. So here, one important thing I want to say is Dataproc job. Whenever you enter into Dataproc, Spark job is called as Dataproc job. So don't get confused. When someone say Dataproc job, it's a Spark job. Okay. So Dataproc is a fully managed Hadoop Spark cluster by Google. It's a big data as a service which has the pre-installed cluster setup will be there, and you don't want to set up or install anything. So just I highly recommend you to watch my previous video. I have given that link in the description box of this video, in which I have explained what is Dataproc and how to create a cluster. Fine. So now what I'm going to do is, so I'm going to read BigQuery data, and then I'll tell you what is BigQuery, and then I'm going to process it in Spark. It's a Spark job, but we call it as a Dataproc job. Dataproc job. Okay, and then finally the processed output I'm going to write it in BigQuery again. Okay, so now here what is BigQuery? So generally outside the world of cloud, you imagine, so we have a machine and in which I installed a single node Hadoop and Spark, and then if I'm going to write a Spark job, I'm going to read it from HDFS or Hive, and then again I'm going to write it back to Hive or HDFS. This is what you people have done, right? And after entering into this Dataproc kind of clouds environment, right? So BigQuery is a query engine, a data warehouse query engine. It's not into big data, but it's a data warehouse where you can do ETL provided by Google. Only when you come to Google Cloud you can use it, or else you can't. So this BigQuery is an alternate for Hive, I can say, in a simple word. So that means we are reading it from Hive, processing it in Spark, again writing the output back to Hive. So the same way in Dataproc, I'm reading it from a BigQuery and I'm doing a process in Spark job, and that is called Dataproc job, and finally writing to BigQuery. It's like an end-to-end project, right? So now when you use this Dataproc thing, right, finally before writing to BigQuery, what Dataproc will do is it just used to store the data temporarily to a cloud storage. It's like a temporary storage for a BigQuery to export the output before storing the data as a table in BigQuery. So BigQuery needs it. So Dataproc, it will export the BigQuery output in a cloud storage temporarily by creating a file and a directory. It will store the output here, and then it is export to BigQuery. So this is how it happens. So cloud storage is a service that we have it in Google Cloud. It is similar to our HDFS, but it's not a file system, similar to HDFS. And if you are aware of Amazon Web Service, right, there we have something called S3. So this cloud storage and S3 and all, it is there in AWS and Google Cloud, where any services can use the file which you have stored in cloud storage, and same as S3 as well. So any services in Google Cloud can able to read and write the data from cloud storage. So cloud storage used to store everything like any structural data, like structure, semi-structure, unstructured, in object format, but it is not a file system or a database. So with respect to writing it before BigQuery, it exports the data temporarily in a cloud storage and then it writes to BigQuery. This is what. So we are going to use the components like cloud storage, Dataproc, and then BigQuery. Okay, fine. So now what I'm going to do is read the data from BigQuery. It's a table. BigQuery has everything as a table, row column. So I'm going to read the data from the table and I'm going to do a process. My ETL process will happen here with Spark. We call it as Dataproc job, and then write it back to BigQuery. So okay. So now you can ask me, like, after writing it to BigQuery, who is going to consume the data? Your downstream. So the data which we get from is upstream. The data which you are going to give after the processing is downstream. A downstream could be another data team, or a downstream could be a reporting team, where they used to use some visualization tools to connect and generate the report and hand it over to the client. Okay, fine. So now you can ask me, like, what type of program you are going to show you for this particular project. So I want to make this video very simple. So what I'm going to do is I'm going to use word count, a traditional example. So the input for the word count is words, right? So this words already presented as a table in BigQuery, which is already there in BigQuery. You don't want to create it. It's default, it is there. So I have to query the table and then process it here and then write it back to BigQuery. The final counted words in the BigQuery has 2 columns in a table, right? So that is what we are going to do here. Fine. So let's get into the practical. And if you see here, I have the steps. So first thing, you have to create a data set in BQ. When I say BQ, it is BigQuery short form BQ. So MK, you are creating a data set. You can ask me like, what is the data set? So generally we call database in Hive and RDBMS, right? A database is equivalent to data set in BQ. So for creating it, you have to use MK BQ command. So I have to create a data set. It's like a database. So I have already created a cluster, and how to create a cluster, the video is there in my previous, the topic is there in my previous video. You can refer it. And it is free. Some credits are free. With that, you can practice all this. So the data set has been created. Fine. So now I'm going to create a bucket. So bucket means it's like a folder that you create in the cloud storage. I showed you in the diagram, right? So before writing the Spark job, before writing into BigQuery, it exports the output in cloud storage for temporary, and then it write to BigQuery. So for your Dataproc to export the data, we are creating a cloud storage bucket. It's like a place where you create a folder, and the folder is equal to bucket. In Amazon also, in S3 we call it as bucket. The folders are called bucket. So you have to create a bucket, and this bucket name should be unique across the globe. It's not unique within your login, across the logins. It should be unique. So gsutil is a command which we use to create or communicate with the cloud storage. It's like how you use HDFS commands to communicate with HDFS file system, Hadoop DF or HDFS DF, right? Similar to it. And MB is make bucket. So I'm just going to create a bucket now. Okay, so the bucket is created. Now let's get into the program. So they have shared this in Dataproc website itself. They have this code, and I have given the code link in the description box of this video. So they have given the code for Spark Shell as well as for IDEs like IntelliJ and Eclipse. So if you uncomment this piece, right, you can create a .scala file in Eclipse or IntelliJ. You can create a jar file. You can submit it. So if you want to use only Spark Shell, then you can start from line number 19. So I'm going to create a file first. So I'm going to use a Spark Shell. So I'm just going to create a file, vi wordCount.scala, and I'm going to place my code here. Okay, so before that, let me explain you, or I'll just go through you this code. I'll just give a walkthrough. So I'll just change so what is the data set that we have created is dataset underscore 1. Okay, so the full dataset name is wordCount underscore ts underscore dataset 1, and then the bucket name that I've created is, it's 1993. So let me remove this comment. I've just commented it for some other purpose. Let me remove it. So now this code as is what I've showed in the notepad. So it's the bucket we created is 1993. Let me change it. Fine. So this is a code. So this is a bucket that you are created for the Spark job to finally write it, export the output before loading it to BQ. Now here you are reading it. So I'm reading it from a BigQuery table, and here I'm giving the table name in BigQuery. So dataset.table name. Okay, so till sample it is dataset name, Shakespeare is a table name. So this has words. So I'm reading it, and then I'm creating a temporary table words, and then I'm using a Spark SQL to achieve this word counting. You can use data frames also. And finally I'm writing it to wordCountDF.write.format BigQuery, and here you can see this is our target data set and the table. So this table name wordCount underscore output will be created automatically. So only thing what we have to do is you have to give the data set name which you have created. That's it. Now save this code. Now you have to enter into Spark Shell. So to enter into Spark Shell, you have to give Spark-shell, and you have to pass this dependency jar as well. So what is this jar for? So now our Dataproc is going to communicate with BigQuery, right, for reading and writing. So you need a connector for Spark job to connect with BigQuery. So this is a connector jar provided by Google itself. So you have to use this. So if it is a Spark submit, so as I told you here, we are not going to use the word Spark submit to submit your jar file. Instead, you have to use cloud Dataproc submit, and then you have to give this dependency jar name, and then you have have to give your jar name, the word count jar, and then Spark memory, executor memory, so on and so stuff. So now I'm going to use Spark shell only. Enter. So you have to use this dependency jar when you are logging into Spark shell, else BigQuery connection will not be get established. So after entering into it, you can run the program. So from Spark shell also you can able to run a Scala file. So after entering into it, I'm going to run my Scala file. Okay, now we are into Scala. I'm going to execute word count.scala. So it's reading the bucket. Now the word count process will get start. And we have print schema and the show. So it will show you the output. First 20 records it will show you. So now the word count job started. So once this is completed, so next again it will start to write it to BigQuery. Like first it exports the data in the cloud storage bucket which you have mentioned, and then it writes to BigQuery table. So now you can see the sample output and the print schema, like you have two columns. So now BigQuery write is happening. It is completed. Now I'll show you in BigQuery. Okay, so for that you have to enter into your Google console, click here, go to BigQuery SQL workspace. So when you get into SQL workspace, you will be seeing this window. I'll just refresh because we created a new data set, right? So let me refresh it. In left hand side, you can able to see the list of data sets which we have created. Okay, so now if we expand this, so you will be seeing the data set. So this is the last data set is what we created, right? Word count TS dataset 1. This is what we created. If you see within this, you have a table. So this got created on the fly. So our dataset name is word count underscore TS underscore dataset underscore 1. And then the table name is word count underscore output. So now run it. So this is your BigQuery actually. Like similar to Hive, this is a BigQuery console. You will be seeing your output. I'm just giving limit 10. That's it. Right, so this is what like end-to-end like we discussed. SQOOP. So SQOOP is one of the important component in Hadoop framework, and SQL plus Hadoop is called SQOOP. Okay, so SQ from here and OOP from Hadoop. So it's called SQOOP, and SQOOP comes under a data pipeline. We call it as a data pipeline tool. Any component that migrates data from one place to another place, we call it as data pipeline. So SQOOP comes under data pipeline. So here, what SQOOP is actually doing and from where it is migrating the data. So SQOOP is used to migrate the data from RDBMS to Hadoop and Hadoop to RDBMS, and it's open source. It's free to download from the Apache site. So group of people from the different background and different organizations and individuals who contributed for SQOOP. It's not like invented by one such organization, like we say Hive by Facebook, right? So and Pig by Yahoo. So SQOOP is not something like that. It's invented by a group of people from different concerns, organizations, and they are like contributors. So they have invented it, and it's free to download, as I told you. So RDBMS to Hadoop, and that's what SQOOP is doing. So RDBMS, when I say RDBMS, like import and export from and to Hadoop is possible with SQOOP. When I say RDBMS, that could be any or traditional database like MySQL, DB2 or Oracle. You can use any RDBMS tables. And when we say Hadoop, so there is two types. I will just elaborate to which component in Hadoop that SQOOP can able to import and export. So in SQOOP we have two things. One is import. You can import data from RDBMS to Hadoop, and then export. That is, you can export from Hadoop to RDBMS. In import, HDFS like RDBMS to HDFS is possible, and then RDBMS to Hive is possible, and then RDBMS to HBase. So we have these three components in Hadoop to which RDBMS can migrate the data, SQOOP can migrate the data from RDBMS to Hadoop. So when we say Hadoop, only three components like HDFS, Hive and HBase for import. Okay, so you can directly migrate data from MySQL to HDFS, MySQL to Hive, or Oracle to Hive, and MySQL to HBase, etc. Now export, in export like from Hadoop to RDBMS, so HDFS to MySQL. So when I say MySQL, that's RDBMS, okay? RDBMS, any RDBMS, not only MySQL, but today I'm going to show you with MySQL only. And then Hive to MySQL is possible, like RDBMS is possible, but HBase to RDBMS is not possible. So in export, there is only two things you can do, like HDFS to RDBMS and Hive to RDBMS. HBase to RDBMS is not possible. But in import, it is possible because your SQOOP can able to migrate the data from from RDBMS to HBase so that HBase can able to understand the structure of RDBMS, but vice versa is not possible. So your RDBMS will not understand the NoSQL type, right? So your RDBMS can't able to accept the NoSQL data, and that's the reason you can't do with SQOOP. Even SQOOP, without SQOOP also you can't do. Okay, so in import you have 3 things to do, but in export only 2 things to do. And if you see SQOOP jobs or MapReduce job, it runs on top of MapReduce, but SQOOP is a map only job. We call SQOOP as a map only job. It runs only on map only will be getting running, reducer will not be running, because SQOOP does everything in parallel, and there is no aggregation job in SQOOP because it's just a migration of the whole table to the your Hadoop, and Hadoop back to RDBMS. It's just a table. You are not going to do any kind of an aggregation or something like that, right? So SQOOP runs on MapReduce framework, but it's a map only job. It's a only interview question that people can ask you from like SQOOP, an important interview question, right? So people used to ask you like SQOOP is whether a map only job or it's a MapReduce job. It's a map only job. Okay, that's very important to note. Fine. So that's all about the SQOOP theory. Okay, now let's jump into the practical stuff. So let me show you like what are all the prerequisites that you need, and then we can start with the POCs. Like I'm gonna show you all these migrations as a practical. Like you can even consider this as a proof of concept, and you can even add this in your resume as well. Fine. So what you need is you need to install Hadoop, because like SQOOP is a Hadoop framework, one of the component in Hadoop framework. So you need Hadoop. So you have to install Hadoop, and the Hadoop installation link is provided in the description box. If you haven't done that before, please do it. So you can just install it. That the video reference is there in my description box. Once Hadoop is installed, then you can start downloading SQOOP from internet, from Apache site. Just you have to untar, like unzip. In Linux we say untar, and then like in bash or C. So bash or C is a file. I will show you. So once you done with the Hadoop installation, then there is a file called bash or C, which we call it as an environmental file, in which we used to specify the environmental path and variable, like in Windows, right? So similar to that, here we can set all the environmental path and variables of the installed softwares in bash or C file. So once you install Hadoop, even in the Hadoop installations video, I have explained like what is this bash or C is. So once you are done with the Hadoop installation, in the bash or C file, just come to the last line of the file, where you can see I have mentioned the Hadoop home. I exported it. So this is environmental variable, and this right hand side is environmental path. So you have to set your Hadoop home, because Hadoop home is required for SQOOP. So you need to set this, and once that is done, you have to add this Hadoop home in your path at the last line. You can see like I mentioned here, and then /bin, and finally $path. You can see here my $path is here. Okay, fine. So this is very, very, very important, and once this is done, just save your file, and then you can execute it by giving source space.bashrc. Once you have executed this file, and then now you can untar your SQOOP file. So once you have just untar, like extracted your SQOOP tar file, the zip file, and that's it. There is no other installation required for SQOOP. Okay, so for SQOOP you need to install Hadoop and Java already, but with respect to SQOOP there is no installation steps. Fine. Now you can change your directory to SQOOP, cd SQOOP. Fine. So now let me show you the directory, SQOOP directory. So this is my home, in which I have installed the SQOOP. So you will be seeing a folder called lib. So in this lib folder, you have to download and paste MySQL connector jar. The reason I'm connecting my SQOOP with MySQL. If it is Oracle, then you have to download Oracle connector jar. If it is DB2, then DB2 connector jar. Okay, respective jars you have to download and paste it here. And that's all. SQOOP configuration and installation is done. Now we can move on to the practical stuff. So here, like other than migration, you can simply even read the data from MySQL. Okay, the very first thing I'm going to show you is just to read MySQL data from SQOOP without even entering into MySQL. Okay, so here if you see here SQOOP eval is evaluate, so the short form eval, and then connect your JDBC MySQL and host name in which the host in which MySQL is running, localhost, and the database name of MySQL. Okay, it is test. So I created all the tables in MySQL under test, and the username for MySQL, password for MySQL, and then hyphen query, and within double quotes you can pass your query. So this is just you can read the data from SQOOP, for the MySQL data from SQOOP. Now if I run this command, I can able to get the demo table which is in MySQL, but I can see the results in my SQOOP. So just change your directory to SQOOP and just paste this command. So like within some seconds you can able to see the data, the output. Yeah, serial number 2. Now I will show you the same result in MySQL. So for MySQL, if you need to install MySQL because we are doing it with MySQL or any other DB, you have to install it. For installing MySQL in Linux, you have to go for this sudo space apt-get install MySQL-server. So if you execute this command, it will a prompt will come in which it will ask for username and password. Please go with root username as root and password root, because if you go for any other custom passwords, you may forgot the password, right? So that's why I'm saying root will be easy for us to remember. So this command will install MySQL in your machine. So once that is done, entering into MySQL, the command is MySQL-u is username, space root is my username, and then -p, then enter. And it will ask the password. You have to give root. Root is the password that I have given for my MySQL. And while typing the password, you will not see the password here, but it's actually typed. Just enter. So now I'm into my MySQL shell. Now use test. I will show my list of databases first. Show databases. Okay, you can see there is a database called test. So now use test. Enter. Now show tables. Okay, you can see these many tables are there. So demo is the table which I queried from SQOOP, right? So select star from demo. Now there is only one record and its serial number is 2, and the same thing what I have queried in SQOOP, right? So here we haven't done any migration. It's just all about I'm just querying MySQL data in SQOOP. That's it. Now we are gonna start the migration part. So the very first thing, MySQL to HDFS. I have a table in MySQL and then I have to migrate that to a file system in HDFS as a file. I have to just store it as a file. So here SQOOP import and then connect and all your MySQL details with username and password, and table test1. So test1 is the table in which I have a data in MySQL. I have to move this table. I have to copy the MySQL table test1 to my HDFS file system. Okay, so now I am gonna show you there is a MySQL table called test2. I will just show you test2. Okay, there is one record, serial number 12. Now I will change this test1 to test2 because I have already migrated test1. So now I'm gonna run this. So here you can see M1, M is for mapper. So it's all about like you can increase the parallelism, like M1 then M2, something like that you can increase. So I'm gonna run this command, just copy. So here you can see SQOOP import. So this is import command, and then as usual all your configuration MySQL details, and then table -- table, the table name of MySQL, and then M1. So M1 is, as I told you, it's for increasing the parallelism. Mapper1, enter. So now I triggered it. So now I can able to see the data in my HDFS. So let me go to HDFS. So the default location for the data that gets stored is like Hadoop fs space ls. This is the default place where your the migrated data will be get stored when you do it via SQOOP. So if you want to give a customized path in HDFS in which your migrated data has to store, then you can use, there is an option called --target dir. You can mention the target dir in which your MySQL data has to be get stored in HDFS. You can mention that. And there is one more option, SQOOP import all tables. So if you want to import all the tables inside the database of MySQL, just you can give simply this. It will just migrate all your tables in the given database in MySQL. It will download. That means test is my database name in MySQL. Whatever the tables I have under my test database will be migrated to HDFS. Okay. Now I'm not doing this, but you can, if you want, you can do that. Okay, so if you see here, retrieved one record. That means like there is only one record in the data in the table, right? So like if I give select star from test2, it's just one record, and I can able to see it has been moved to copied to HDFS. Let me go back to HDFS. So Hadoop fs space ls, enter. So now I can able to see a directory named as test2, and that is my MySQL table name. That creates the directory name will be same as your MySQL table name. Now Hadoop fs ls space test2. Okay, very important. It's not slash test2, it is just test2. People used to give slash test2 and they will get like file not found. So just test2. But if you want to specify in a specific directory, then I told you there is a command target-dir, right? You have to give that. So within this, we can see there will be a file called part-m0000. You can see here part full form is partition. M is mapper output. So when it is reducer, then you will be seeing R there, part-r, but this is just a mapper output, right? So M, because I told you it's a map only job. So just copy this Hadoop fs hyphen let me do a cat here, cat command, so that I can able to see the content of the file part hyphen m000. So you can able to see like 12, right? You can see. So because this is the only record that we had in MySQL table, and it has been migrated to our HDFS now. So that means like we have done with the HDFS part, and there is MySQL to Hive. So for this, you need to have Hive installed. Like I have a video for it. I've mentioned that in the description box of this video. You have to install Hive in your machine. Okay. So here, what I'm gonna do, there is two things you can do with Hive. MySQL to Hive. You can create a table in Hive and then you can migrate the data from MySQL to Hive. Or what you can do is you can ask your SQOOP to create a table while migration. Okay, on the fly you can create a table and then you can migrate the table. So I'm going to go with the second option. I'm going to create a table on the fly while migrating data from MySQL. So the command is scoop import connect. You have to give all your MySQL information and then the table test. So test is the table which I have in my MySQL, and I'm going to migrate that to my Hive, and I want my Hive to my SQOOP to create a table in Hive as MySQL to Hive 1. So now it is 2. MySQL to Hive 2 is a table name will be get created in your Hive. So I'm giving the command as create Hive table, then Hive import, then M1. So if it is your table is already there, then you can skip this create Hive table. Okay. Then it will just migrate it. So for this you need to have Hive. So let me what I will do is I will just show you the command means the data from the table test. Okay, there is two record, 1 and 2, which I'm showing you in MySQL. Now I'm going to show you the same in my Hive. So let me come out from here because I don't have enough memory for now. So now I will just jump into Hive, bin/Hive. We'll enter into the Hive shell, and I'm going to show you whether I already have the particular table or not. I'm going to show. Okay, I will not have this particular table in my Hive. I'm going to show you that. So I have not given any database name here. That means in Hive, the tables will be get created in default database when there is no database mentioned before the table name. Okay. So now I'm going to use the default database only. I will just show you here. Okay. Show tables. Okay, so if you see here, I have a table as MySQL to Hive 1, but there is no MySQL to Hive 2. So here our table name is MySQL Hive 2. So this will be get created hereafter only. Now I'm going to run this. I will be running this. Back to SQOOP window. Enter. So now SQOOP will migrate the test table from MySQL to my Hive by creating an Hive table called the MySQL to Hive 2. Okay, so if you see here, like the Hive, the MapReduce job has been completed, but still the final touch is like it's like loading the data to the Hive. So the final touch is happening. So it says like retrieve 2 records. Yes, I have 2 records on the table. So like we will be getting an message like loading table to the particular database and the table name. So once we get that, the Hive the table will be get created. Just let's wait for that. So like it's still in process. Okay, so if you see here, loading data to the table default MySQL to Hive 2. Okay, so that means it's a default database in Hive. If you haven't selected any database, then it's a default. So currently I'm in default database, show tables. Now you can see there is the new table which has been created by SQOOP while migrating the data. Let me select the table. Sorry. I will copy it and paste. Yep. So now I'm just executing this in my Hive. So I'll be having 2 records and 1 column. Yeah, it's 1 and 10, just 2 records. Was what was I showed you in the MySQL is the same, right? So you can see here, select star from test. It's 1 and 10. That's it. So the migration from MySQL to Hive is also completed. Now the last thing is MySQL to HBase. So I'm not going to show you this in practical because I don't have HBase installed in my machine. So yes, you need HBase to be get installed before doing this. So here again, like you give all your MySQL information and then the table from which you are going to migrate. So this demo is a table which I have in my MySQL, and here also you can use the existing HBase table, or you can ask SQOOP to create it while migrating the data. So here you can see HBase table, test HBase, and then the column family is CF. There is a concept called column family in HBase. So like if you know HBase, you will come to know this. Column family name I have to give, and then HBase row key. For sure, there should be a row key in your HBase. For sure, you have to create one row key column, and whatever the integer column was there in your MySQL table, give that as a row key for the row key. So I'm giving my PID column name, which is there in my table demo, as a row key here. So it's like a row ID that needs to be get created for sure in HBase. So you need to have kind of an integer column when you migrate the data. So assign one integer column of your MySQL database table to this particular row key, the column. And then HBase create table, then use like you can give your parallelism. So this will create an HBase table with the column family CF, and the data will be get migrated. Now it's done. Now let's move on to like export. So as I already told you, HDFS to MySQL is possible, Hive to MySQL is possible, HBase to RDBMS is not possible via SQOOP. Even without SQOOP is also not possible. Fine. So now what I'm going to do here is HDFS in which I have a data as a file, and I'm going to move this file to my MySQL table. I created a table as name1 here. So let me show you that in my MySQL. Let me log on to my MySQL. Okay, so use test. So let me create a new table. Okay, so create table name underscore 3 serial number int, and then comma name varchar of 10. Okay, so why I'm creating 2 columns, right? So sorry, spelling mistake. Okay, why I'm creating 2 columns, right? See here, the file what I'm going to send for means the file which I'm going to load it in MySQL is name.txt. This name.txt has 2 columns. I will just cat this in HDFS, Hadoop fs -cat, enter. So like I have 2 columns here and 1 record. The value will be 1 comma Gautam. So you can see here 1 comma Gautam. So this name.txt has 2 columns, and that's the reason I created 2 columns in MySQL here. So now I'm going to move this, copy this file from HDFS to the table MySQL name underscore 3. So back to the commands. So here I remove this name1 and I'll just put name3 because this is my destination table MySQL, and this is my command export dir, and I'm going to export this particular directory. Along with the file name you can give name.txt. Now just copy this and back to the SQOOP window, just paste, enter. Okay, so you can see here the export has been completed. Now go back to MySQL and I'm going to select this table, select star from name underscore 3. Yeah, you can able to see the record here 1 comma Gautam. So what we did is we moved a file from HDFS to MySQL. So export is done. So the next thing is like Hive to MySQL, and if you see the command, right, it's almost same. The HDFS to MySQL and Hive to MySQL both are kind of same. You can see here also I'm giving the HDFS location, and here also I'm giving export dir the same HDFS location. So the one difference between these two, here this particular directory was not used by any Hive table. So Hive, whenever you create a table in Hive, what will happen is the Hive will store the data in HDFS only. Right, so migrating data from Hive is nothing but migrating the data from the HDFS to whatever the destination is. But the thing is, the HDFS path what I have given here is pointing to a table. That's the only difference. So this demo I will show you in the Hive. So just move to Hive. So show tables. Okay, so here, okay, it's in a different database. So use test show tables. Okay, you can see there is a table demo, like select star from demo. There is only one record, one, and I will show you the location of this table in HDFS, because any table that you create in Hive will get stored in HDFS only. So show create table, this is a command which will show you the location of the table demo. Okay, so now you can see this is the location of my table in HDFS. So here, so whatever the data that you load into the demo table will be get stored in this location in HDFS. So I am going to give this location in my export command. So that's it. So but if you see this demo, this particular directory is pointing by an Hive table, but here it was not pointed by any Hive table. That's the difference. But anyway, I'm going to use the same HDFS path only. So because sometimes when people used to say, like you said Hive, but there is no Hive table name here, you are giving just simply a path similar to HDFS export. So yeah, so this is also same like the previous one, but this demo is pointed by a Hive table. Now when you just run this, what will happen? So again, like I have created a table in MySQL called test Hive. So to this test Hive table, my Hive data will be get migrated. So let me run this. So I'll give test Hive underscore 1. Okay, so let me run this. Yeah, okay, I don't have the table in MySQL. So what we can do, we can create a table. So test underscore Hive underscore 1 is what the table name, right? Okay, I have decided to have. Okay, then serial number, it's just one integer column we have in that table, right? So sorry, oh, I'm sorry, create table. Yes, okay, I created a table test Hive 1, and in Hive I queried you, I just showed you, right? Select star from demo, it has only one record. Now I'm going to migrate this data to my MySQL. Okay, so let me go back to the commands, just copy this and then run it. That's it. So now we can see the data in MySQL from Hive. Let's wait for the execution. Okay, so here it's exported. So the data has been exported. So exported one record. So now I will show you this in MySQL. So select star from test underscore Hive underscore 1, enter. Yeah, so we migrated the data from MySQL to from Hive to MySQL, but it's again HDFS location, but it was pointed by a Hive table. Okay, that's a difference that you need to understand. So that's all with respect to the video. I will share this commands in a page, and I will just share the link in the description box of the video where you can find these commands. And HBase is the thing that you have to try. And if I get a time, like I will install and make a separate video for this. The important 10 points that we need to explain before and after explaining our big data project. So in this video, I am not going to explain you a big data project with an architecture and so on so stuff. Okay, that is not the agenda of the video. So whenever you go for an interview, when we start explaining our project, there is some important things that we have to explain before and after explaining the actual project, and that is the important thing which is required for the interview, and we will impress a lot. Like interviewer will be get more impressed when we explain that, and they will believe us in with that we have a real-time experience for sure. And sometimes even people do have the real-time experience, but they fail in the interview. The reason is, even though they explain the project and the architecture internals and everything, but still there should be some kind of an interesting facts that you have to explain, and that is what I'm going to give you today. Okay, so please do watch this video till end so that this will be very useful for you. Okay, so now you have a big data project. So as I told you, I'm not going to explain, but there is an upcoming series coming where I will explain different big data projects with the architectures. Okay, so you can get all the videos link from the description box of this video. Fine. So now the 10 important points. Point number 1. Okay, so what is your LOB? LOB, full form, line of business. That's very important. So you work for the IT company, which they do a business of pharma or banking or finance or fintech. So what a retail, what line of business your company is doing. That's very important. So because some companies are very familiar for you, but your company is very familiar for you, right? But if you go for some other company for an interview, when you just say the company name, they don't even know what is that company is for. Okay, so if you say some very famous company, then they will come to know, okay, this is banking, this is pharma. But when you say some small company, you worked in a small startup or small product based company, so people will not come to know what is the line of business. So it's very important to explain your line of business. Okay, that is the first thing. And second question, what is your upstream technology or the upstream team? The upstream is all about the source team from which you will get the data. So what is your upstream? The upstream is again a team. It's okay, let me name it as A, and our big data project team, let me name it as B. So who is your source team and the team which gives you the data? And you do some process in your big data, right? So what is the upstream? The upstream is a team, and that could be again a technology. It could be some technology that particular A team is using. That technology is your upstream. So it could be a mainframe, or it could be a database, or it could be some ETL technology like Informatica or Ab initio, or database means it could be an Oracle or Teradata. So, or it could be even a flat files, just a file. If some files will come to some common path, and from there you will read a file and you do all the process in big data. So you can say it's a flat file also, but you have to define what is your upstream and which technology it is. That's it. It's a simpler one-liner explanation is enough, and you don't want to explain what your upstream is all about, what they are doing and all. It's not at all required. And who is upstream for your upstream? So that is not required. So just one-liner, what is your upstream? That's it. And what technology it is. So from which you get the data, right? So same question, who is your downstream? So you get the data from the A team, which is your source team, and you do a lot of processing in big data. You do with Hive, Spark, and blah blah stuff. You do some process, and to whom you are going to give the data? Someone, right? Some team is there for that. For them only you are working, right? So who is your downstream? To which I will give my processed data. So your downstream. Okay, so third question. So far we have seen two questions, like what is your upstream, and then like what is your line of business, and the third question is your downstream. Again, your downstream could be some team which, okay, let me name it as C, and some technology they might have used it, right? So again, you are sending it as a file, or you are loading it in a DB, or the extracted file, the processed file, or you are giving to some visualization team. Okay, some visualization team like Tableau or MicroStrategy, you are giving to some visualization team from which they will prepare some charts and they will give it to the client. Okay, so again, one-liner explanation of what is your downstream and what they are going to do with your data. So again, one-liner. It's pretty much enough. And then fourth question, type of your data. That's again important. So you get some data as a DB or from ETL tool or from mainframe. It's completely fine. It's completely fine. So it's going to be a structured data, or you have to say I'm getting some semi-structured data or unstructured data. And again, even it is a structured data, and you are getting it as a file. And what is your file format is important, whether it is TXT or CSV or some format, some other format of files that you are getting. So defining your file format is important. Same question. Fifth question. So in which format that you give data to downstream? That's again a question. Again, you if you load it to a database, then fine. But if you are giving it as a structured file, then again you have to say whether you are giving it as a TXT file or CSV, something. So you have to define your upstream file format and your downstream file format. Sixth question, frequency of data that you get from upstream. Okay, so that means like imagine like we have some data that will not come always, or like it won't come just once in a year or once in a month. It may or may not, right? So you have to define the frequency. So imagine, for example, I will tell you one of the frequency which I worked in one of my project. Like I will get the data two times in a week, Wednesday and Saturday, and then I will process. So, or you are getting daily basis like 5 hours once, or you get 1 hour once. For every 1 hour once, you will get a data. So you have to tell the frequency from upstream. In what frequency you will get the data? It's all scheduled, automated. Okay, you will get the data, whatever the frequency that you have defined between you and your upstream team. You have to explain. And seventh question, it's again the same with your downstream. In what frequency that you are giving the processed data to your downstream? That's again an important question. So one important point here you have to note down is it is not mandatory that your upstream frequency and downstream frequency should be like equal. It's not like that, may or may not again. So you get data from the upstream 1R once, but your downstream required the processed data only by 5R once. It may or may not. The frequency changes. It depends on your upstream and downstream agreement, what you had with your downstream team and what the agreement you had with the upstream team. Now imagine every 1 hour once I get the data from upstream, and then I will process the data, and I will be giving this data to my downstream by end of day. Okay, this is one use case. So define your frequency from upstream to your team, and again from your team to your downstream. That's the thing. Fine. So the next question, size of your data. Okay, so you have to say some rough average size of your data. So what is the volume of the data that you get from your upstream? Okay, so let me give you a scenario, explain an example. So I work for a banking company, imagine, and we have like we do have some we handle data of from 15 countries. Imagine in that way. So all these 15 countries data as a file, it will be get generated, and every 1 hour once I will get it, and that means from the source team you will get 15 files for every 1 hour. Now you try to get the average size of these 15 files of every 1 hour. Okay, or you can even consider based on, you can custom you can manually change the size, depends on the volume that you get from different countries. But what I'm telling you is an average size, or even you tell the row count is also fine. You get 1 million records from 15 files, or you can say like 1 million records from each file, or 3 million, or even 100 records, that is fine. But an average size will be kind of an adding an extra spices to the food, so it will be in that way. So you can even say 25 GB roughly, or 100 MB, 100 GB, it's also fine, because I've told you in a different videos that volume doesn't matter. It's all about how you have handled the data in the project for what problem. That is important. So don't worry about telling the volume, okay, I have to tell 100 GB only, I have to tell 20 GB only. It's not that way. And if you already working with some data projects like data warehouse, or existing other than big data, you are already in the data related projects, then you can use your volume of data what you are currently handling. Or if you are new to big data or new to the data world itself, then you can check with your friends or colleagues who work on some data related projects, and just ask them what will be the average size of data that we will get. So that is for your self thing I'm saying. But actually what I suggest you to say, even you say 25 GB per hour for this 15 file, is still fine. It's still okay. It's not about you have to say 100 GB, 200 GB, doesn't matter. Okay, now the next question is all about, okay, so again, are you using any compression format? So when you receive the data, right? So you are getting the data from upstream. You use any, if it comes as a file, then are you doing any compression? Like you are using zip format or tar file, something like that. So you are compressing it. If we are just loading, we are getting it from the table, then it's fine. But if you are getting it as a file, then whether it's compressed or not, mostly when you are getting as a file, it will be compressed. And again, the same question, like how you will give the data to your downstream. If it is a database, then fine. For example, you receive a file from your source team, and in your big data, you are processing with Hive and Spark. You are doing some magic on top of it, and then you are loading the processed data of from the Spark and Hive, again a table in Hive. So the processed output, you are again storing it as a table in Hive or some other RDBMS, and from which your downstream will read it. So again, what way like you are giving the data? It's the DB means fine. If it is again a file, your processed data is going as a file, and again you have to say like whether you are compressing it before handing it over to your downstream. Okay, and the last question is all about what is your data is about. That's important. The 10th question is very important. See, I'm telling that I'm working for a banking domain. Okay, it's completely fine. You're working for a banking domain, but in banking itself, we have a lot of data, right? So you have transactions, you have payments data, you have fraud information, risk management data, employees information, and then offers. So you have so many data, right? So in which particular domain of data that you are working? So if you take banking, I have these many branches. So you say like I work for payments, I work for risk, I work for employees data. What type of data that you handle? So that's Again, a one-liner or two-liner is fine. You don't want to explain the complete stuff. For example, I work for a particular pharma company, and I work for the data related to medicines, okay, or the sales. But if you take again in the sales, I will be having 200, 300 plus tables. I don't want to explain each of the table, right? So just tell them that you are working for sales related information, and then you explain what you are actually doing and what is the need for the data, that for what purpose you are giving for your downstream. Okay, so these 10 points is really important. Like before and after explaining your big data project, it gives the better articulation of providing the explanation. Presentation will be really good. And like, even though people have good experience, but still they used to say, I'm really working in big data, I have a lot of experience, like 5 years I worked, but still I'm failing in the interview because I was not able to present the project properly. It's because, like, you have to add these points. So these points will come as a question also. That's very important. If you miss to explain these 10 points, then this will come as a questions for you. Okay, so before they ask you this, if you tell everything, then it will be good in the interview. The top 10 interview question that I used to ask if I'm an interviewer. So the very first question that I'm gonna ask in all the interviews is Hive partition versus bucket. Sorry, partition and bucket. Okay. Okay, this is the first question, and this questions you will always face in any interview that you go. So now imagine there is a table in Hive and you have a column like country. So you get data from different people from different countries. Now imagine there is no partition in my table. So you get Indian record and one US record, and there is one more US record, and there is one more Indian record, and there is an Australian record, two Australian record, and then there is an UK record and UAE, and again UK. Now I'm going to write a query, select star from the table where country equal to India. So what will happen here? It used to first read the first record, India. Okay, India is there, and then it used to read the second record, and then third record, and then fourth. Okay, there is a record, India. So now here the question is, why my query has to read these two records? Because this is not the Indian record, they are US record. Yes. So when there is no partition, your Hive query will do a full search. Your Hive query will do a full search, and that means your read time will get increased and your query performance will go down. So here the partition comes into picture in Hive. So we create partitions, like one partition for one country. All Indian records will go here, and all US record will go here, and then UAE, and then Australia, and something like that. So now there is two partitions in Hive, whereas static partition and dynamic partition. In static partitions, just you decide the partition before you create the table itself, or while you create the table itself. And if you have only 4 partitions got created, only the 4 partition will be get created. And even though if a new value comes into picture, for example, you decided to have only 4 partition for the country column, but then there is a new country comes into picture, but you have mentioned it as a static partition, and that means, imagine now this is a static partition, you created 4 partition, and there is one more new record comes like UK record. So what will happen, right? It will create one partition in which UK record will get stored, and there is one more record comes like it's like Japan record. So again Japan record also will go here. That means hereafter whatever the new country comes into picture, it all goes to one partition. Because this is static, only for the partitions which for the country which you have created will be get distributed equally, but other than that the remaining all will be into one. So dynamic partition is something different. So you don't want to mention the partition count during creating the table. The Hive itself will take care of it. So for example, if any new record comes, okay, take this example itself, dynamic partition. If UK record comes, it will create one new partition for UK, and then Japan record comes, it will create a one new partition for Japan. Okay, so it creates based on the new entry comes into picture. So dynamic partition is widely used in the real time. And here comes the bucket. So what exactly bucket will do alone is something I will discuss in the different video. Okay, so here I will just explain you the bucket along with the partition. Okay, so we create buckets. So while creating in buckets, you have to mention how many bucket has to be get created. It's not like dynamic bucket, static bucket, similar to dynamic and static partition. In bucket, we don't have such concepts. It's always static. You have to say how many buckets has to be get created. And what happens if I want to increase my bucket count in future? That is highly possible. I have a separate video. I have given the link in the description box of this video. The title is how to decide a bucket count in future. Okay, so there is a video, you can have a look. So bucket is again creating a sub partition under each partition. For example, if I have 3 buckets, I create 3 buckets. In each partition, 3 buckets will be get created. So 1, 2, 3, 1, 2, 3. And furthermore, like your records are getting partitioned. That's it. So again, Indian record will be splitted into 3 buckets here so that your query performance will be good even more. And when exactly I will use only bucket without partition? Okay, that is what I raised as a question before. I will make that as a separate video. Okay, so it will take long time for me to explain. Okay, so I don't want to make the video lengthier here. Fine. So what is the next question? So next question is default partition algorithm for MapReduce, Spark, and then buckets. So the bucket internal algorithm is something same as what Spark default partition and MapReduce default partition does. So what is default partition? So if I'm not telling the partition, then Spark, MapReduce, and bucket itself will decide where the output has to be get splitted. So that is something, it has its own algorithm to do that, and we call that as an hash partitioner, which is called the default partitional algorithm that the framework itself will take care of to decide the target for your data. So the algorithm name is hash partition. Okay, and the formula is hash of the key mod of number of reducer. So we use this word number of reducer if you are explaining this answer for MapReduce. And if the formula is same for all these three, but if it is MapReduce, you have to say number of reducer. If it is Spark, you have to say number of partition. And then if it is bucket, then you have to say number of bucket. Okay, so now hash of the key. So for example, you have a record 1 comma Gautam comma India, and there is another record 2 comma Saravana comma US. So you have something like this. So you can decide which column should act as a key column. So for that column, the hash value will be get generated. Okay, so imagine I'm going with this row number as a key column. So that means, so hash of the key will be get computed for this one. Okay, so this hashing algorithm as a, like, we will never come to know what it actually does internally, which hash value it uses, we are not aware of it, but just imagine. So the hash value computed for this one and the result is 23. Just imagine. Now number of reducer or number of partition or number of bucket is something we decide. Okay, so if it is Spark, then you do repartition of 2. If it is reducer, you need reducer of 2. If it is bucket, then you need a bucket of 2. It's all about you decide this actually. So now imagine there is 2. Number of bucket or number of partition in Spark is 2. Now what happens, right? So this 23 will be get divided by 2. Obviously it is an odd number, so you will be getting 1 as the remainder. So mod means remainder value of the division. So this one, what represents this one denotes what? Okay, now if you run the Spark program with 2 partition, you will have 2 output files, right? 4 files. So part-00000 part-00001. So you will have these 2 files. If it is bucket, then you will have 2 bucket. So this 1 denotes the position of your output file. So this is 1, this is 0, and this is 1. So this 1 denotes the position. So this is where. So 1 means here it is 1. Okay, so here if you see this remainder 1 generated for this record, right? So this record goes to this file because it is 1. Now imagine I'm going to compute hash value for number 2, and this number 2 hash value is 78. Now divide 78 by 2. Obviously 78, 0. The remainder will be 0 because any even number divided by 2 is 0. So now this 0 denotes the first file. So this 2 Saravana US record will goes to first partition. That means 0th partition. So this is how Spark, MapReduce, and buckets internally decides the placement of your record when you are not giving anything. So if you want to do something, okay, I want to customize this, then you have to write a custom partitioner in MapReduce and custom partitioner in Spark. And when it comes to Hive, you have to use partition, not to use bucket. In Hive, creating a partition is custom partition, but in MapReduce and Spark, you have to write a program custom partition. So there is a custom partition program video. I have a video for it with based out on Spark, and that video link is also there in the description box. You can refer it. So this is the second question. Let me go for the next question. So that file formats, list of file formats that you use in Hive. Okay, so we have some file formats like if you see, this is a cut copy paste image from the Hartenworks Cloud blocks. So if you see here, we have text file format and then RC file, which is row columnar full form, and there is a parquet file ORC, and there is a few more like sequence file format and n-line input format. We have so many other. With respect to Hive, the very frequently used file format means ORC and parquet only. So if you see here, 585 GB of text file will be get compressed when I use RC. Like 14% is getting compressed, and then when I go for parquet, it is like 62% it is getting compressed compared to the 585 GB. So this file format is not only for the compression, it also does different things actually, the query performance, and then the tuning part of the query, everything it's there. It's not only the compression. In some cases ORC will be best, and in some cases parquet will be best. We cannot say always ORC is best or always parquet is best. So it's always depends on the use case, but try to explain this as an answer. Just don't say, most of the answers that I used to get for this question is, candidate will say it depends on the use case. Yeah, of course, I know it depends on the use case, but explain me. You have to say like, we have these many formats and we use ORC format because so and so reason, or we use parquet format so and so reason. That is what required. Okay, fine. At the end of the day, the fact is it depends on the use case only. Okay, so what is the next question? So Spark word count program. So that is what the next question that I have asked. So Spark word count program, you can write it in any flavor, Scala, Python, or Java. So if you see here, this is a Scala version of word count program. So here you read the file and then you do a flat map. You just split the data. My file has words with space delimiter, so I have given space here, and then you are doing a key value separation where for each word you are appending hard coding 1. So that means hi, hello, hi. So hi 1, hello 1, hi 1, and then finally you are doing a shuffle on top of it by reduceByKey, so that each duplicate word value will be get incremented, because we have 2 hi. So hi 1 comma 1, it will be hi 2, and then hello 1, it's just only one word, so hello 1. So finally you are invoking an action and then you will be getting an output. So here this collect is the action. reduceByKey, map, and flat map are called transformations, whereas flat map and map is called narrow transformation. reduceByKey is called wide transformation, because in narrow transformation there won't be any shuffle, but in wide transformation we will have shuffle. So reduceByKey is in wide transformation. So this is also an interview question. They will ask you the difference between narrow and wide transformations. Okay, next question. Join two data frames using Spark SQL. Okay, so most of the time in the interviews, right, so what people used to do, they used to tell me spark.sql, and they used to write the full select query, the join query within this triple quotes. So this is the one way of doing, as I know, but this is not doing via data frames. Okay, this is not, you are not using data frames. So what I am asking you is, you have to join two data frames or two Hive tables via Spark SQL, whatever. The answer is same. You have to use this way. This is what data frame. Whereas one table called EMP, you created a data frame for one table, and there is a second table department for which you created another DF. Now you have to do a join. Employee data frame dot join department data frame comma employee data frame. So you have to get the column on which you have to do a condition. So employee department ID equal to department DF of department ID, and you are doing an inner join here, and finally you do a show. So this is what I'm expecting when I ask you to write a Spark SQL two data frame joins, or joining the two data frame. Fine. Next question. Hive ACID table. Hive ACID table. What is Hive ACID table and how to create it? So Hive ACID tables allows you to do an insert, update, and delete. And how to create an Hive ACID table? When I ask these questions, people used to say transaction property needs to be enabled, true. But that is not the only thing you will do. You have few more things to do, and then only the table will be get eligible to be an ACID table. If you haven't used in the real time, but that is completely fine. But tell them how to create a table and what is ACID table. That is what needed, because most of the time candidate will say I haven't used it, but that's fine. At least you would have been learned it, right? So I need that actually. So if you are not using ACID table, tell me why. Because we don't have any update scenarios. So we use everything for analytical process, OLAP. If it is you have updates frequently, then that is called OLTP database, means transaction process. You tell them that we are not using it for OLTP, we are using it for only OLAP. And now tell me what is ACID. then you have to say it is ACID, means insert, update, deletes are allowed. Now tell me how to create a table. So here you have to set these properties first, but this is also not mandatory for us to explain in the interview. You can say there is few set properties we have to set, and then the important thing what I'm expecting in my interviews, right, they have to tell me what are all the things that we have to do in Hive table so that my table will be get eligible as an ACID table. The very first point, your table should be an internal table. External table is not supported by ACID, only internal table. Second, your table should use buckets. It has to be bucketed. Third, ACID tables will use only ORC format. Fourth, transaction equal to true. So people used to just to say transaction equal to true, but you have three more points to say when Hive table is eligible for an ACID. So internal table, you have to use buckets, and then you have to use ORC file format only, and then transaction property equal to true. This is what expected. Fine. So the next last question. Okay, we have two more questions. Now there is a scenario. I will just give you a scenario here. Just give me a second. So now there is a scenario like I have two blocks in HDFS for which you have to write a Spark program. Okay, now the question is how many input tasks will be get created in Spark and how many output tasks will be created in the Spark. Okay, fine. Okay, so I have two blocks in HDFS and you write a Spark word count program or whatever program it is. So how many input tasks and how many output tasks? Okay, so input task. So number of blocks in HDFS is equal to number of tasks in Spark, same as MapReduce. So two input tasks, simple. Output task. Okay, by default, you haven't given any repartition or coalesce. You didn't give anything. That means if your input task, the number of input task equal to output task. So two input task and two output task. So that means you will be having two output files, part-000, part-00001. So when there is no repartition coalesce, then the default output task will be 2. People used to answer this, but not this. Okay, now you are using repartition. You are making it as 3, then fine, there will be 3 partition. Coalesce, you are making it as 1, then there will be 1 partition. But we are not using any of those. Fine. Next question. Repartition and coalesce. What is the difference between repartition and coalesce? Repartition versus coalesce. So repartition used to increase the partition. Coalesce used to decrease the partition. If you see here, I want to increase my output task. Let me say, take the same example. So you can use repartition of 3 if you want to increase. If you want to decrease, then you can use coalesce of 1. So you are decreasing it to 1. And there is one more point to explain. It's not only increase and decrease. Repartition will do a shuffle, whereas coalesce will be not doing that. Means I can say when you reduce it, the shuffle will be get reduced. It's not like the shuffle won't happen. It will reduce. But repartition will do a full shuffle again. So this is the last question, like repartition with coalesce. And these are all the 10 questions that I always used to ask in my interviews, and out of which like 3 to 4 questions is wrong is completely fine for me, but I will expect people to say at least 6 questions and answers, correct answers, then I will be selecting them. About how to build a data engineer resume, a big data engineer resume. So before getting into this video, so if you are a fresher, that is recent college graduate, you can still see this video. This will be helpful for you as well. And or if you are people like who has around like 5 years of experience or 10 years of experience, that means you already has an IT experience. Even for you, this video will be helpful. So that means like you are an experienced person, but for big data you are new. Okay, for you also this video will be helpful. And last, so you already into big data. I'm currently you are already into big data. You are a developer. You are currently a big data developer, but still you want to know how to prepare a good resume. So even for you, this video will be helpful. So for all these 3 audience, okay, this video will be helpful. Fine. So let's start with the heading. So your name, your email address, and then in your right hand side, you have to give your mobile number and then your LinkedIn. So your LinkedIn is very much important because the percentage of importance that you are giving to your resume should equal to your LinkedIn also. The effort that what you are putting in your resume preparation, the same effort you have to put on your LinkedIn as well, because nowadays HR, instead of going for job portals, they are paying for LinkedIn premium, and they are creating and login as a premium account, and then they are fetching candidates via LinkedIn, because LinkedIn provides quality of candidates compared to the job portal. So always keep up to date, like your LinkedIn should be an up to date one, and LinkedIn provides 5 stars based on the profile you build. So that 5 stars, you have to get that 5 star when you build a profile and you feed information, the stars will get increased. You can able to see that star somewhere in the right side of your LinkedIn. Okay, so you have to add your highlights and then projects and the tech stacks, and then so many other stuff. I'm going to explain you that as well. Fine. So, and then the technology specialist, that heading, it's very important. So you have to say big data developer, that's a primary tech stack, that's okay. But also you can add some combo. When I say combo, any other technology other than big data. For example, if you see my combo is big data and AWS. So I will tell you the list of combos which has high priority to low priority. So low priorities combos you can avoid. Just instead you can just mention only big data developer. And if you are watching this video and you say like other than big data I don't have any other thing to know or to feed in my resume, then fine, you just put big data engineer, that's fine. But I will tell you the combos. So big data with data science is a wonderful combo. So even the interviewer is recruiting you for big data, but still you provide data science. If you know that, you can still provide data science, and that will be like an your interviewer will get impressed when they see that combo. And then the next is big data with any ETL like Informatica, Ab Initio, any ETL tools. You can mention it as big data, ETL developer, or big data, Informatica, and any RDBMS like Oracle or MySQL DB2. You can mention that big data, Oracle. You can mention in that way. If you know any visualization, right? So you can add Tableau, ClickView, MicroStrategy. You can add that as well. And then you can add cloud. Cloud is a leading combo again. You can add like if you know big data and AWS, big data and Google Cloud, big data and Azure. You can add that as a combo. Okay, so few combos which has very low priority. For example, mainframes. You are already in a mainframe or you are a tester. Please don't add that as a combo. The more we try to make our profile to be get impressed by others, right? So we are trying to do that. So in that case, you don't want to add such thing. So testing, or if you are already in a testing background, don't add that in the combo. Or you are in a mainframe, you don't want to add that because they have less ranking when it comes to the combo part. Okay, you can simply add big data developer. That's fine. You can ask me this question. I'm already a mainframe developer and now I'm trying to switch to big data. Even in that case, you don't want me add that mainframe in the title? Yes, please don't do that. Just add big data developer. Somewhere in the resume, you can mention that you've been worked on mainframe before, but don't include that in your resume. I mean, the combo in the title. Also, you can add some other combos like big data with Java, big data with Python, big data with any other tech stacks like for example, SQL. So you can do these kind of stuff. They are like good combos, as I told you already. So that's very important. And then when it comes to summary. When it comes to summary, like whatever the summary you currently have in your resume, you can keep it as it is, but just by end you can add somewhere an enthusiastic in big data and big data related technologies like Hadoop, Spark, something you can add it in the summary itself. Plus, while you are mentioning the experience, this experience, something what you are mentioning is actually your overall experience. Okay, if you want, you can categorize that. For example, you have 10 years of experience, out of which 3 years is big data. You can mention that. Overall 10 year, related 3 year, you can do that, but it's not recommended. Okay, I mean sorry, it's an optional. Okay, sorry for that, the word that I use, not recommended, is optional. Okay, so I recommend you to go with your overall experience. You don't want to categorize that, so you can just say. And one more thing, if you have an year of experience as 5.5, make it as around 6. Okay, don't put just 5.5, 5.7, 7.1. Don't do that. Okay, just have one number over there. And coming to work experience and highlights is very important, because first page of your resume is what like an eye-catchy one. We have to build the first page. We have to build in that way. And whatever the information what I'm giving you is important, but designing your resume on your own way is up to you. Okay. I want to tell that as well, right? So, okay, what highlights I have added here? Especially in the highlights, I have added the technology, overall tech stack, what I know, like big data and AWS. You can see in the point number 2. And then I have added the remaining highlights. If you see, I have added my YouTube channel link. I have added my blog. I used to write blogs. I have added my blog URL. And I was part of Q&A site like Stack Overflow and Quora, etc. So I have added that as well. And I have written my own book and I published in my LinkedIn page. It's a self-published PDF. It's an e-book in which I have given 10 big data project and POC architecture with some explanations, one-liner explanations. So it's there in my LinkedIn. If you see, that is my 10th point. So what I'm coming to say here is your work highlights should be somewhere like your work experience highlights should be somehow like this. Like for example, you can tell me you don't have a blog, or if you are seeing this video and your question is I don't have a blog, then please write one. Because where you want to write, you can write it in your LinkedIn profile itself. There is an option called article you can write. I highly recommend you to do that, because especially product based startup companies are highly interested when you do such things. Even in my current company, they got impressed with my YouTube channel and the book what I have written. Okay, so this is what like companies are expecting from us. So please do. It's not only for getting a job. I'm saying it's personally will help you a lot. You will learn new things. Initially, if you don't know what to write, just copy paste some content and you can just paste it in your LinkedIn profile, and you can add the click here option to redirect to the site. But later on, you can try to write your own blogs with practicals or theory or whatever your point of view of big data or a particular topic you can write. So write some blog, go to Google Blogger, or you can use LinkedIn article page where you can write. And if you want to start a channel, yeah, you can start a channel, upload some 10 to 15 videos and add that in your profile as well. It's you don't take much time to do all those stuff. It's just a time what you spend on social media. Instead you can spend over there. And then participating in Q&A sites like Stack Overflow or Quora are highly recommended. Create one profile if you don't have. Please create one and try to answer some big data related questions, or you ask some question and they will and get the answer from them. Have that kind of communication. And very importantly, if you are attending interview by tomorrow, and today you are writing a blog and you are adding it in your resume, your interviewer will think, okay, just for the interview he's written a blog yesterday and he's coming now. So that kind of bad impression will come when you go to interview if you have written previous day. So that's the reason I'm telling, if you are watching this video now, once you complete this video, please write a blog immediately in your LinkedIn profile. Add that in your resume. Update your resume. That's what I can say. Just write one blog in a week is fine. So the agenda, the goal of writing the blog is not for getting more viewers or likes or not something like that. It's personally you have learned something and you are writing over there, and you get a good you will be getting a good approach from the interviewers if you added it in your resume. Okay, so that's a thing. And what other things that you have as a work experience, you can add it in the highlights as well. So this is my highlights, the same what I have in my LinkedIn also. Fine. And then certification. So certification, this Cloudera certification is a very old one that I've written in 2013, and after that I didn't upgrade my certification because certification in big data, it's not that much required as of now. So I will make a different video why it's not required and in which case it is required. I will make a separate video. But on the whole, I will say, like, whenever someone asks me if you want to take a certification, if I want to take a certification, when someone asks me, I will say no, it's not, it's optional, it's not mandatory. Okay, so don't spend too much of time or too much of money to do that. Instead you can learn something in big data instead of doing that. Okay, it's not that much important. But if you have an AWS certification or cloud related certification, of course you can add that. But if you have any other certification other than these, right, certifications like data science or big data or cloud, you can add. But as I told you, big data certifications is not it's not mandatory, and I will not recommend personally. And AWS and Google Cloud certification or Azure certification is it's like industry are expecting. If you have that, you can add that. You can add some data science certification also. But you say like I have a certification in Java, Oracle, so those stuff and all, please don't include here. Okay, so people will get confused that you have so many certifications. Yes, so that's not required. Okay, if you have no certification, that's fine. Simply you can skip this part. It's still considerable. Okay, so people don't think like if I don't have a certification then they don't consider. No, it's not like that. Okay, so they will still consider your resume. And then your professional experience stuff you can add here, and add a one liner. What is it, the responsibilities in one liner? Okay, and then education, so you can add your education stuff with your all college name and the location and all those stuff. And coming to the skill set, okay, this is very important. The technical skill set, how to categorize the technical skill set is very important. That sometimes like people are doing some mistake over here, I will tell you. See what people used to do, right? They used to write, they create a tabular column. So in the first column, they write technology. In the second column, they will write everything: HDFS, MapReduce, Hive, Oracle, MySQL, MS Office, PowerPoint, everything in a same column as a one row. But that is not recommended. You have to categorize. Okay. So if you see here, I created, like, if you see 1, 2, 3, 4 tabular columns I have. In the very first tabular column, it's for big data. So again in big data, I categorized it as data management, data processing, data ingestion, data NoSQL database, always data storage, Hadoop distribution, visualization. You can say I've categorized it. So if you take data processing, Hadoop, MapReduce, Hive, Pig, Spark, Spark Batch, Spark Streaming, Spark SQL will come under data processing. If you take data storage or database, Cassandra, HBase, NoSQL databases. And if you take workflow scheduler, yeah, we have only Woozy here. So Woozy. If you know any other workflow scheduler, for example, outside the world of big data, that you can add in the next new tabular column. Don't add it in this, because this is only for big data. And Hadoop distribution, like Apache is a vanilla flavor, but the real-time Hadoop distributions for enterprise environment is Hartanox, Cloudera, EMR. You can add whatever the environment that you know, but don't just add Apache. Apache is like for practice purpose. Okay, you should not add that, because when people see Apache, then they won't believe that you have really worked in a real time. Okay, so in real time, because people won't use Apache. Fine. And then visualization, so I just added it. So I know Zeppelin, so I've just added it. So this is how you have to categorize, because if I explain how to build a resume to 100 audience, right, out of which like almost like 70 audience, they will prepare a resume by not considering the point of categorizing the tech stack. They will send back the resume to me for the review. When I see people, what they used to do, they used to write the tech stack like this, everything in one row. So that's why I'm just pressing that point. Please categorize it. That's very important. And then cloud platform. So I've just created another tabular column for cloud platform. I'm aware of AWS, and just now I'm started with Google Cloud. So in my next resume, I can add Google Cloud also. As of now, in AWS, I know these services. And programming language. Yes, you have to categorize the programming languages also as a separate tabular column. Java, Scala, Python, whatever you want, you can add. And you can create one more like databases where you can add Oracle, MySQL, if you know some RDBMs or any other data warehouse tool other than big data. And if you see here, then I've just created another skill set where I have added the remaining stuff, whatever the tools I know. You can see the stuff I have included. I worked on agile methodology, web technologies, and then version control system. If you know GitHub or Bitbucket, you can add that. And whatever the other, I worked on Eclipse, IntelliJ, MS Office, those stuff you can add here. And one more thing I've just got in my mind as of now, when I see this version control system in the work highlights, please add your GitHub link if you have, or you create one GitHub and upload whatever the practicals that you have done so far, like Spark program or Spark SQL program or Hive queries, MapReduce program, whatever it is, upload it to a Git page, and you can add that GitHub also in your work experience. Okay, fine. So the point I've missed, so I'm just telling it again. And then next, coming back to project details. Okay, when it comes to project details, two things: projects, POC. You have to add both project and POC. Even you have done only POC is also fine. You can project that as a project. Okay, so if you see in my experience, I have done 50 plus POCs, okay, but I cannot add everything. I've just add one POC per organization. That's it. I've just added 2 to 3 POCs. That's it. So I have two categorization: project, POC. If you see, this is project details where I will add all the projects based on the organization that I worked, and there is a different category. It's a POC. Again, the POC also categorized based on my organization. So the resume should not be more than 2 pages, or max 3 pages it can be. So don't add more information, because the recruiters will not see the 3rd and 4th page and etc. So they will say only first 2 pages. So have only very less, like 2 projects or 1 projects, 2 POCs, something like that. Okay. So when it comes to project, right, what are all the things you can include? So include title, and then your role role, and LOB is line of business, whether your company is banking or pharma or fintech or whatever it is. You can add that. If you don't know what is your LOB, you can remove it. And then technology stack that you have used for that particular project. 10 technology is fine, but what tech stack that you have used for the particular project. So the wide 80% of any big data project use only 4 to 5 technologies like HDFS, Hive, Spark Batch, Spark SQL. That's it. And somewhere you can see HBase, NoSQL database, HBase, Cassandra, or MongoDB. So only people will use these 5 technologies. 80 to 90% I can tell you this. And then later only like Spark streaming, Kafka and all you can add later, or you can learn it later. So the importance what you have to give only is for these 4 technologies like HDFS, Spark, Spark Batch, Spark SQL, Hive. Okay, just give importance only for this and try to add these keywords all over your resume, because keyword search is what HRs will do. So the more keywords you give, like Hadoop, Big Data, Spark, Data Engineering, Hive, Spig, SQOOP, Uzi, the more you give these keywords, the more your resume will come top. Okay, it's like again a page rank. Okay, fine. So here you can add the tech stack, and when it comes to project description about your project in 2 lines, that's it. What is your upstream, downstream, and what you are going to do in the project. And the detailed explanation of project, you can give it like this modules, and then you can say whatever the things that you use in project, you can categorize it again. So how we categorize the tech stack, right? Data processing, data storage, data ingestion, in such a way you can categorize as a modules, like what you have done in data sourcing, what you have done in data processing, what you have done in data storage, what you have done in data scheduler. Like that, try to categorize it so that it will be easy for the interviewer to see what you have done in the projects. And roles and responsibilities, when it comes, you can say you have done a POC before starting this project, and you can say like you handled a 10 node cluster in dev, 20 node cluster in test environment and production, and you have been in the support work, and you can say a lot of other roles and responsibilities like this. And again, when it comes to POC, the same structure. And I will not recommend you to add the total number of team members, and I will not recommend to add the duration. Yes, duration. Like I've done this project in 6 years, 1 year, so I don't recommend to do that. And one more thing I want to tell you, when it comes to POC, right? I have seen many people used to say like this. This is the POC which I have done on my personal interest. I am the only person who did this in POC. Please don't say that. Okay, so if you have really done that, then it's fine saying like that, but please don't say that, because from the interview perspective, I will tell you, I have attended so many interviews as a candidate. Also, I have been an interviewer in many interviews as well. Okay, so I have both experience. So when you say like when you say that I am the only person who did this, I am the only person who did this, some interviewers will think in this way. I will tell you how they will think. So if a POC was not allocated by the company as a team, or the company has not allocated a budget to the POC, you have done the POC on your own interest, then what interviewer will think, right? You have done it on your own interest. Okay, that means this guy will do when he want to do, or else like he will leave it. So it's not that much important, it seems. That is how interviewer will think. But if you really say like this, the POC was allocated a budget by my company, and there was a team got allocated, I am one of the member in the team. If you say in that way, then it's like the interviewer will the percentage of belief on you will get increase. Okay, he will think, okay, he has done a POC really, he utilized all his time in the POC, it seems. That's how they will think. You can say in my project I worked like 6 hours a day, and I will work on my POC for 3 hours a day. You can say in that way. It's an in-house POC. We did it internal to our organization. There was a separate team got allocated, a manager was appointed to it, and I was part of the team. You can project your POC in this way, but anyways, like I'm going to make a separate video like how to project yourself in the project and how to explain your project. They are a separate video. This video is just for a resume preparation only, but just I want to tell you this point here also. Okay, so that is with respect to the POC and project. So if you don't have a project, only POC you have done, that is fine. You can still showcase that POC as a project. Okay, so here very important discussion we have to do now. Imagine if you take my case, I entered into the industry in 2013. 2013, I passed out. Year is 2013. So from my first organization, my experience started with big data only. So I don't have any other tech stack experience, like a traditional tech stack experience. I don't have. But we do have some viewers who is watching this video. Imagine that you've been worked in mainframes and now you are into big data. So you've been into some testing and now you are into big data. So in that case, do I need to add my old projects also? For example, now I am a big data developer, but 2 years back I was in mainframe. So you want me to add mainframe project also in this resume? Or you are a tester, so you want me to add my old testing project also here? So try to showcase that very less in your resume. So you have done like last 2 years you have been in big data, but before 2 years, like you have been like in mainframe for 3 years, or you have been in some other Oracle for 3 years. And if you want to showcase those old projects, try to mention one project. That's fine, one or two, because the more big data keywords and big data related stuff we have, the more the resume will come up in the ranking. That is what our goal is to. In the interview, you can explain all your old project is, that is fine, but when it comes to resume, don't try to add your existing tech stack, the very traditional old tech stack. If you think your tech stack is very old and you are not getting new opportunities in that, then in that case you should not add those tech stacks in these resumes. The reason why I'm telling you is, again, the page rank mechanism will not work when you upload it in the job portals, and that is also one reason why some people are not getting calls, because your resume is not coming up in the top 10 or top 20 or top 100. It's not coming. So that's the reason, that's the reason I'm telling you, please try to minimize the content of your existing tech stack and existing project detail explanation in the resume. Okay, that's an important point I want to tell you, so I've just shared you this information. So that is all about the resume preparation. So in the information what I have given, you can make use of it, but the design of the resume can be anything. You can the way like you are interested, you can build it in that way. Big data project. So one of the big data project that I have done in my previous experience, I'm going to explain you the architecture and audience for this video, right? So if you are a fresher, if you are a recent college graduate, you can still able to see the video, and you have some experience in industry. Like I have been in industry for 3 to 4 years, and now I'm into big data. I'm very newbie to the big data. Yeah, even for you, this video will be suitable. And if you say like, I'm more than 10 plus years of experience, can I still watch this video? Yes, you can also watch this video. And fourth audience, like you've been already in big data for some years, but still you are struggling to articulate your project in the interview. Even for you, this video will be very helpful. And people who already working in some data technology, so few things which I'm going to explain in this video will be more familiar for you, but still don't skip the video. I will recommend you to watch the video till end. Yes, we can jump into the topic. So here it's going to be the data migration and data transformation project. So my source, I just wanted to tell you my source. It's a DB2 database. It's an RDBMS. So here as a data engineer, I used to get the requirement from the client, right? Client or a BSA, right? We used to get the requirement. So here is the requirement. It's a banking domain. Just imagine it's a banking domain. And the client is asking you a report. The report should have in last month how many credit cards that we have offered for customers, and in that for how many credit card users we have announced offer, and again out of that offered customers, how many of them they have used the offer to purchase what product. So this is what they're asking. So they need to know how many credit cards has been offered for the customer in the last month, and how many have been announced an offer for their credit card, and how many of them have used the offer to purchase what product. So this is what the client is asking me, and this report has to be get scheduled on monthly basis for every month before 5th date, right? We have to hand it over to the client. So this will be like an automated process. It has to be get scheduled. I will tell you those part, all scheduler part as well I will tell you. So now you have to identify the source table, because the report what client is asking, this data will not be get stored in one single table. Am I right? So it won't be in one single table. If you see here, so we have so many tables in source. Like if you again go with the requirement, I will just go with the requirement again. So client need a list of customers who have been issued credit card. That means customer information and credit card information. There is 2 tables, and then how many of credit card user have been given an offer. That means there is an offer table, and how many of them used it to purchase what product. Now product table. So there is 4 tables that I have to get from the source, and I have to do all the joins and blah blah stuff, and then I have to give the report. Right. So first you have to identify the list of source table that you need to query. Okay, so now the data is in DB2, and I'm not going to do any transformation on top of DB2. So instead what I'm going to do is I'm going to bring those 4 tables data for the past 1 month. Okay, I'm going to migrate. So the component what I'm going to use to retrieve the data from database is SQOOP. SQOOP act as a data pipeline tool to bring the data from RDBMS to Hadoop, Hadoop to RDBMS, right? By the time you might have been heard about this tool, and you might have been worked in this tool as well. So here in the project, what we have done, we used SQOOP, and we just bought the data and we stored it in Hive. Okay, so this is how initially the project started. So we just stored the data in Hive. So again in Hive, like you can directly do after the storage, you just completed the storage part. You just queried the last month of these 4 tables, and you created a table in Hive, and you have stored it. Now, so on top of this Hive table, I have to do the ETL, that is transformation, extract, transform, and load. So the transformation is nothing, it's just the joins, subqueries, filters, and those stuff, right? So we directly queried Hive, and we have started giving the report to the client. So this is how it started. So roughly like the time of 2015, and in the end of 2015 and in the mid of 2016, till that time, people, they heavily used Hive. Without Hive, you can't see any big data project, and even now, without Hive, you can't see any big data project. That's why Hive is very important. So by the time when even Hive is part of big data component, but Hive supports SQL, even a lot of SQL developers, without knowing what is Hadoop and Hive, they started working on Hive because it's again SQL. But later what happened at the end of 2016, as I told you, end of 2015 to mid of 2016, by the time people started getting into Spark. Spark was there even before that actually. So it was even before 2013 actually. But the thing is, people started using Spark with Hive by the time of 2016 mid. People started using a lot. So what happened? So initially people started doing all the transformation with Hive, and they generated the report. Now I'm not going to do the ETL in Hive. So I'm just going to use Hive just for storing and just for querying purpose to see the data. That's it. So I'm going to do the transformation with Spark. So we introduced Spark into picture. So you can explain it this way. So you can say that if you say that you have 2 years of experience in big data, you can say initially the project what you have done is we started Hive only for transformations. And then later we started a POC to introduce Spark into picture, and then the POC has turned into project. So this is how you can explain, right? Step by step only the project will get mutated, right? So you can say initially you have started with Hive, and then you introduced Spark into picture. Okay, right? So in Spark, like we have Spark Batch and Spark SQL. Okay. So here initially in Spark, when we decided to do the ETL, the transformations, we started with RDD, and then we moved on to data frames. In Spark SQL, we have data frames and data set, which is very good compared to RDD with respect to performance. So how Spark is very good with respect to performance compared to Hive, in the same way within Spark compared to RDD, data frames and data sets are more performance. It has more performance. So we started doing all this, and the transformation is completed, and you are reading data from Hive. Okay, you are reading the table from Hive, not from DB2. Very important. You are reading the data from Hive, and then you started doing all the transformation. So okay, here is the question. You can ask me why Hive. I can, if we are not going to use Hive, then directly we can query DB2 itself, right? Yes, Spark supports it. Still, you can connect directly and you can read whatever the tables you want. The thing is, like DB2 is not free. So the connections that you create with DB2, it costs for it. Okay, that is one thing. And whenever you go with the doing transformation within big data family, right, it will be very faster, and that's the reason we first bring the data to a storage, and then we are doing the transformation. But I have seen some use cases where people directly query RDBMS. Yes, that is also supported. for some reasons, maybe in upcoming video series I will explain you that, but now we are not using the straight way of doing it. Okay, I will just remove this one. So it's like you are reading from Hive and you are doing all the transformation, and finally we are giving the report to the downstream. So downstream can be a non-technical team or they could be a technical team. So imagine if this is a non-technical team, then I'm giving the report as a file to the bankers, to directly to the bank employees, right? I can give they are non-technical, they just need of my file which I have the report, that's it. Imagine if they are a technical team, that is there is another development team to which I am giving this report. So what that team will do, so in my case we handed this report to another technical team. It's again they are also an data engineering team only, but they use visualization to project the report. So we are not taking care of any visualization. So what we did is we generated the report, a Spark output, so this report. So what we have done, okay, so we just this report we stored it in a Hive table. That means the target table is Hive again. So that means the source is Hive for Spark, yes. So there here we have a database called source where we store all the source table, and in the same Hive we will create a database called target, and within the under target database we store all these report as a tables. So monthly wise this Hive table will be get loaded, because that is what the requirement from the customer, right? If they ask for weekly, imagine for every month 5th they need the report. So every month on or before 5th the data will be loaded to Hive, or they are asking weekly, then weekly this Hive table will be get loaded. Okay, it depends on what frequency they want the transformation and data to be get populated. So now this report we have stored it in the Hive. So this Hive table, the target table, is what we will be giving to the downstream. So this downstream, again they use a visualization technology called MicroStrategy. So they use this MicroStrategy to project to the customer in the some chart format. Okay, so they read the target table from here. Okay, they are not going to do any kind of transformation. They used to design the charts in MicroStrategy. So we as a data engineer team, we used to do all the transformations. Okay, fine. So here as I told you, the Hive part, like the table which get loaded based on the frequency what you say. Now how come this happens, how we will deploy this project? Okay, I will tell you that. So if it is Hive, right, then it's fine, just directly SQL file you can place it in the production, and you can call this SQL file by writing a shell script or Python script. We need some invocation script, right? And okay, you imagine you are writing it in a shell script. So within shell script you invoke this SQL file, and this shell script file is what you have to, the shell script and this SQL file you have to place it in your cluster somewhere. That's it. So here we are using Spark, right? So if you are using PySpark, then it will be the .py file, or it is Scala or Java. If you use, then it is going to be a jar file. So you have to call this jar file within this. See, if you are using .sql, then in the shell script you have to call .sql. So now we are not going to use this. So we are going to invoke jar file, and this jar file will do all the Spark transformation. So in the shell script, I will write a Spark command to invoke this jar and start execution. So here, this shell script you have to place it in your cluster somewhere with this jar file. Okay. So now we have to use scheduler. The reason why we need scheduler is client needs this job to run for every month once, right, or every weekly once. Then we need a scheduler to do this. I can't do manually, right? So some famous scheduler. Okay, I will tell you what scheduler that I have used, Autosys. And similar to this, you have something called active batch and control M, etc. Control M, Airflow, etc. So I used Autosys. So in Autosys, so all these schedulers are a different team. You don't want to worry about what is these tools, or you just need to know, okay, they are schedulers. That's it. So even in the interviewer, none of the data engineer will ask you like, how about Control M, or how about Autosys, what internally so and so stuff will do. No one will ask you. And even if they ask you this, you can simply say scheduler has been taken care by a different team. So here, that is the reality actually. So this Autosys team will ask you some informations like where you are going to place the shell script, and where you are going to place the jar file, and in what frequency we need to invoke this. So all this information they will ask you. You have to hand over all those information like script path, jar path, and then the frequency information and so on. So they will give you some Excel sheet or some online form will be there. You have to fill it, and it goes with an approval, so on so stuff, and then it will get approved and scheduler will get started. So what this Autosys will do, right? it will invoke the shell script which you have placed in your cluster. So this shell script will invoke the jar file which you have placed in the cluster, and this jar file will start your Spark execution and the movie starts. Okay, so all the transformation get completes, and then the report will be get stored in the Hive table once the job get complete. So all these schedulers will have some sort of UI or log where you can find whether the job has been completed or not. So with that you can just query your target table to see select count star from, that's it, right? So you can see whether the data has been populated for this month, and if it is done you can inform to the downstream, and then the downstream will query it, and they will use some kind of a visualization tool, or it could be a file that they use some different technology to do whatever transformation they want, or they could be another data engineering team. I'm giving the report to them. On top of that report, they are going to do some transformation. Okay, it's depends on the downstream. So it's always good to say that you are giving to someone who is taken means it's always like you can tell that your downstream is a visualization team, because that's where the picture ends. Like, okay, so if you say that you are giving this report to another data engineering team, then they will ask you like what that team will do. Okay, so again we need to know what transformation that they are doing. It depends, again it's there, like the cases are there, but it's to make it so simple, tell them that your downstream is a visualization team in which you will give the report as a Hive table, and they will do all the transformation, sorry, not transformation, all the visualization stuff with the Tableau or MicroStrategies, blah stuff. So in my case we used MicroStrategy. Okay, and here comes the information, like there will be three cluster environments you will have. First, you will initially develop all your Spark code things, everything in your local laptop, in your office laptop, right? And then you have to move the jar file and script to dev environment. So dev, this environment is again a cluster, 20 node cluster or 10 node cluster. You can say up to 30 node cluster. Dev will be always very small. And then once development is completed, we will move this jar file and shell script to UAT, user acceptance environment. It's a test environment. So in develop itself, in the develop environment itself, we do all the testing too, but still there will be another testing environment. So you have to run successfully on these two. Again, in this cluster, you will have Hive Spark and so on so stuff. Again, you will have Hive Spark and UAT as well. Datas will be different. They are like mock data. The input data, what you will have will be dummy data, and production is where you will have the real data, and then you have to move the shell script and jar file to the production, and this scheduler team will take care of doing scheduling in all these three environments. Just you want to tell which environment the scheduler has to run. If you say all the three environment, then they will take care of all the three. So when it goes to production, you have to get the solid approvals and clearance, like you have to prove that your code is good and your input is good and your output is as expected. Okay, so again these three environment will, the cluster configurations will be different. So you can say like 20 plus node in dev and 20 plus node in UAT, and if you say like, always try to say more than 50 plus node in the production environment. But I have a separate video for cluster configuration and dev production, so there will be a separate video, so you can find that in the description box of this video. If the video is not there, please do wait, I will upload soon. And here, and one more, the last point I want to tell you is, so if some issue that downstream identifies, for example, they are just query this target table and they find there is a null value, and the downstream is very sure that this particular table and the particular row should not be null. They are very clear about it. They said there is no possible of having null values, and that means there is a problem with the code. You have to check. And if you see there is no problem with the code, then you have to check the source in Hive, right? So this is the first source, right? And this first source you have used SQOOP to bring it to Hive, right? So here you have to check in the source itself. If you see null, then you can tell them that in the source itself it is null. Okay, now downstream is telling another point. In the source also it should not be null. And that means you have to check the DB2 directly. So you can ask me, like, the DB2 data is what we migrated here, right? If here it is null, then in the source also obviously it will be null, right? So no, it won't be in the case, because like when we migrated it, sometimes in between some problems can happen. Maybe in the SQOOP when I do migration, some problems might have occurred, right? So we don't know. So if you see null here and still like your downstream or someone from the team saying that the source should not be null, I doubt it. So that means you directly check the DB2 tables. you have all the information to query the table, right? If you have the access to query the db2 directly, you can do, or you can send an email to the concerned source team to check whether that particular row is null or it has the data in the actual source itself. In the actual source itself it is null, and there is no problem in your migration. The problem is with this, you have to inform to the downstream saying that in the actual source itself it is null, and there is no issue with my code or in the my migrated data. Okay, then downstream has to check with their own team, like why it happens, all those stuff. But thing is, if db2 has a good correct data, there is no null, but in our Hive there is a null in the source, means when you have done the migration, something you have missed. Okay, so why I am telling this, right? And high level of some issues what we will face after we load the target table. After all the transformation is completed, this kind of issues will come. Okay, so not only null issues, they will say the value is wrong, the output is not expected. So that case you have to check your source. Immediate source is your Hive and the actual source is your db2. Okay, so that is what I want to tell you in a high level of thing. Okay, so as I told you already, there is a video called top 10 things that you should know, top 10 points that you should know before and after a project. So there is a video in this title. Please, I recommend 100%, I want you to watch that video first and then this video. If you haven't watched that video, please, the link is there in the description box of this video. Please do watch it, because that video will help you a lot to articulate your project. That's very important. In every video, project series video, I'm going to upload a lot of project use cases in my upcoming video series, and for all those videos, the top 10 points before and after project is very important. Okay, so that I cannot repeat in every video, right? So that's why I have made it as a separate video. So that link is there in the description box. Please do watch that video and then this video. Okay, and if you merge these two videos content, you will get a clear idea of how to articulate the project. And you might have think that whatever the tech stack that I have used here is like very common, and you think the project is very simple, but this is the reality. So the 80% of any project, big data project you go, they use Hive, Spark and Spark SQL. That is what 80% of project you will see. So this Kafka part, Spark streaming, and then NoSQL database, it's there, but only less projects are using it. But still, I'm going to include those components also in my upcoming video as a project, different project architecture with those components also. But if you are very new to this industry, you are a newcomer, you are a newbie, then this video is completely enough for you to enter into the big data environment.
Very important topic. If you are a data engineer, and this video will be very useful for you. So how to make a second income in data engineering part itself. So you are a data engineer and you need a second income in the same data engineering itself. So I'm going to give you 4 important points which is very good for you to do it. So in this video, whatever we are going to discuss, it's not a short term or something like within 7 days or in 28 days or in 2 weeks. It's not like that. So we're going to build a platform to make a second income. So it takes time for you. So whatever the 4 points which I'm going to tell you will take time, for sure it will take a time. So minimum 6 months to maximum 1 year it will take. And people who have less than 8 years of experience, this video will be very useful for you. And people who have more than 10 years of experience is also completely fine to have this video and to have such platforms. Build it for you. Okay, let's get into the topic. So the very first thing what I'm going to tell you is very familiar for you also. Try to write blogging and try to make vlogging. So when I say blogging, so you just have your own website or you just go to Google Blogger and create your own blog post and start writing some data engineering blogs or start writing some content, some tutorial, something like that. So after some time, you can integrate your website or Google Blogger with Google AdSense so that Google will advertise some ads in your website, and with that you can make money. Okay, so this is one thing. And second thing, when I say blogging, make blogging. Blogging means video blogging is called blogging. For example, making videos in YouTube. Okay, so you make videos in YouTube. Example, so if you take my channel Data Engineering, so for now, the current date, I have 86k subscribers, okay, and I used to get advertisements from Google AdSense, so I have videos, I integrated my YouTube channel with Google AdSense, now I'm getting more videos, I have more videos and I'm getting more ads on top of it, I'm making money for it. So now these two, blogging and blogging, gives you money. So apart from this, what else you will get from this? So you will be getting publicity. That's very important. So whenever I attend some interview, in my resume, I have mentioned my YouTube channel name, and that really makes the employer to select my resume for the interview. Okay, and whenever I go for an interview, people are asking me what channel it is and what content you do it and how long you are doing it. So they get impressed. So that is also an important point we need to have actually. So blogging and blogging. This is the very first thing. And the second point is freelancing. You have to make some for freelancing things. For example, so there is some small startup which requires you some work like per hourly work or 1 day work or 2 weeks work, something like that. You can just pay for how many hours or how many days you've been with them. Imagine there is a request coming to your email asking for I need a Hadoop cluster to be get set up and Hadoop cluster environment need to be get created like 20 nodes. You just go there and create the cluster and get the money. Okay, so hardly you can charge for it. So freelancing is something like you can. There is an websites like freelance.com, elance.com, upwork.com. So I will just mention these websites in the description box. Just you can create your own freelancing profile. So freelancing is not only we can get only through these websites. Even if you take myself, like I'm getting a lot of freelancing work through my LinkedIn message. Okay, so even in your LinkedIn, if you have a LinkedIn profile, very great, and people used to approach you through LinkedIn also, even Facebook. Okay, so some people will ask you for work. You just do the work and you'll be get charged. So this is one thing. And the next thing is, because data engineering is a very, as of now, it's a very demanding skill set, right? People are there to get training from you. Okay, you can give online training, or you can make videos and you can upload in Coursera, Udemy, from which you can get money, similar to what I said in YouTube, right? And you can make one-on-one session, or you can have some group of people. You can give them training, prepare a course content, and a lot of practical stuffs. It again involves a lot of time for you and a lot of energy to do that. It's one-time job. You just prepare material, course content, and everything, and then you just get an audience, and you can make training. So how will I get audience? Okay, that is where I told you the very first point, what I told you, blogging and blogging, which gives you more audience. So if you take, currently I'm not taking any online stuff, but I have been before. I've been taking online classes and classroom trainings also. But how come people approaches me is through my YouTube channel and through my blogging. People approaches me because my content is already there as a proof, and people are they loved it and they are approaching me. So that is what the step by step I'm telling you. So first you have to be in public and you have to provide your content for free, and then people will come back to you and ask for more content, and they will pay for you. And that is where online trainings and sessions I'm telling you, or you can make videos in online platforms like Udemy and Coursera also. And the last thing is, you can take some seminars also. So there are some companies and universities and colleges, they will invite you as a guest and they will ask you to give 1 day seminar session, like theoretical, or 2 days of practical session. So for that they do for per day basis like 10K, 20K, something like that, based on the company and university. So this is also a kind of income. So these 4 points, it's not whatever I told you, it's building a platform actually. Each points are interrelated. They are not giving you they are not only giving the money, it also giving you the fame, the publicity, which is very useful for our personal growth when we go for some interviews or some career change to a new company. So that is very important. So this is what the 4 points I just wanted to discuss with you.
Big data project deployments. So recently I got questions from my viewers like how we will deploy the project in production. So how I will move my code to production. So one guy asked me this in interview. They have asked me this question. So I have explained my project. I have explained all the interview questions. But finally, when they ask me like how you will deploy it. So he was very new to this tech stack, but he has good experience. But still, when it comes to deployment, he was not aware that much to answer the question. So now I'm going to explain you how to deploy a big data project. That means you have a code, a Spark program, or a MapReduce program, or a Hive query file. So how you will move this to different environments and finally to the production machine. Okay, so now there is like 4 environments you will be having in general. So the very first thing when I say environment is your personal laptop. Okay, and then the actual real clusters, you will be having 3 real clusters. One is called a dev cluster, and then test cluster, something called sometimes called as UAT, user acceptance test cluster, and then finally you will be having the prod environment production cluster. So all these 3 are like a cluster, it's group of nodes, and all these are Hadoop clusters only, but you will be having 3 environments. The very first thing, let me go with only Spark code or HQL, whatever. You can replace my Spark code with HQL, whatever. Like I will go with Spark code. So I'm going to develop a Spark code. If it is a PySpark, then it is going to be a py file. If it is a Scala or Java, then it is going to be the jar file. So let me go with the jar file. Okay, but you can replace this with PigScript or Hive, whatever it is. It's going to be the common story actually. So in the laptop, I have my IDE like IntelliJ or Eclipse. You develop your Spark program. Imagine I'm writing a Spark program to read data from tables from MySQL. Okay, so I have 2 tables, T1 and T2. I want to join this in my Spark program, and then I have to get the output, and this output will get stored in another table. Or maybe in Hive, the output is going to get stored in Hive. Okay, this is the case. So in my local environment, in my laptop, what I'm doing is I have MySQL in my machine. So I've just created a table, and then I did a join. And then finally I'm doing a show because in my local machine I don't have Hive, but it's possible you can install, but that's fine. Anyway, you can test that in dev environment, so you can skip that in your laptop. So in laptop I'm just giving show and I'm just checking my output. So or even if your MySQL is not there in your local office laptop machine, what you can do, you can create a test file. Okay, or we have some test framework in which you can create tables, mock tables as a file, and then you can do a join and you can test all those stuff. So in your local laptop, whichever method is possible for you to populate the input file, you try to do in that way and test it in your local laptop first. So once your code is ready and it is working fine in your local laptop, then build the code as a jar file, and then you have to move it to your development cluster. So this is your dev cluster. So in the dev cluster you will be having some folder structure in which you have to place the jar and you have to trigger the Spark submit command. So if there is no table structure, folder structure, try to create one. So imagine I'm working for a company called ABC Insurance. Okay, so for this client I'm going to run this particular module. So this module is called user module. Imagine in that way. The code what I have written is for user. The module name is user. So here I will be creating a folder in dev. I'm going to create a folder as ABC Insurance, and again within that folder I will create one more folder as user, and within that user I'm going to place my Spark jar file. Now I am going to prepare a Spark submit command with all the memory properties and dependent files, whatever, etc. I will create one Spark submit command and I will trigger the jar file. Now you will get a question like, in dev environment, how will I get the input files? So in dev test and production, you will be having your source system ready already. So MySQL is the source, right? So in dev environment, you will be having MySQL installed, and input tables will be also available. So there is two way in which you will get the data in the lower environment. When we say lower environment, is dev and test is called lower environment. When we say upper environment, it is production. So the terminologies, the jargons will be different from company to company. So don't get confused. So I will use the word dev, test and production. That way I will use. So in dev and UAT, there will be a team, okay, in which they will populate the data for us. And very important, in the dev and test environment, the source data is not the real data. It's not the production source data. That is very important. So I need a source. MySQL is the source. If my tables are there in MySQL, then only I can test my Spark code. So in dev and UAT, you will not see the real data, the real actual business data you will not see. So there will be a team which will populate the data for you for the testing purpose in the dev and UAT. If there is no such team, you can populate the data, you can create a table and you can insert some records to it, but mostly you will be having a team. So that team will have some name, just identify it. So or you can use some names as well. So that team will populate the data for you, or you can inform to them, I need a data for this table. So they will just generate a data generator tool they used to have, and they will generate the data for that particular tables. Now imagine in dev and test, the input data is ready for me in MySQL. Now the Spark submit, when I trigger in dev cluster, it is running fine, or sometimes you will be having some error with the performance or some syntax issue, which in your laptop it was not there, but when you move to dev, it is there, because it's environmental change, right? So that is the reason why we have to test it by environment by environment. Okay, so in dev cluster you have to check the performance as well. That is also matters. Okay, now once it is done with the dev cluster, okay, you have to move it to UAT. So UAT means user acceptance testing. So once you have done with the dev environment, if everything runs fine, you can check with your lead or someone, and if they say okay, your code is good, move to UAT, then you will get an approval, so you can move this to UAT. So in UAT, the user will, so same, you will be having a folder again like ABC Insurance, and within that you will be having an user folder, and within that you will be placing the jar file and generate the Spark submit and run the code. Once the output is generated, you ask the user to validate the output. So if user says okay, I'm good with the data, so now you are eligible to move this to the production. But I will halt here. So before getting into the production part, I want to explain you one more important thing, that is scheduler. So scheduling is a separate team which will help you to schedule your jobs. Imagine this particular jar file has to run for every 1 hour. So I cannot manually come back every 1 hour once, and I cannot trigger the jar file, right? So imagine in dev, UAT and production, the jar file what you are placing needs to be get executed for every 1 hour once. So that means I cannot manually do that. So I will be having some scheduling team to which there will be a team to whom I have to say, like, this is my jar file, please trigger this jar file every 1 hour once with the Spark submit command. So this is what I have to inform them. But how you will do that, right? So scheduler means you will be having a lot of schedulers, like you have schedulers like control M, autosys, active batch, and airflow. So there are so many schedulers, and it's not important that you need to aware of all the schedulers when you go for an interview or to a new project or new company. So the schedulers is always like kind of not mandatory skill set for the data engineers to learn these things. It's not required, but if you learn it, that's fine. But for schedulers, there will be a separate team for 100% sure in any companies you go. So this scheduler team, for example, if you pick autosys, the autosys will ask you for few details. So where from which folder, from which script, for the which jar file should be get invoked, and all those information the autosys will ask you through some form or some web form. They will ask all this information, and they will ask also like how many hours once this has to be get triggered, and like if some issue comes, to whom we have to contact. So they will ask all this information. You fill all this information and give it back to the scheduling team, and they will start the scheduler. So very important thing is in your projects, right, in dev or UAT or production, you should not manually prepare the Spark submit. You have to write one script. Okay, so imagine I'm going to write a start code.py, or it could be a shell script, anything is fine. So this shell script is what, this Python or shell script is what will generate the Spark submit, and that is how you have to prepare one script. Okay, so this script will prepare the Spark submit. Imagine you have 100 jars, Spark jars, and you cannot manually generate a Spark submit for all these 100 jars, or if a new jar adds in future, you can't do it, right? So you have to write one shell script or a Python script which will take care of generating the Spark submit, or if it is a HQL file, it has to take care of generating that hive-f command to run your HQL file. Okay, so just create one base script, and this script is what you have to hand over to the scheduler team. So to the scheduler team, tell them please trigger this script for every 1 hour once. That's it. Autosys team will not come to know what is inside and what Spark submit or whatever it is. They will never come to know. Just give them this script, and script whenever 1 hour once, whenever the Autosys is triggering the script internally, the script will execute and generate the Spark submit, and it will run the code. That is how it has to be. So now this script, you have to again place it in your cluster somewhere, create a script folder and place it in all these environment, and inform the scheduler team. They will take care of it. And as I told you, I'm repeating it again. You don't want to worry about which scheduler you are using and what about the questions that I will get from scheduler. In interview, you will be getting only one question: what scheduler you have used. That's it. And in what frequency you will trigger the job. That's it. So don't worry about the scheduler part. Fine. So now when you go for production, so user said everything is good, the code is good, the performance is good, the output is also expected, you can move the jar file to production, but you will be having some process to follow. Here you have to get a lot of approvals to move this jar file. So I'm explaining the process also. The process depends to company, but in general I'm telling you the process. So we call it as a change request. So whenever you move something to production, there will be a process called a change request team. So this change request team used to monitor like what are all the scripts are coming to production, and with that new script or new changes or new jar file, what impact is gonna come for the code and the project, and what is the business justification. So this change request team used to ask all these questions from you, and also they will ask the approval mail or approval stuff from your client or from your managers saying that the code is good and everything is good. Then the change request team will approve it, and once they have approved it, then you have to move the jar file to the production. This is how it happens. So the process, like, it depends actually. So companies to company it will change, but change request is a common process across the company, but the process within the change request may differ. So this is again a new other team to which you have to interact, and you have to raise a CR. We call it as a CR in short form. So once the CR is approved, your jar file will be placed again in the same directory structure like ABC insurance, and within that you have user folder, and within that you have the jar file. Now again, this script will be available in the production also. Inform that to the Autosys team, and in production also the Autosys team will take care of triggering your code. Now once your code has been triggered and it is running good for 2 days, and finally in the third day you are getting some issue with the code, then there will be a team called support team. They will monitor your jobs, and if some issue comes, the support team or the ops team, we call it as an admin team or support team, whomever it is, they will inform to the data engineering team back, means to you and your team. They will inform that this is a code which got onboarded 3 days back and now it is causing an issue, please check. You will be getting an issue will be assigned to you. So any jobs that runs in production, when failure comes, the issue will be assigned to the development team, so they have to take care of it. So once it is done, again you have to, okay, so there is an issue occurred and you identified what is the bug and you are doing some code changes, and again you have to push the code via dev, test, and then production. With all this process you have to follow. So whenever in the interview someone asks you how you deploy it, you have to explain this in short.
Something very important for all data engineers to follow. So how can I get the latest information about data engineering, or latest news, or latest updates, or live updates, or latest big data, data engineering related project architectures and use cases? So this is very important, apart from what technically you are strong. So if you want to be a solution architect, or you want to give some solution, or you want to be a very good freelancer, you are doing a freelancer, then you need to give a very good solution or something like this. So how can I get all these information? So how do I gather all this information? So that is what I'm going to explain in this video completely. So please do watch this video. If this information was something like already you are aware of it, absolutely fine. But if it is something new, please do watch this video completely.
Okay, so now I'm going to share you few links which will help you to improve your solutioning skill. So here, these are some links which is from various companies actually. So they're engineering blogs. So just go to Google and just type Facebook engineering blog. So you will get their engineering blog. So for example, if you see here, so this is Facebook engineering blog. Just go to Google and just type Facebook engineering blog. You will get this site. So in the search box, you just search for data engineering keyword. So if you search for it, you will get all the blogs related to the keyword what they have with the data engineering, because they have a lot of other tech stacks also. They have written as a blog, right? We have to filter out only the data engineering blogs. So if you see here, I have similar links here. So the very first link is engineering blog of Facebook, and then the second one is PayPal engineering blog, and then Uber engineering blog, and then Google, Databricks, Cloudera, Amazon's engineering blog, Netflix, and then LinkedIn, and then Oracle, Stack Overflow. So these are some engineering blogs which I used to follow. So after I enter into this URL, I will search for data engineering related blogs only. So for in a week, just take 1 week and just follow one company's engineering blog with the keyword of data engineering, filter it out and just learn it. So for sure, I'm telling you, 100% I'm telling you, when you start reading the blogs, it will be Greek and Latin. So you will not understand anything at the very first shot, even though you are a data engineer. Okay, this is what happens. So don't get back. Okay, so please continue, so that at least at some point of time you will come to know something, right? For example, you are reading some blogs and all of a sudden there is a new tech stack they have mentioned and you don't know what is it, and you will search for it in the Google, right? At least you will come to know something. So that is how your solutioning skill set will increase. Okay, so that is very important. So this is not only for a 10 years experienced guy or more than 5 years experienced guy. Even if you are 2 years or even if you are a fresher, you are sitting in the meeting room and you are discussing something very importantly, and all of a sudden you can give a solution if you have that in your mind, right? So that is how it helps. So it's not like this video is only for experienced candidates. It's not only for them, it's even for you, and also it will give you the solution problem solving things, right? Already these blogs have written their problem and the solution. So if you know that, so that you can answer it in your team meeting when there is a problem, right? So this is what I'm following, or whatever the engineering blogs that you have in your mind, you can search for it. For example, Spotify engineering blog, you can, whatever the company you get in the mind, just add, go to Google and just add Spotify engineering blog. Just add the word engineering blog and you will be getting their website, and go there and just filter out data engineering. So, and I want to give you one more link called this Data Eng Weekly. So Data Engineering Weekly, short from ENG. So this is previously the website name was Hadoop Weekly, but now they have changed it to dataengineeringweekly.com. So what this website gives you is, if you subscribe to this website, right? So let me go to the home page. So if you just subscribe to this, right, so they used to send you a newsletter every week. One newsletter you will receive one in a week. So that newsletter will have top 10 latest things what happened in the data engineering field. For example, if you don't want to subscribe, that is fine. Just go to this latest issue, so in which you can able to see the list of so if you see here, data engineering week 356, they have written some top 10 issues. And if you see here, what they have actually done is they have just given the description, short description about the news, and then for reading more you have to follow this link. So one more thing I want to tell you here, in my many videos I'm asking my YouTube followers to write blogs to project them in the interview. That will give you an added advantage if you mention that in your resume that you are a data engineer blogger. So I'm asking you to write such blogs. So if you see this particular guy, what he has written, he's just given the 10 lines description in short, and then he's giving the link for read more. That's it. This is what I'm asking you to do it in your LinkedIn. So just go to some other engineering blog, just whatever you have read is interesting, just share it in your LinkedIn and make it as a blog post, or you create a Google blogger and you can write it and add that in your resume. So I just wanted to tell that. Suddenly I got it in my mind, so I'm just sharing with you.
Thanks for watching this complete course, and if you really like this video, please do subscribe my channel and forward this to your friends and colleagues. So we do have a lot of data engineering videos in our channel, and we are keep on uploading new videos as well. Thanks for watching.